topics. I have taken one of those topics and trying to share my understanding of the same and the possible research problems that could be explored on this topic. And it is an iota of what I have been reading on these topics and sharing with you. And I humbly request you all to pardon me if I make some mistakes or anything. And before I start my presentation, I would like to thank Professor Ramakrishna for introducing me to this audience. So thank you very much. Now kindly permit me to share my screen.
Yeah.
Okay, ma'am.
Madam, what you are talking today, orthogonal arrays, is the first of his work, C.R. Rao's work.
Yes. Yes. So is my PPT visible, sir?
Just wait, madam. It's coming. It's coming. Yeah. Now it's visible.
Okay.
Make it full mode, madam.
Okay.
Yeah, good.
Okay. So thank you. So I want to share whatever I have learned in this last 2-3 weeks about this orthogonal arrays and their applications. I am Rajeshwari Seshadri. So before we go into this, actually I was trying to look at from the mathematical point of view, what is the mathematical richness I can add to these concepts of orthogonal arrays. But what we have seen in most of the literature is its definition and its application to various statistical processes and design of experiments and testing and so on. So, but if I try to go into the mathematical application of this, it is going too much into algebra, Galois theory, and permutation groups and other things. So I would definitely, because it's 90% of statistics audience, I restrict myself to too much of mathematics into this. But I'm really enjoying, after going through so many concepts of this related to mathematics. So I will keep the application towards the mathematics line minimal. So we will just see. I'm sure many of you will know, but as a matter of routine, I will just want to define what is it. And some of them who have not studied about this topic, I just want to give a brief idea of what it is. So an orthogonal array of strength T with n rows and k columns, where k should always be greater than or equal to T, which is based on S symbols, say 0, 1, 2, S minus 1, so that every n cross T subarray contains each of the S power T possible T tuples equally often as a row. So that equally often may be, say, n times. Okay, so n must be a multiple of S power T, and the lambda can always be given in terms of the other parameters n S by S power T, which is called the index of the array. And mostly in literature, orthogonal array is prominently expressed as OA of NKST, where NK, S and T are its parameters. This is, I have highlighted in blue because this is more often used compared to few other notations available. Okay, and as Professor Tirupati Rao rightly mentioned, this is one of the first concepts introduced by Professor C.R. Rao way back in 1946, I think during his PhD days. And he has published three papers on this topic, 46, 47, and 49. And its applications in the use of fractional factorial experiments. See, generally, I wouldn't like, starting giving a definition in a more discrete manners like this. Okay, so what are the parameters involved on the orthogonal array n, k, s and t are given by n typically represents a number of rows in general, but when it comes to application, it may represent a combinations of runs or number of experiments or number of tests and so on. And k is the number of columns as far as mathematicians are concerned, but when it comes to application, it may represent a set of constraints or set of factors or set of variables. And S represents just symbols for us, but it's in general, it will represent for the application of point of view different levels. Okay, and T represents the strength, which is used for the factorial experiments. So the strength T of an orthogonal array is related to estimability of parameters under certain models when using the rows of the orthogonal array as runs in the experiment. Okay, so why is it called orthogonal? What is orthogonality there? When we call it as orthogonal array, we will try to explain what it is. So, as of now, when I just gave a definition like this, I'm sure those who are not aware of orthogonal array may not follow it very clearly. So I would always want you to break into finer units. So as usual, we will start with the simplest of the example. So I'm going to take a simple orthogonal array of 4, 3, 2, 2. So we know that NKST. Just remember NKST, these 4 parameters. So this first one represents column, second one row, third one is level, fourth one is strength. So I claim that this object, a matrix of the form 4 rows and 3 columns, 4 by 3, is called an orthogonal array. So why do I say it is an orthogonal array? Because it has 2 levels. When I say 2 levels, what is the distinct symbols used in writing the matrix? That's all it means. Okay, not the value. It could be, instead of 0, 1, it could be +1, -1, it could be 50, 100, or it could be X, Y. It doesn't really matter. Okay, so it is just the number of distinct symbol we use to represent the members of the elements. And what do I mean by the strength? So this is where it plays an important role. This is the strength of the orthogonal array, I should say. So that's why it may have been named as strength also. So by the strength of the orthogonal array, what do we mean? We can, am I audible, sir? Hello?
Okay. Madam, audible, madam. Okay. Audible, madam.
Okay. So by the strength of the orthogonal array, we mean we can pick up. So here he say here the value says it is 3. Okay. So when I say 3, what does it mean? What does the number 3 represent here? In the given match, sorry, I am still in the first one. Here the strength it says is 2. Okay. So by 2, what do we mean? Out of the 3 columns, we can pick any 2 columns, please remember, any 2 columns, which could be either C1, C2 or C1, C3 or C1, C3, such that, okay, when you explicitly write it like this, so I'm picking only C1 and C2, C3 is left out in this case, C2 is left out, C1 and C3 is written here, and C1 is left out, C2 and C3. This is the possible combination, right? There are 3 columns available. I want to pick up any 2 columns. These are the 3 possible cases available. In all the cases, you will get these 2 symbols 0, 1 to the power of 2, whatever is the t here. This is the power 2. So when you take 0, 1 power 2 means 0, 1 cross 0, 1. So when you take the cross product, I'm expected to get only these 4 combinations, right? 0, 0, 0, 1, 1, 0, 1, 1. So this 0, 1 power, the strength always appears as many times in this all columns. You get that? So this is what we mean by saying strength. When I say strength is 2, I should be able to pick any 2 columns from the set of columns available. And in each of those cases, this level power strength will always appear as many times, equal number of times. That's also very important. So here you see that 0, 1 power 2 is 0, 0, 1, 0, 0, 1, 1, 1, which has appeared exactly once, all of them. So this is said to have this orthogonal array is said to have a strength of index 1. Sometimes you may have 0, 0, 0, 1, 1, 0, 1, 1 once again. Then we will said to have a strength of index 2. So this is the simple idea of the orthogonal array. So let us illustrate with one more example. So here we have an orthogonal array with 8 rows, 4 columns, 2 levels, and strength 3. Okay, so 8 rows is clearly understood. I have 8 rows in the matrix. 4 columns, I have 4 columns in the matrix. 2 represent the levels. Again, you have only 0 and 1, so 2 levels of symbols. Here I am saying the strength is 3. So by strength 3, then I have to immediately look at 2 power 3. What is 2 power 3? 0. Sorry. Okay, so this is between 0 and 1 in terms of 3. So how many possible things I can get? I have 4 columns, C1, C2, C3, C4, 4 columns, out of which I should be able to take 3 at a time. That's why the strength is 3. Okay, so what is the possible combination? 4, C3. So there are 4 of them. I could take C1, C2, C3, or C1, C2, C4, or C1, C3, C4, or C2, C3, C4. In all the 4 cases, you will be able to see that the 2 power 3, 8 orders 0, 0, 0, 0, 1, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1 appears once. So this is also, this pattern you will be able to see in all these 4 set of sub-matrices, sub-arrays, what we call. Okay. So this feature and this rich property will be repeated in the orthogonal array. Okay, the strength 3 will tell you I can pick up any 3 at a time and I can visibly see this property present in the subarrays. So this is what is an orthogonal array. And one more thing, here you have a very simple orthogonal matrix. You have just 2 rows and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns, right? So 2 rows and 12 columns. And when I say 2, again 2 symbols, 0 and 1, only 2 symbols. 1 means strength is only 1. That means what am I saying? If you pick 1 column at a time, the levels will appear once. So if I pick any 1 column, 0 and 1 are anyway the level, so it's appearing 1. That is happening in all the single column when you pick out. So this is the orthogonal, trivial orthogonal array of strength 1. Okay. So here n is 2, k is 12, s is 2, t is 1, strength is 1. Pick any 1 column, you can see 0 and 1. And because this is of index 1. Okay. So this is about the orthogonal arrays. A simple definition. I hope with this simplest of the illustration with these 3 examples, we have got an idea of what is an orthogonal array for those who have not heard about this topic. Okay. So now we can see a very simple exercise. All arrays are given as transpose in the transpose form in order to save the space. And also, typing is a little easier. So when you look at this, for example, I have 4 rows. That means it should be 4 columns because I'm saying it's a transpose. I'm saying that it's a transpose form is given. Similarly, there are 14 columns are there, so it should be 14 rows. Okay. And why do I say levels is 4? There are 4 distinct elements, 0, 1, 2, and 3 appearing as any member of the interior elements of the array, right? So 0, 1, 2, 3. These 4 are the distinct elements. So the level is 4. And I'm saying strength is 2. So what do we mean by saying strength is 2? That means 4 power 2. If you take 16 of those elements, you will have that 16, 0, 0, 0. If you take any 2 after time among this 0, 1, 2, 3, all of them will appear in that column, 2 columns. Okay. N cross T subarray, you will be able to see all of them. Okay. And please note that there are only 14 mentioned here. So it should be 16, right? So you can always construct the left out, like, you do in your statistical, this thing, missing values. Similarly, if in 1 or 2 orthogonal arrays, some rows or columns are missing, you can also fill in the missing rows and columns of the orthogonal array by knowing its property. Okay. Similarly, the second case you have 16 columns, so I write it as 16 rows, 3 rows, so I write as 3 columns. Again, 4 elements, 0, 1, 2, 3, 4 elements are there, and 2 represent the strength of that. So in the same way, it is a simple exercise for you to find out what could be the fields of this orthogonal array and this orthogonal array. Okay. So this is what is about the simple idea from the layman's point of view. I mean, non-mathematical, non-statistical point of student's point of view, what is an orthogonal array. Okay. So now let us go through the definition once again. An orthogonal array is an n cross k matrix. Okay. With n rows and k columns, having s symbols from the entries 0, 1, 2 up to s minus 1. Okay. And have a strength T, where k is always greater than or equal to t, so that every n cross t subarray contains each of the s power t possible t tuples equally often as a row. Okay. So say n times. So I think I would like to give, rewrite this definition in this form so that it's easily understandable. So now, having gone through the experiments, I'm sure this definition of orthogonal array may be more appealing compared to the first one what we saw, right? So we know it is a matrix and it has n rows and k columns, and the remaining 2 fields represent the symbols, a finite number of symbols coming from a finite set, Okay, and having a strength T satisfying a property that if you take an n cross T subarray, all the subarray, that each row will be having a s power T possible T tuples equally often. So this is what is about orthogonal array. And I make some observations from the study. Okay, an orthogonal array of strength T is also of strength T power j whenever T power j is less than or equal to T. So obviously true, right? If it is of strength 2, it could also be of strength 1. So as far as the permutation of rows, columns and symbols are concerned, it is invariant. So we can always have an isomorphic arrays. And the existence of an orthogonal array with the fields n, k, s and t will always imply the existence of orthogonal arrays n by s, k minus 1, s and t minus 1. So this has been established. So what this tells us that if we are given one orthogonal array, I can always construct more orthogonal arrays out of that. Okay. Oh dear. So this is all goofed up. So there are many methods to construct larger orthogonal arrays from so smaller ones. Okay. And now, if you go a little deeper into the ideas, we want to ask few questions. Okay. For which T, the strength, whenever the strength is greater than or equal to 2, we have seen that already T is equal to 1 is a trivial one, right? That 12 rows, 12 columns, 2 rows example we have seen. So that is a trivial example. So we'll always be interested in 2 or more the strength of the orthogonal array. So whenever the strength is greater than or equal to 2 and the levels are always greater than or equal to T, okay, then for S greater than or equal to 2, n is congruent to 0 mod of st. Does an orthogonal array exist? So the very basic questions, existence, uniqueness is what we'll be interested, because uniqueness is established by understanding the isomorphic arrays. Now existence. So for any given set of nkst, can we have an orthogonal array? Definitely not. Okay. So there are some restrictions. We can give an example which is not an orthogonal array. So for that combinations of nkst, you cannot have an orthogonal array. So for what value? So what should be the n? What should be the suitable k? What is the s and t for which orthogonal arrays exist? And how are these fields of the orthogonal array related? All that are the questions to be answered. There are, of course, several research now. It's almost 76 years after the introduction of orthogonal array into the literature. So lot of works have been done. Very, very interesting results are out. Now we are looking at what is the maximum k. What is our k here? The number of columns, right? So what is the maximum k for which an orthogonal array nkst with t greater than or equal to 2, s greater than or equal to, and n is congruent to 0 mod st exists? So why am I calling it as maximum of k? What does k represent in terms of the application? It refers here. K represent the constraints, factors, and variables, right? So we want to incorporate into our model as many factors as possible, as many various variables as possible, right? So we have to have an optimal of k. We have to have an optimal of k. So now we are interested in looking at what should be the maximum k for which an orthogonal array exists. So we are going to call that maximum value as f of, so I'm defining a function in terms of nst which has this maximum k. Okay. And in the same way, I want to ask about what is the minimum n? What is my n represent? The number of rows typically, but from the application point of view, it's going to talk about the number of experiments, number of tests that we need to perform, right? So obviously I want from the cost purpose and the doable purpose, we want the minimum number of tests has to be incorporated. So I'm looking for what could be the minimum number of n for which the orthogonal array nkst exists. I'm going to call this as capital F. So please note, small f refers to the maximum of k, capital F refers to the minimum of n. So my capital F, I'm allowing for all n for which this f is minimal. From this set, the minimum of that is the capital F. From this set, the maximum of it is small f. Okay. So establishing the values of small f and capital F is typically through the combination of obtaining a bound and constructing orthogonal arrays that attains that bound. Okay, so here is where is an opening. There's still, of course, several results are available as I'm going to list down, and several open problems are also there in this. So many values are still unknown. Okay, and there have been several bounds given by Professor Rao. So we have Rao's inequalities and the bounds for several of them, and many methods of constructions are also given, how to construct an orthogonal array for a given set of fields. And it is shown that there is, especially when n is prime or a power prime, it is possible to construct orthogonal arrays and so on. Okay, right. Okay, well, did I have some? I had some inequality, I think. Okay, here it is. What is now, as we mentioned, we call it orthogonal array. Where is that orthogonality coming into picture if you look at it? Okay, so you define a function phi I of u, or maybe x, if you want to look at it as a functional form, phi I of x for I is equal to 1 to s minus 1. Okay, so I is 1. So how many such functions are available? S minus 1 functions are available. Okay, be a set of s minus 1 orthogonal polynomials. Okay, on s0, 1 up to s minus 1 degree with phi of I is I. All right, so 0th degree up to s minus 1th degree. So I've got a set of s polynomials which are orthogonal to each other. What do I mean by the orthogonal polynomials? They are basically linearly independent. One cannot be expressed as a linear scalar multiple of the other. So they are all orthogonal polynomials. So when I keep the strength as 2, then we replace that u, the variable u, with 0 to n minus 1 in the orthogonal array everywhere by that function phi 1 of u, phi 2 of u, up to phi s minus 1 of u, and add a constant column. So normally it is 1, 1, 1, 1, 1. It is added as the last column. So all columns of this resulting matrix mentioned above are always orthogonal. You get it? So when t is equal to 2, replace one column with the constant values and all the other columns with their functions. This matrix will always be orthogonal, and this will be one of the standard examples of an orthogonal array. Here, the n, the total number of rows, will always be greater than or equal to 1 plus k times s minus 1. So we already know what are k and s, right? K represent the number of columns and s represent the levels. Okay, so when I make t as 3, what is 3? If the strength is 3, then the minimum number of rows required is always this in order to satisfy this condition. Okay, so here we are giving the bound. So n should be greater than or equal to means what? Lower bound of the n, the minimum number of rows that should be present in that orthogonal array in order to satisfy the given condition that the strength has to be 2 and so on. Same way, for t is equal to 4, the lower bound of n is also prescribed. So these are all Rao's inequalities. He has established these results. And in general, please note the general form of the Rao's inequality. When the t, the strength is the even number or the strength is the odd number, for any general u, 2u and 2u plus 1, the bound is already given. So what a fantastic generalized result you see. If the strength is 2u and strength is, we have seen examples with strength 2 and 1 and 3 maximum, right? So what do I mean by strength? If I have, say, for example, 100 rows in 50 columns. So if I take any 3 columns out of the 50 columns, I should be able to see that s power t result has to be satisfied. So for any general even number and odd number of strength, the lower bound of n is achieved. The number of tests we have to do precisely for the application point of view. So only explicit bounds that apply for any orthogonal arrays. And the lower bound of n, okay, but also the upper bound of k is also, so we can have, since we define these two things, small capital F is the minimum of this, small f is the maximum of this, the equality will be achieved when these two are equal, right? So this will be when k is equal to, when some values of s is satisfied, you can have equality symbols here also. So that is what is given here. Bounds can be attained for some parameters, but improvements are possible for others. Okay, so there are also results available in the literature regarding the construction and bounds. So one such example is you can construct a zero-sum array. We can form an S power t into t array to fix only the S and t, the levels you want, whether 0, 1, 0, 1, 2, or 0 up to S minus 1, your choice of S, which is the level, t is the strength. Okay, form an S power t into t array from all t tuples based on 0 to S minus 1 and add one column so that the entries in each row adds up to 0 modulo S. This is an orthogonal array. So this is a beautiful construction of an orthogonal array for S power t, t plus 1, S comma t. Okay, and it's very surprising, interesting result to note that this f, small f, which is the maximum of the n, maximum of the k, f of S power t, S comma t always becomes t plus 1 for s is less than or equal to t. Okay, so and another example is given by the Bush, where he says that if you have used the polynomials of degree less than or equal to 2 over a Galois field of GFS, one extra column can be added if t is 3 is equal to 3 and s is a power of 2. Okay, so with this idea, we can increase the constructions of orthogonal arrays for higher values of S power t and so on. And there's also a conjecture made here. So obviously it is still open. One could prove if S is a prime power, then f of S power t, S and t is always S plus 1 when t is between 2 and S, t plus 1 if t is greater than or equal to S. So there are some special cases. It has been discussed here. Okay, and we also have what are raw Hamming arrays. They are of the strength 2, having the type S power n, S power n minus 1 by S minus 1, S comma 2. So for any arbitrary S and n. But only thing is S has to be some prime power. Okay, so give for equality for Raw's bound so that this for any prime power S. So this is also an open problem. Give the equality for Raw's bound so that f of Sn S2 is given by this. Okay, so this is a possible constructions. I will not go into the technical details of that. So some constructions are also given how to construct orthogonal arrays for a given set of S comma t. And also you can alternatively think of starting with an n cross S power n minus 1 by S minus 1 array and take all linear combinations as their rows. And there are some interesting mathematical objects called Hadamard matrices, which have the entries only as plus and minus 1. Okay, so it's denoted by Hn of order n. It's of the form n cross n matrix with entries from plus 1 and minus 1, which always satisfy a relation of the form Hn transpose is always n times In. So this exists for n is equal to 1, 2, etc. and where any n is of the form of multiple of 4. Okay, so when you have such Hns, you can always construct the orthogonal arrays using this Hadamard matrix. Okay, so it says that Hn, Hn we know is the simplest of the Hn you can think of is 1 when n is equal to 1. So 4 by 4 matrix is the simplest of the Hadamard matrix. So if you put that 4 by 4 matrix here and the negative of that matrix below, so I'm going to get 8 rows, right? So twice of n and 4 columns, single n, and 2n comma n, 2 comma 3 will always be an orthogonal array. So with Hadamard matrix, you can generate any number of orthogonal arrays.
Madam, Rajesh, sorry to disturb you, madam. The time is going to up.
Okay, how many more? 2 minutes I have? 2 minutes?
Yeah.
I will wind up. So I will skip. There are also some different schemes available from Hadamard matrix. You can generate examples using different matrix, and a very beautiful mathematical concept lattice can be generated using the orthogonal arrays of strength 2, which has great applications. Okay, so I will skip the lattice part of it. It's very interesting. Lattices could be generated, and using that lattice, we can generate what is called as the dual atoms of the orthogonal matrix. So I'm going to skip all that. I will just give an example of 1 or 2 and then wind it up because my title says orthogonal arrays with application. So I definitely have to mention some applications. Just give me 2 minutes, please. So in the case of mobile applications, for example, if I have 3 types of calls, free, national and international, 3 call methods, phone book, voice activated or quick dial, and 2 account type, postpaid and prepaid, these are all the possible combinations. The call type could be this, call method could be shit, account type could be this. So the test count is totally orthogonal arrays could be 18, but by applying the orthogonal array technique, you can at most choose only 8 to 9 tests to identify what is the minimum number of tests required. Okay, so totally 8 possible cases, out of which 9 is enough. So reduction in the percentage of 50% in terms of time and cost. Another example is the plastic molding experiment, wherein you want to assess the tensile strength. The factors are pressure, time, and additive, and you have 2 levels: temperature varying 200 to 220, 500 to 700, 30 to 40, and 3 to 5. And here the total number of test cases is 14. Test cases count after applying the orthogonal array is reduced to 8. I would have wished to show you how we are reducing to 8, but because of the want of time, I'll just skip that. And another example about the web browsing, web page browsing. So when you have 3 distinct sections of top, middle, and bottom that can be individually shown or hidden from the user. So I have number of factors is 3, which is top, middle, and bottom. Number of levels is 2, which is hidden or shown. So the possible testing cases are 8. And using orthogonal array, we can do away with only 4 runs. So total number of test cases is 8. With an orthogonal array application, we can do only 4 runs and get the exact result out of that. The last of the application is the personal information data. So we have 4 fields of registration form, each having 3 sub-options. So age field, gender, highest qualification, mother tongue are the 4 fields, and subfields are 3 each has this one. So the total possible factors are 4, levels are 3. The number of orthogonal arrays required is just 9 rows. So if we look at it here, with respect to these 9 arrays, you should be able to clear all this. But when we do all this, how do we apply it back? So we have factor 1, factor 2, factor 3, factor 4. In each, you have some 0, 1, 2 symbols appearing, right? So how do we map back to our application problem? Map the factors and levels to the array. So factor 1 will be representing the age, 2 will be representing gender, 3 will be highest qualification, 4 is the mother tongue. So when you replace all that, 0, 1, 2 will be replaced by the sub option of each field. So you will clearly know this is what it is. These 9 runs, if you do, you will be able to get the idea of what you want. So run 1, you always do with less than 18 people, males who have done high school with the mother tongue, Hindi, and so on. Okay, so we can see that each run in the above table represents the test scenario to be covered in the testing. So there are several advantages, and I will also mention just 2 research topics. At least 2 challenging problems is that the number of levels, when it is not a prime number, do we have an orthogonal array? It's still an open question. We can still check. And also the conjecture what we made, f of s power t s t, between 2 and t is between 2 and s, it is always s plus 1. When it's greater than or equal to 1, it's only t plus s. It's a conjecture which is still open. So here the challenge is, to conclude, I say that we want to optimize the number of test cases, reduce the number of execution time and the number of test runs, and optimize the variables, cover 100% functionality. The tool is an orthogonal testing strategy called OATS. And the solution is execution time will be definitely reduced, result analysis times will be reduced, coverage will be increased, and productivity will be increased. So orthogonal arrays have been studied extensively, but remains as an active area of research. It includes existence and bounds, method of construction, enumeration, and it has several additional properties, and it could be constructed in several structures closely related to orthogonal studies also could be studied. So this is the references. This is a set of orthogonal libraries in these 2 things. And the standard book, the first book released on orthogonal arrays is by Sloan, Hedayat, and this thing in 1999, and for which the preface itself is written by Professor C.R. Rao. And many references are also listed here. So thank you for your patient listening. Thank you.
Okay.
Sorry
Thank
if
you,
I have
madam.
exceeded
Any
time.
questions?
Sorry.
Wonderful presentation, madam.
Thank you, sir.
Wonderful presentation. Actually, you have spoken very aptly. The objective of the talk is, actually, I have listened you and we have worked together. Your talk requires minimum 2 hours. Then only you can communicate what the actual information you are having.
Thank
You
you.
will start with concept, end with application, close with the challenges and solutions. Everything your passion is to cover all these things. I have a mind that I would like to start a school of thought on Professor C.R. Rao. Okay. So that Professor C.R. Rao School of Thought, I would like to arrange some series of lectures in which, because being orthogonal arrays is the first of its kind for C.R. Rao's work, and later it has proliferated into many disciplines. Now we cannot assume what is the application side of these orthogonal arrays, which is pioneered in 1940s, 1946 it seems. So really it's a wonderful phenomena that we have to be privileged if we arrange a school of thought lectures, madam. I want to listen your full talks at the time. I want to go for so many projects on this also. Thank you, madam, for your lucid presentation. Thank you.
Sir, I want to just make one sentence. So this has, motivated me and, induced me a lot of interest. And I want to bring out several mathematical richness sitting inside this orthogonal array.
Exactly.
So I will do that in due course of time, definitely.
Madam,
and I have a very interesting.
Madam, please apply. We are going to continue this activity, Professor Rao School of Thought.
Okay.
Particularly orthogonal errors, we will do some work with application side.
Okay,
you have focused on very good areas where very limited you have focused, but there is a very good scope. Therefore, let us work together, madam. Let us make our school more vibrant.
Thank you, sir.
With your participation and vibrant contribution. Thank you, madam.
Thank you, sir. Thank you, sir.
Thank you. Now I'm over to chairman of the session.
So, Gulbin, please stop the sharing. Farooq.
Yeah, stop.
Yes, sir.
Yes.
Sir, can I?
Yeah, you can interact now.
Yeah, 1 sec.
Natarajan, Vishwanath.
Can I? Yeah, Vishwanath. Yeah. Sir, am I audible?
Yes, audible.
Okay, madam.
Krishna, you do simultaneously.
Okay. Madam, actually, I am from statistics background and I have very little knowledge of these kind of orthogonal arrays. But by going the way that which you have described, see whether we can take the rows as in some way blocks in classical design of experiments. Is it possible?
Yes.
Yeah.
Yes, sir. Yes.
Okay. So one more thing is, suppose in that case we can have only one blocking effect. Okay. And as you said, this being a homeomorphic structure, okay, can we have two such structures superimposed on one another so that we can simultaneously have two blocking effects on the with the help of two orthogonal arrays?
See, that's strength, the last component of the orthogonal array will take care of it. So if you want to take 3 columns or 2 columns at a time, so that this richness is spread over 3 variables only. If you are studying with 5 variables or 10 variables, the testing procedure is very tedious, right? So with 3, can you do that and get also 95% output? That is the idea. And if you want to superimpose 2, it should not be isomorphic to each other. It has to be distinct. The very word orthogonal as an adjective is, it should be linearly independent. So you cannot superimpose 2 isomorphic structures together.
Yeah, that is accepted, madam. But my question is, if you have 2 such similar dimensional orthogonal arrays, okay, can we superimpose them one another so that we can simultaneously have 2 blocking effects?
Yes, it's possible.
That is one thing.
Juxtaposing one to the other. Yes, it is.
Yes, Professor.
You are absolutely correct. The design of experiments is one of the vibrant areas where orthogonal arrays are using. Okay. Anyway, Professor Rajeshwari Madam is of our university. We will have work together. We will have more fruits on it. Thank you. Now let us go for questions.
This is a wonderful. Sir, this is a wonderful lecture and very, very refreshing on a Sunday morning.
We will have the conversations later.
Okay.
Right. Ramakrishna, you carry on.
Okay. So now the second invite by Dr. SVS Girija Madam. She is a professor of mathematics, Hindu College, Guntur. So he has done PhD from Acharya Nagarjuna University in 2019, and she receives so many awards and honors. The international published a title on a rapid version of the some live testing tools models, jointly authored by A.V. Dattatreya Rao and I. Rambhadra Sharma, has been awarded Best International Publication by Acharya Nagarjuna University in 2007 and Certificate of Merit. The national publication title, A Note on Offset Cost Distribution, jointly authored by A.V. Dattatreya Rao and J.V. Radhika, has been published Best National Publication by Acharya Nagarjuna University in 2012. And a national publication titled on the Rising Sun, Rapid Log Normal and the Rising Sun, Rapid Exponential Models, by jointly authored by A.V. Dattesar and A.V. Devaraj, has been awarded Best National Publication by Acharya Nagarjuna University. And she is the academic advisor for academic audit to private aided colleges in AP, recognized by a Commissioner of College Education, Hyderabad. And she is reviewed for statistics probability letters elsewhere, general and communication in statistics, theory and models. And she is editor to Econometrics and Statistics elsewhere journal, and received a cash award, so gold medal and contribution certificate to State Best Teacher Award from Government of Andhra Pradesh on September 2015.
You are showing one slide and saying something. You just scroll it and speak.
Right. So she is editor, and she is a selected associate fellow of Academy of Sciences in 2015, and she is editorial board member and reviewed the Institute of Mathematics and Management, Sri Lanka, in 2020. She is a life member in Indian Society for Probability and Statistics, ISPS, and a life member for AP Society for Mathematical Sciences, and life member of International Indian Statistics Association. Experience is 20 years experience in research. She published 66 papers in reputed journals, and she got published in BDM World. Getting 3 categories for PhD and students, 2 students for award for MPhils. And this is a small gist of. Now I welcome you, madam, to present our topic.
Thank you, sir. Thank you, Ramakrishna, sir. Thank you very much for a nice introduction. Am I audible, sir?
Yeah, audible.
Sir.
Okay, thank you. Good morning, all the eminent professors in this conference. At the outset, I would like to thank the organizers for giving me this opportunity to get associated with the conference, which is organized in the honor of Professor C.R. Rao, a legend of mathematical statistics. I am proud to say that Professor C.R. Rao Garu accepted my request and acted as the adjudicator to the thesis of my student. It's my bounded duty to offer pranamams to my beloved teachers, Professor I. Rambhadra Sharma Garu and Professor A.V. Dattatreya Rao Garu, who are retired professors of mathematics and statistics, respectively, from Acharya Nagarjuna University, and they are responsible for my increasing academic graph. Last Sunday, we enjoyed a talk by Professor Samanthi Konarasinghe Madam from Sri Lanka, in which she explained about semi-circular model and its applications. She considered 4-year series to construct circular model. Analysis of circular or angular or periodic data falls under nascent and fertile area directional data analysis. There are several procedures for constructing circular as well as angular models, which requires more mathematical and statistical tools. Shall I present my PPT, sir?
Ma'am. Sure, ma'am. Please present.
Okay, sir. Is it visible, sir?
No, ma'am. It's coming now.
Okay.
This will take time.
Okay, okay, sir. Is it visible, sir?
Yeah, carry on, madam.
Madam, put in a slideshow, ma'am.
Yes, yes. Okay.
Okay. It's clear, ma'am.
Okay.
Go
sir.
on, ma'am. Proceed.
Thank you. Here, I would like to focus on applications of mathematical tools in construction of new circular models or angular models and developing new construction procedures. Hence, title of my topic is Mathematical Significance in Angular Statistics. In many practical situations, we come across angular data. For example, biologists are interested in birds migration problem, for which they collect angles of extinction while birds are getting migrated. They want to analyze that data. And similarly, solving the following problems presumes the knowledge of directional data analysis. Existing linear statistical tools will not yield suitable results when applied on angular data. For example, arithmetic mean of 15 degrees and 345 degrees, which is 180 degrees, doesn't fall between these two angles. It points the wrong way. And according to mathematician, here the angle is 60 degrees, and according to geologists, the angle is 30 degrees. Which one is to be considered? Similarly, measuring the length of an arc, PQ, whether it is PLQ or PMQ. So, some new circular models which are invariant of zero direction and sense of rotation are needed for analysis of angular data. So to define the PDF of circular model, apart from non-negativity and the total probability is 1, periodicity condition is also to be satisfied. So this is the definition of a circular model, density function of circular model. Wrapping a linear model, applying stereographic projection on linear model, transforming a bivariate random variate to its directional component of that is offsetting, etc. are the existing construction procedures. The first one is wrapping a linear model. We take graph of PDF of linear distribution and wrap around unit circle. Result will be the PDF of circular model. Here we use modulo 2 pi reduction. XW is random variable of circular model and X is random variable of linear model. So here XW is congruent to X modulo 2 pi, and this XW of theta is a many valued function. Hence, the PDF of wrapped circular model can be given as sigma f of theta plus 2k pi, where k ranges from -infinity to infinity and theta ranging from 0 to 2 pi. This is the PDF of rapid circular model. The characteristic function of circular model is derived as under. Pi of t is e of e power it theta, since theta is periodic, and here we can write it as e of e power it theta plus 2 pi. From this, we get t is an integer. In case of, we all know, in case of linear distributions, t is a real number. For circular models, we can say that we can take t is an integer. So the characteristic function is defined as a, for p is an integer. Phi p of theta is a characteristic function where p is an integer. The real and imaginary parts of characteristic function are called trigonometric moments, and in phi p characteristic function, alpha p and beta p are real and imaginary parts. These are called pth order trigonometric moments, and first order and second order trigonometric moments play a vital role in the study of population characteristics of circular models. So we require characteristic function for each circular model from which we can study the population characteristics. And from a textbook, Professor authored by Professor Jamal Madaka, Srinivas Rao Garu and Professor Sen Gupta, they proposed that the trigonometric moment of order p for a rapid circular distribution corresponds to the value of the characteristic function of the unwrapped random variable x. So using these trigonometric moments, density function is defined by g theta, with this here alpha p and beta p are pth order trigonometric moments. So this is called as a Fourier representation of density function of a circular model. And we study population characteristics of circular model by adopting expressions from directional statistics authored by Mardia and Jupp. These are the expressions given in that book. And we can visualize the circular model, rapid circular model in this form. These are the rapid circular models which we constructed in our work. One of the circular models we constructed is rapid log normal model, and characteristic function of rapid log normal model cannot be derived analytically. So we use n-point Hermite-Gauss quadrature formula to evaluate trigonometric moments through MATLAB. We can visualize points of trigonometric moments in this graph. Another circular model is rapid Weibull model. In linear case, Weibull distribution plays vital role in data analysis with various values of shape parameter. Here also, we obtained, this is the characteristic function of Weibull distribution. We obtain a series of our characteristic function, which is convergent as per Bromwich 1955 book. The convergence of the series fails at least for some values of c. For example, when c is equal to 1 by n, where n is a positive integer, this contingency directs us to go for numerical integration. For this purpose, we use n-point Gauss-Legaré quadrature formula. The real and imaginary parts of numerical values of the characteristic function of rapid Weibull distribution are taken to be the trigonometric moments alpha p and beta p respectively. Another interesting method is applying stereographic projection. Probability distributions, both circular and linear, can be generated by applying stereographic projection. So that yields one-to-one correspondence between points on plane to the points on sphere. Here we consider one-to-one correspondence between points on unit circle and those on the real line. So stereographic projection is one way to make a flat map of the Earth. Inverse stereographic projection is defined by one-to-one correspondence, one-to-one map correspondence given by T of theta is equal to U plus V tan theta by 2. So here, though inverse stereographic projection is induced to construct circular models, we call such circular models as stereographic circular models. Here, this is the theorem developed by us to construct stereographic circular models. This is G theta, capital G theta is CDF and small g theta is PDF. This is the characteristic function. The proposition for characteristic function of circular models, which was proposed by Professor Jamal Madaka and Sen Gupta, is not applicable here in case of stereographic circular models. Hence, using Lucas theorem, characteristic function for stereographic models is derived. These are the new stereographic models. And in study of stereographic logistic model, it can be observed that it is unimodal. These are the PDF and CDF of stereographic logistic distribution. And we can observe that this model is unimodal if sigma is less than 0.5 and bimodal if sigma is greater than 0.5. And in the derivation of trigonometric moments, first two trigonometric moments of stereographic logistic distribution logistic model, we use major G function to get analytical result of that integral. So here we can see this. This is adapted from Gradstone and Rizek book formulae of integrals, and we use this majors G function in evaluating or in derivation of trigonometric moments of stereographic logistic distribution. So these are all about circular models. Next, not only circular data, we come across some semicircular data, arc data, like that. So what is the need of semicircular? Where we need semicircular or angular models or arc models? When sea turtles emerge from the ocean in search of nesting site on dry land, the data we get is semicircular data. Similarly, when an aircraft is lost, but its departure and its initial heading are known, there also we get semicircular data. To analyze that data, we require semicircular models. And similarly, in face recognition problem also, from 0 to pi by 2 only we get the data. When inverse stereographic projection is applied on linear distribution with domain ranging from 0 to infinity, stereographic semicircular model is obtained that ranges from 0 to pi in natural phenomenon. Similarly, while transforming bivariate beta distribution to its directional component, obtained angular model is offset arc beta model, ranges from 0 to pi by 2. I will show in the next slides. In this context, I would like to pay tributes to Professor V.L. Narasimham Garu, who was the founder of Department of Statistics in Acharya Nagarjuna University. And he guided me to develop the concepts of arc models. So if we require more angular models, in particular random variable of a model for angular data, we restrict to an arc of length 2 pi by L, where L is an integer on the unit circle and is called L-axial model. We extend circular or semicircular distributions to the corresponding L-axial distribution, which is applicable to any arc of arbitrary length 2 pi by L or pi by L for L is equal to 1, 2, and so on. A semicircular random variable is sufficient for such angular data. For L is equal to 1, here this is typo, not circular. Random variable leads to circular model, and for L is equal to 2, the random variable is restricted to semicircular model arc, that is theta belongs to minus pi by 2 to pi by 2. And inverse stereographic projection is also defined by one-to-one mapping to construct semicircular model for x belongs to 0 to infinity, and we get theta belongs to 0 to pi. These are the semicircular models we constructed. And one of such semicircular model is stereographic semicircular Weibull model. And this is density and distribution functions of stereographic semicircular Weibull distribution. This model was found to be the best fit for several semicircular live data sets. That will be explained by in next talk by Professor A.B. Dattatreya Rao Garu. This is the characteristic function, and first two trigonometric moments are evaluated by applying numerical integration in MATLAB. Next method of construction is offsetting. If f of xy is joint density function and transforming variables to polar coordinates and integrating with respect to or ranging from 0 to infinity, the procedure is called offsetting, and offset angular model is obtained. Offsetting is considered for the construction of new circular models. While working on this method, application of contour integration is very much required in the derivation of characteristic function of offset circular models. Surprisingly, some of offset circular models are found to be bimodal circular distributions, which are very much suitable to analyze the bimodal data. When offsetting is applied on bivariate beta distribution instead of circular model, an arc model ranging from 0 to pi by 2 is obtained in natural phenomenon. Similarly, offset exponential distribution is also an arc model. When offsetting is applied on bivariate linear distribution, we get univariate angular distribution. So these are all the this is about methods of available constructing methods of circular models, and new methods of construction we developed using rising sun function differential approach, that is taking differential initial with initial conditions, and with the positive definite sequences we can construct circular models or angular models, and Topless Hermitian positive definite matrices can also be considered for the construction of new circular models, and discretization of existing angular models to get discrete angular models. I am interested to present this rising sun circular models because this rising sun function is available in a textbook of real analysis by Van Ruiz and Shikoff that is published in 1982. This is a function smoothens the existing curve and many bumps disappear. This may lead to the effect of increasing the smoothing the curve in density estimation. So this topic of this rising function was my seminar topic for MPhil. So I am interested to present this rising sun function here, the application of rising sun function in construction of circular models. So this rising sun function is a bounded function, and it is represented as f circle dot x, which is the supreme of all the function values ranging from x to b. When f is non-negative, f circle dot is also non-negative. If f is continuous, then f circle dot is also continuous. If f circle dot is, this is monotonically decreasing, hence f circle dot is equal to f. And this is the theorem available in Van Ruiz-Shikoff mathematical analysis book. And this is rising sun lemma. F from closed interval AB to R be a continuous function, and this set E is open. And basing on that lemma, we developed circular rising sun lemma. And using all these concepts, rising sun concepts, we applied to available circular distribution to construct rising sun circular models. And this is the distribution function of GC, where GC is the PDF of circular model. And here, PDF of von Mises distribution is taken, and applying rising sun, that is the supreme of all the function values ranging from particular point to the end value, and normalizing that function, we get GC of theta, that is the PDF of rising sun von Mises distribution. Here, this is the graph for PDF of rising sun von Mises distribution. Here, this curve is the linear representation of von Mises PDF, and this green graph represents the rising sun function of this von Mises function PDF, and after normalizing, we get rising sun von Mises circular model. And this is a graph of PDF of rising sun circular model in circular representation. So due to time constraint, this is the characteristic function of the rising sun circular model. And due to time constraint, I would like to remain here. Before that, I would like to thank Professor Jamal Madaka Srinivas Rao Garu and Professor Ashish Sen Gupta, who encouraged me in working this area. And these are the references I included here, and most of them are our papers only. And thank you, one and all.
Okay, thank you, madam, for your motivated and elaborated lecture. It's a mathematical significance in angular statistics. So, any questions from others?
Thank you, madam, for your vibrant presentation. And really, this is the area where circular data is, as you said, that Jamal Madaka and Ashish Sen are working on that circular data analysis, where bread and butter of this circular data analysis is trigonometry and calculus. So, so combination of
real analysis also, sir.
Yeah, real analysis.
Calculus, real analysis and everything. Many.
Yeah,
being a mathematics student,
yes,
I would like.
different mathematical concepts. So mostly the calculus and the trigonometry, as you said, real analysis, and there are the real stuff behind this circular data analysis. and we statisticians always peripheral, and the engine behind this type of analysis is always mathematics. That one has to remember. So really a thought-provoking talk, madam.
Thank you.
It's really thought-provoking. As when that Sri Lanka madam Samanthi Kumarna Singh has submitted the circular data analysis related Sama circular model. That Sama circular model is having a considerable theory background, and just now I'm able to make it what is that math stuff behind it through you. Really, I'm very much thankful to you, madam, for giving this valuable inputs. Hope now I'm really amazing that the topics what you have touched upon, that rising sign model and wave transmission, that Fourier transmissions, etc. Really wonderful topics. I have goosebumps. Really, I'm speaking.
Thank you very much.
Professor, I just want to say today's morning 2 presentations were excellent.
Thank you very much for your nice presentation.
Thank you, sir.
They were actually, mathematics is coming closer to statistics. We are very much happy. There should be a sisterly affection to statistics from mathematics. I'm really grateful for the 2 excellent presentations which are practical, and we hope that statistics and mathematics will together help medicine and engineering.
Yes, sir. Thank you very much, sir. Thank you.
Thank you.
So now we'll go for next innovative talk by Professor A.V. Dattatreya sir. Dattatreya sir.
Yes, sir.
Right. Just I'm presenting your profile, sir.
What is the problem?
Shared.
Present how?
Already shared that presentation. We can share now.
Yes.
Yes. So I feel proud to introduce the Professor A.V. Dattatreya sir is a retired professor of statistics, Acharya Nagarjuna University, Guntur. His research experience is vast. They are having 37 years of PG teaching experience, particularly 19 years as a professor, and retired as a professor of statistics in September at the age of 62 from ANU. And he published more than 100 from international reputed journals and more than 50 from national journals. And he did 3 research projects, and under his valuable guidance, 11 PhDs and 5 MPhils are awarded. He published so many books. They mainly in recent 2020, he published Angular Statistics by Chapman and Hull publisher in the international market. And he gave invited talks more than 50 national and international conferences, including the Hong Kong and the USA. And he is served as a visiting scientist in a prestigious ISI, Kolkata, and went to Debat University, Assam, and worked as a visiting professor. And he received the Best Teacher Award from AP government in 2011, and 4 to 5 times the research publishing the best national and international publication, in addition to getting the best internal paper presentation award from the ANU. And he is a member of UPSC for paper setting and evaluation of ISS, and 6 times paper setter of ISET, and helped SK University in conducting the entrance examination for MCA prior to introducing the ISET. And he did so many administrative positions in ANU and elsewhere, and is a head and chairman and PG Board of Studies and Department of Statistics ANU, and dean and vice principal and principal of University of Science College ANU, and he is a senate member of ANU and AU, and the first coordinator of IQAC ANU, and developed in the material and 7th criterion of NAC accreditation and trained the faculty. He is the first APIO and PIO and FIA RTA Act of ANU, and handled more than 500 RTA cases, and delivered lectures on Act in these various awareness campaigns. And he is act as an officer in special duty of University, and conducted entrance tests for admission for second batch of BCA applications, around 15,000 in number, and act as a coordinator for the conducting of UGC JRF examination, and act as a ROSA coordinator of ANU, and contributed, developed the state level reports in collaboration with the state project directors, apart from the preparing the for ANU, who stood as a model for all the state universities. When ANU thought of making PG admissions through the entrance test, the then statistics HOD was asked to design the system, and he got the opportunity to involve himself in designing.
Krishnan, you can skip that.
And implementing.
You can skip it. You can skip it. We can save time.
Okay. You invite him.
Yeah.
Okay.
Straight away we can get it.
So this is the vast contribution towards the statistics, and he served the people of both the states. And now I welcome you, sir. The AV Datta sir, the topic is choice of angular models. Now welcome you, sir. Datta sir.
Thank you, Krishna garu, for introducing me, and Tirupati Rao garu for giving me this opportunity to.
Welcome, sir. Welcome for your blessings. Thank you.
So, to allow me to participate in this happy, auspicious occasion. I'm an indirect student of Professor C.R. Rao, in the sense, Guru V.L. Narasimhan was a direct student of C.R. Rao. That way, I'm indirect student, and I had several occasions to interact with C.R. Rao garu directly, and C.R. Rao happened to be adjudicator for my scholars. So this is my contact with C.R. Rao. And C.R. Rao worked in directional data analysis during 1960s, late 60s. And if I'm right, he rather encouraged Jamal Madaka to work in this particular area. And they jointly published several papers in this area. And in turn, Jamal Madaka and Ashish Gupta, they initiated us to this area. Therefore, we thank them also. Now, I'll share. Sir, is it visible?
Yeah.
Keep it.
Coming, sir, coming.
Yeah.
Put it in a slide mode, sir.
Yeah, sure.
Yes. Perfect. Perfect.
Yeah. The topic is choice of angular models. And Dr. Giji Garu, she made my job very simple. And most of the terms which I'm going to use, she has already introduced from mathematical notions. So thereby, she made my job so simple. So here, the idea is when we have several kinds of angular models, in a given situation, which model is to be selected and so on this I'm going to emphasize. So this is from statistics point of view, and she was talking on mathematical issues. Is it audible, sir?
Yeah, audible and visible. Perfectly correct.
Yeah. Yeah, we know there are several types of data, numerical basically and non-numeric. And non-numeric data analysis using statistics is now gaining very popularity. And numerical data analysis was done so much, but angular data is a novel feature for data analysis from statistics point of view. And she already quoted this example. Environmentalists, they are interested in bird migration problem. Therefore, they want to study in particular seasons, birds will be migrating from one country to another country. And based upon the angle of extinction, they try to assess where the birds are going to land in which country they are going to land in, and so on. So therefore, the measurements they make are the angles. And there are many examples in which angular data is very much useful. And some of these applications are shown here. And Girija has already shown all these things. And this is the circular model, definition of circular model, density function of that. One is non-negativity and total probability. These two are well known. And one more additional exam which you have, or the condition which you have, is the periodicity. If these three conditions are satisfied, then it is defined as a circular model. And existing construction procedures also she has touched upon. If you have any geometrical thing, and if it is normalized, it becomes a density function. That's a first idea of construction of circular models. Second one, Girija Garu already discussed in detail, namely wrapping of a linear distribution around the unit circle. That is also she discussed. Then if you have any characterization properties, and based upon characterization properties also we can think of constructing new circular models. And then offsetting, this also she discussed, and I'll also discuss in brief. And stereographic projection. So these are the broad methods which are already available in the literature prior to 2007 or so. And later on, new methods have come into the picture in the literature. So let me discuss those things. And then among all the models which is to be selected and so on and so forth, I'll make it presentation. And these are the circular models that were very popular till 2007. And very few models are available, maybe less than they are available for modeling circular data. And therefore, there was a scarcity for fitting various types of data that is available in a practical situation. And therefore, there is a need to construct more number of circular models. And this type of work was taken up by us after 2007. So this is what the wrapping concept is called. Suppose if you have a linear normal distribution and taking a unit circle, and if you wrap it on the unit circle, and that model is called wrapped normal model. And that wrapped normal model looks like this after wrapping. Then using this idea of wrapping, several wrapped models we have constructed, and the list is as follows. And another construction procedure is stereographic projection. Suppose we have a circle and a plane, or a sphere and a plane, then every point mapping onto the linear is called stereographic projection. Whereas our aim is to construct circular models using linear models. Therefore, we take inverse stereographic projection to construct circular models. So inverse stereographic projection is from plane to sphere. Or if you take 2 dimensions, a linear line to circle. And that inverse projection gives a density function, and such things are called stereographic circular models. So when I say circular model, full circle 0 to 2 pi is considered. And these are the list of stereograph models we constructed. And these are the semicircular minus pi to plus pi, or 0 to pi we can think of. These are the semicircular models, and she was talking about some of the applications of semicircular models, and these are the semicircular models which we have constructed. Offsetting, this also she was talking. With respect to the resultant length, then it results into a density function, univariate density function, and that univariate density function happened to be the circular model. And geometric representation of that is this. If this is a bivariate normal, and or any bivariate distribution, we can have this kind of a thing. Then if we chop it in the direction of R, and then if we take the area, normalizing the area, that is going to be an angular density function. And this kind of technique is called offsetting. So offset normal distribution is like this histogram. Then these are some of the offset models which we have constructed. And sometimes we need skewed data. Skewed data we may come across, and modeling skewed data is also required. And this Marshall and Alkin has given the transformation, and with this transformation we can use the tilt parameter or shift parameter alpha, and we can shift the model and we can get skewed model. And these are the skewed models which we have constructed using Marshall-Alkin transformation. Now the theme of my talk, this is the introductory part of it. Theme of my talk is, when we have several models of this sort, then which is to be selected in a given situation? That is the prime interest we have. And I just classified them in 3 categories. One is looking at the scatter plot. We can think of suitable model because we know the characteristics of all the models which we have derived so far. Maybe around 40 distributions, new distributions we have added to the literature, and all the characteristics of those things were studied thoroughly, namely mean direction, variance, skewness, kurtosis, and so on and so forth. So based upon the nature of the data, and we can suitably choose the model and we can fit it. That is one type of thing. Then if the available models are not characterizing the given data, then perhaps we may have to go for construction of new methods. And third one is, if we have several models and which is to be selected, we can select through what is known as goodness of fit technique. So let me discuss these things one by one. Looking at the scatter plot. So the nature of data which we can say is symmetric data. It could be symmetric data or semicircular data or bimodal data or asymmetric skewed data we can think of. Examples. This is one example. and its scatter plot is this. So it is a total circle. On the total circle, I mean, the entire data is dispersed. Therefore, it is a circular data. And this is another example wherein, if you look at the data plot, only semicircle and bimodal data. This is bimodal. And when we have bimodal data, one scope or chance is to go for offset models. Asymmetric data. You can see this is asymmetric data. And when we have asymmetric data, we can make use of Marshall-Alkin models. Now, the second aspect, namely, if the models are not available and new model, if it is to be constructed, and what is the basis of using a particular procedure and so on that we can think of. And this is the broad table we can have. If the nature of data is circular, then one can use wrapping or stereographic projection or offsetting. If one is interested to have semicircular, then stereographic projection on positive sided support is to be taken. If it is bimodal, then offsetting is the suitable method of construction. And if one is interested to have smoothing or try to have density estimation, then rising sun function one can think of. And asymmetric data, if we have, then Marshall-Alkin transformation is to be used. And in addition to this, axial data if you have, namely total probability is concentrated only a particular arc, then arc models or an axial data is to be taken. So then the last aspect is goodness of fit. To demonstrate this, we have taken data of 13 Poisson data, and we have considered 4 models: offset Pearson type 2, which is bimodal, and stereographic logistic, stereographic double exponential, and wrapped logistic model to fit that data. And this is the probability plot curve of the data using various models which I have stated, namely 4 models. This is the second model, this is the third model, this is the fourth model. So looking at that, 4 models are the candidates to try for goodness of fit. And in goodness of fit, the first thing is estimation of parameters, and this is the non-parametric estimation of the mean direction. And taking this, we can think of various tests for uniformity, and using inverse probability integration transformation, and we can think of developing the statistic for testing goodness of fit. And this is the data which we have taken to study goodness of fit of those models. And this is the scatter plot. And these are the estimates. And these are the statistics of various test procedures which I have already mentioned. These are the cutoff points which we have developed, and we have tabulated all these things for various procedures. And the inference is all the 4 models are okay at 1%, 5%, and 10%. Now, among the 4 fits, which is to be selected as the best fit, and that answer is to be still answered, and it is answered using the one of the criteria or all the criteria one can think of: maximum likelihood, or AAC and BIC, whose formulae are here. And if AAC or BIC is small, then that model is to be selected. Similarly, maximum likelihood, maximum value we have, and for which it is maximum, that will be preferred as the best. And then for these things, we have calculated MLL, AIC, and BAC, and this is our conclusion. Based upon that, offset Pearson is the best model among those 4 models. Then, so far we have discussed only continuous models, but in practical situations, we need to have discrete angular models also. And one such example is in signal processing. We come across these continuous models, but when a sample quantization is done, discretization is required, especially for computerizing the computations of those things and so on and so forth. So therefore, this is the discrete type of thing, namely dividing the whole thing into m intervals and then finding the mass at each and every point we can think of, and when the total probability is 1, such a model is called discrete model. And using this idea, we have derived a discrete, one of the discrete distributions, rising sun rapid Cauchy distribution we have derived, and the density function is given by this. And this is the diagrammatic representation of that. And this is a circular representation of it. And this is the book we have published, and this material is taken from this book. Thank you. Thank you.
So thank you, sir. It's a nice presentation. Are there any questions?
Thank you, Professor Dattatreya Rao garu, for your
Thank you, sir.
very, very thought-provoking and very vibrant topic. That is really when I noticed that orthogonal data analysis initiated by our Professor Rao in 1940s, and this directional data analysis is also equally make more impact on from 1960s. It seems to be originated, and the luckiest part of the Professor C.R. Rao is that there are many propagators and promoters of his thoughts. So his thought processing is making proliferation, like you people contributing this directional data analysis, and really very heartening to know that recently you wrote a book on this directional data analysis also. So very, very interesting, sir. So converting the math notions for statistical perceptions is very essential and order of the day, and your contributions towards that area is highly laudable, sir. Highly laudable, and definitely the future generations will be indebted to you people for making these contributions. Really wonderful, sir. The applications what you have mentioned, and the areas where we can do the work, the scope, influence, everything is really admiring, sir. Really admiring, sir. Really, we are blessed. All the delegates of the conference are really blessed to have your tremendous information. Hope this information definitely will give some impact on future research, sir. Thank you very much.
Let me add a sentence.
Yes, sir. Thank you.
Got all applications in every field. You may say design of experiments, quality control, and whatnot. But still one has to work on that, and especially Gadde Srinivas Rao is there, who is expert in quality control. Quality control. Namaste, sir. And then he can take up. Namaste, Bhavana. He can take up some more activities on this. Similarly, pattern recognition and designs. Not much is done in this angular data. Thank you very much. Any questions? Yes, sir.
Sir, please stop your sharing, sir.
Sir,
Stop your sharing, sir. Then we have it.
Sir, Vishwas sir is available,
Yeah.
sir? Vishwas,
yeah, I am available, sir.
Okay.
Yeah, I am available. Sir, this is regarding if you have to spread or discretize in a semicircular model, do you have any problem of convergence issue, particularly when the set is countably infinite?
No,
No, sir.
no, sir.
Because normally when we sum it once, it's okay, because being circular in nature, if it gets repeatedly, it adds mass, not necessarily across the point, even at point at different possibly 2 pi's or pi's. Okay.
Yeah, depending on the periodicity. Depending on the
Periodicity.
periodicity.
So,
periodicity.
so whether
But
spreading.
ultimately, we are going to normalize it.
Okay.
So therefore,
So-
that may not give any problem.
Thank you, sir. Thank you.
Okay, sir. Thank you.
Thank you. Namaste, sir. Namaste. Thank you very much.
Now I'm sharing the profile of Sri S. Viswanathan, sir.
Welcome, Viswanathan, sir. Before making that, thank you for your participation. And yeah.
Sir, I'm very fortunate to introduce the speaker, Viswanathan, sir, the Associate Professor, Department of Statistics, Presidency College, Chennai. And he is a net qualified lecturer, and he had higher diploma in computer hardware and networking, besides our regular PhD in statistics. And he has a vast teaching experience. So he has 25 years of teaching experience in PG and 26 years in UG. And he published 12 papers in a national and 7 papers in international journals, reputed journals. And his research, he served as an assistant research officer in 3 years in schizophrenia prevalence study conducted by ICMR. Now this name is very famous in nowadays. So survival analysis, information censoring, and his research contributions and area of research is in statistics as well as in mathematics also. In statistics, the time series, model building, and parameter estimation and testing, and factor analysis, inference and survival, and general linear models, multi-dimensional scaling, and non-parametric testing, and in mathematics, measure theory and integration, and real and function analysis. He is a man with the mathematics and the statistics combination. He is an expert in that. So welcoming you, sir. Now we are welcoming the Viswanathan, Dr. N. Viswanathan, to present his innovative thoughts. So Viswanathan, sir, present, sir.
Yeah. Whether the screen is getting shared?
Yeah, it's correct.
Okay.
Perfect.
First of all, let me thank Professor Tirupati Rao and his team for giving me this opportunity to take part in this wonderful occasion. And not only thank for giving me an opportunity to present, but more so over, I have to mention, yes, given sufficient time for me to clarify my doubts. That is, in my point of view, it is much more important than providing me this opportunity, because normally what I feel personally is that instead of spending years together in a particular topic and learning something, listening to 30 or 20 minutes from experts and learning, that is a more comfortable way for me at least, and getting clarified is a very big thing. Opportunity in that way is very, very so in that sense, I thank the team first of all. And in one of the earlier speakers, possibly in the beginning from North, they mentioned Tirupati Rao's name as something like Tripti Rao. Yeah, Tripti Rao. See, in Tamil and in some other South Indian languages, this Tripti actually means satisfaction.
Yeah.
way, this is a very satisfactory work of Professor Rao, which either gets into the stream directly or indirectly, so that it gets recognized by our earlier speakers from the north. So in that way also, it's a very commendable work.
Compliments.
No, it's a fact, Professor. It's not something like that we put it. See, it naturally happened. Probably professors from the north, they are unable to pronounce your name, it seems. Finally coinciding with the fact. And coming to Professor C.R. Rao, as everybody knows, is a great personality. And there is a definition for knowledge which goes like this. There are very many definitions of knowledge because it is a very abstract concept. And one of the definitions is says something like it is knowing something of everything and everything of something. So which indirectly means nobody can. Yes, yes, sir.
Can you make some effort to speak towards seeing the camera?
Oh, okay, fine.
Facing the camera is always better. Because
Okay, fine. Is it okay now?
Right.
Is it okay now?
Yeah, okay now.
Okay, fine. So, as I was mentioning, the definition of knowledge, okay, so it is said something like knowing everything of something and something of everything, which practically excludes knowing everything of everything, which is practically impossible, and that is the way it is defined. But when it comes to Professor C.R. Rao's case, going by the area and domain he has worked with, okay, it seems like he is a man who is capable of knowing everything in everything. So that is an exception to the definition of knowledge. It is his caliber is something like beyond knowledge, so to say. In 2011, I think, beginning, okay, there was a function conducted in Madras University while they honor Professor Rao with the honorary doctorate. In 2011, if I remember correctly, his very first word in the meeting was, "I am 92 not out." So that was the statement of Professor Rao. By that time,
Can you repeat? What is that?
Very first statement was, "I am 92 not out." Because by that time, normally during that particular season, this December or January, okay, normally because of this pandemic only the things are getting shifted. Otherwise, this is the period of some foreign nations coming in to play test cricket or one-day cricket to India, and particularly to Madras. That was the scenario. So he was that much context specific that he said that started with the word, because he was a little bit aged by that time, but aged in the sense nothing reflected in his speech or other things, but subtle way he said that I am 92 not out. Because similar to now, there was a Indo-Australia test cricket was going by that time, and at the time we preferred that he should complete the century, and it is now getting done. And as usual in any cricket, okay, we expect him to go for another round. So that is what we expect, and it is the wish through this we express through this function. Okay, so that is one part. So now I will get into the business. It is estimation of quantiles in survival, a fuzzy approach. Okay. So this is a joint paper by myself and Professor Ravanan, who was now is a joint director, Chennai Region Collegiate Education, Tamil Nadu. Okay. So the plan is plan goes like this: abstract, what concise the thing, and then introduction. And first I want to stress the applications, because that gives more meaning when we study certain things, okay, some weightage. Then what has been done already, review of literature, methodology, and particularly what we do. And here specifically I am going into simulation studies, not going for any real-time data, particularly because I want to study the model with varying parameter structures, which cannot be done with real-time data. It is a fixed structure. Okay, here we have some flexibility in simulation. Okay, so we can vary things, and under different circumstances, how the things are going to work. And any real-time data possibly will be can be approximated to any one of the simulated structure which is close in the grid. Okay, if it is multi-parameter setup, or close in Euclidean distance if it is a general structure, or even some other measure distance also, and some conclusion and limitations. And limitations can be overcome with the future work. So in survival studies, estimation of lower order quantiles becomes a major problem. This is mainly because when we draw the survival curve, as everybody knows, it starts from 1 at 0 in time scale. Time scale in x-axis normally we have the time, and in y-axis we have the probability of survival. At 0, okay, so everything is or every person or every patient or every mission, okay, we can expect something to be alive. Of course, mission it comes separately under reliability theory. So we have a different structure for censoring there. Okay, so here we are more concerned about the human subjects and other things. Okay, so normally plotting the curve from the data, we face the problem once it reaches at some particular stage. Okay, it starts coming down. After a certain stage, it will stop. And we cannot extend further this, that particular thing to down to the 0 level, so that we can find all the lower order quantiles. Lower order quantiles, it is difficult, particularly when we have high proportion of censoring subjects. When the censoring proportion is heavy, and the curve will hardly go and touch the 0 line. So when you want to compute something like quantile of order 5% or 10%, it will become very difficult. Even at times, median becomes difficult to flash a graph concerned with this. So, so normally that lower order quantiles we estimate using the inverse survival function. Survival function is there. Okay, it takes t and gets the value, and normally we are more bothered about the survival probability at a particular point. So we take the inverse survival distribution concept. Certain extensions using exponential nature of survival structures were used to extend the curve downwards. Okay, this is a mathematical approach. So we know a curve coming from sloping downwards, whether it is sloping via a straight line or via a curve. Okay, so convex or something of that sort. We can always have some extension could be done. Okay, something like fitting. Okay, that is one way. But the problem there is mainly we will not consider any censoring and other related things that we will discuss in detail. It is purely a mathematical structure which gets extended and drops the curve to the bottom line, from which we can do all the quantile estimation. That is one way that we can do. And in this paper, what we suggest is incorporating some fuzziness, okay, in the survival time and the censoring pattern. Okay, so because see, normally what happens is, of course, we will be considering that in later slides also. But the thing is that usually we give importance to the survival counts, but not at what time the censoring counts, but at not what time the censoring takes place. That is a major issue. And even if you give consideration how you are going to accommodate it, okay, the pattern of accommodation also matters. And to some extent, that is being modified in our study from the previous one. So normally, I think this is for non-beginners. Okay, sorry, this is for beginners, so to say. So we define survival analysis. Okay, modeling for time until the occurrence of an event. Okay, so this is the thing that we consider, and the event can be anything like death, occurrence of disease, marriage, divorce. Okay, and the time to event. Okay, that is what we are interested in mainly, and to be very particular, probability of time to event. That is what we are trying to model. Okay. So we have survival analysis. In addition, we have the problem of censored and uncensored observations that normally does not take place in the case of classical estimation or testing. So there we have complete data, so there won't be any missing observation. Or even if there is a missing observation, since we assume that the IID structure, okay, they can be to some extent replaced by the existing ones with equal weightage. Here weightage also is going to play a very important. And in survival, we face the issue of right censoring because of time and resource constraints. So we cannot go on extending the study until we find all the subjects in the study to die or get married or get divorced, something of that sort. Okay. So that is also there. Right censoring is a very big issue. And high proportion of censoring subjects, as I was mentioned, when it is in psychological studies or in some other studies. Okay, so we expect this high proportion difficulty. Okay. So, okay. So as I mentioned, some of the classical works, they mainly operate on the slope of the survival distribution. So to some extent, already the existing data will give you a partial survival curve down, sloping downwards. So you extend it, okay, you extend it. So such as Kaplan-Meier product moment estimator, it will give you a step function, of course, but we can suitably replace by some smoothed functions, and you can extend it. You can extend it. That is one thing. And here, as I mentioned, we are going to use fuzzy approach to quantify the censoring information to fill in the gaps. So that is the major doing here. And as I was mentioning, taking into account the fuzziness of the data present in censoring pattern. Because normally when we want to fill up certain things, so we mainly replace it under the assumption that they are almost in classical setup. I am talking about in classical setup, we assume that they are more IID in nature. So in that sense, possibly we have some flexibility there here because we are going down the probability scale or going high in the time scale. So we cannot have any replacement from the other end. Okay, so the one that have behaved very well or one that have lost in the earlier of the time period, they cannot serve in any way replacement directly. Okay, of course, unless you attach some weights and scale it down. Common scene survival function. So starting from 1 at time 0 or any fixed shifted time, and it as things goes down, okay, so it approaches 0. So it's a simple Kaplan-Meier like structure. So in this case, we are interested in getting the median survival time. So after if the survival function is complete, okay, that is what we are saying. If the survival function is complete, that is starting from 0, it goes down to, starting from 1 goes down to 0 completely or continuously, or even if there is some discrete jumps, okay, to some extent we can make it smooth. And you start with the x-axis, so y-axis at 50% or 0.5, and take a right turn with 90 degree and see at what time, okay, the things there is a survival 50% survival probability. So given the probability, we can use this technique to find the months. Even in clinical studies, we can fix the dosage levels using such things, or lethal level in which they want to kill certain insects or kill certain viruses. Okay, so all such things, whether it is even connected with living or even connected with death. And this is one particular area which treats both death and living with equal probability or equal weightage in a way. So this can be above par with normal structures. Okay. So I want to know what is the chance, okay, of surviving beyond up to 2 months. Okay, surviving up to 2 months. So sorry, beyond 2 months. So in that sense, I am fixing the value in the x-axis, and accordingly, I am fixing the probability in the y-axis. Previously, I fixed the probability at 0.5. I fixed the probability at 0.5. Okay, fixing something on the y-axis and coming down to x-axis. So I want to know what is the time. Now I fix the time. Okay, now I fix the time, and I want to know what is the corresponding chance. Both are required at times. Both are required at times. Okay. A few applications to mention. Premiums, okay, because once we know the probability of survival at a particular time point, depending upon the age of the particular candidate, we can fix the premium. If the probability of survival is less, you should fix high premium. If the probability of survival is more, you can fix less premium. And it is a simple logic. Okay, when the probability is more, fix high, and it is less, fix low. But the problem is how much. Okay, quantitatively we have to put it, and to fix the premium as a function of survival probability. So we need this as an input. We need this as an input because of so now there exists cutting edge competition between insurance sectors. There are many players. Okay, so private players and also from the government sectors. So unless you have a cutting edge, which has to be decided very, very closely and scientifically. So this plays a vital role in deciding the probability of survival. And then in industry, to some extent, okay, we cannot directly extend this, but to some extent we can consider this for replacement plans. When things break down, okay, time to break down can be taken as an event. Time to break down can be taken as an event. So when is the optimal time to replace it? Because otherwise the industrial structures, so when we replace it little bit longer, we will have more maintenance cost than the say having the things new. So some such things may happen. So that is one thing. And also about creation of reserve funds, okay, because normally any any industrial application, a particular instrument is not going to be replaced all of a sudden on a particular day. So we expect that at what rate it is going to get depreciated, okay, which is something like decreasing probability of survival. Accordingly, they have to phase it out, properly make the reserve fund from the profit, and at expected time or even before that, okay, they can replace the thing. So for building reserve funds, okay, reserve fund models also, this is going to be very helpful. Okay, so already as I was mentioning these things, I will quickly go through this. So previously we have a standard model from Kaplan-Meier. Okay, so for times less than the maximum, sorry, for times less than the maximum, we have no problem. Okay, so when it is getting more than what is the maximum time of the observed data, then we will attach a probability of 0 beyond that time. So it is a rough approximation. Okay, because any theory that initially starts with, okay, so they have to give some initial solution, and that gets developed in the time span. The largest time is censored, as I was mentioning, it will the curve will not get proceed. So that is the case that we are seeing. And Efron 1967 suggested estimating survival probability after maximum observation. Okay, so again that says that after maximum observation, okay, please make it 0, finished. That is negatively biased. The probability, the estimation of survival probability is negatively biased because probably he may have some chance. Okay, so completely eradicating that chance, okay, brings down the probability so to 0, which is in some way underestimating or termed as negative bias. And Gill 1980 suggested estimating ST by you take the maximum time at which the survival probability is available, and you fix that probability to the rest of the time. Okay, so the curve will get a flatter line after the minimum possible data observed period. Okay, so it will never get down. So naturally we expect something to go down, and we are having something fixed at that level constant till the end of the. So in that way, okay, so we estimate it with more value, so positively biased, so to say. And as I said, Brown suggested some exponential distribution structure, okay, which brings down the curve to 0 line. And here again, the problem is that exponential distribution structure is more of mathematical extension or extrapolation rather than taking into account the structure of censored values and censored numbers. Okay, so everything put together. Okay. So it goes to some extent similar to this. So we have, you take the maximum time at which the survival estimate is available, divide it by T max, okay, the time at that value, take log, of course, to offset what we have exponentiated, and multiply it by T. That is going to serve as the estimated value. So that is another solution provided. But as I was mentioning, using fuzzy, how it is going to happen. Okay, that is what we are mainly more bothered about in this section. Okay, so here what we have is something like TIDI. This is getting into the pattern how we are going to generate the fuzzy membership function. Okay, which incorporates your not only accounting for number of censoring, but the time at which censoring is taking place. That is also a thing to consider. Okay, that is where the things most matter actually. So we have TIDI as usual, and TI is a failure 1. Okay, so it is a ordinary censoring mechanism that is captured by the variable di. And we have the membership function mu I of x, which is I is defined for all the observations, okay, in the sample, and the x is defined, okay, for the entire real line. That is the point to be mentioned. So here x is actually defined from 0 to t and 0 to ti and ti to infinity. In effect, okay, so it should not be confused with some other x. Okay, here x is t, which is going to be defined for every point on the positive real axis. So 0 to infinity, and it gets varied depending on each subject. Okay, depending on each subject. Okay, that we will let you know. So here we can see that we have some parameters ci, alpha I, okay, and then we have tot. Okay, so these things that will be defined now. Okay, so on the whole, what it says is, in essence, actually, if you have a value of x which is less than the failure time or death time of that particular individual, this membership function attaches 1. Otherwise, it attaches a value because it has survived only up to ti. So it cannot have a very big say on the values of ti greater than that. But still, it has some say. That some say is the weight that we attach, and that is governed by the denominator. Okay, we incorporate ci, as I mentioned, in alpha I, tot, etc. That we will see in the next slide. And see that ai, ci, wi, because in defining wi we use ti. Okay, so in that sense it's something like inbuilt structure that we have. Cen is the total number of censored subjects, and we have n number of observations, and you can see that the range how it varies. Okay, the range how it varies, and it's something very difficult to quickly grasp in. But all that I can suggest is that you have that u, l, okay, and other things. Okay, we will see how their values are fixed in the once we get into the simulation. So this is one reason why we have went for simulation rather than for real-time data. It's not a justification purely, but to some extent it's a matter of academic interest, so to say. So by adjusting these values, okay, I cannot even say adjust. See, L and U to some extent they are in our control. Okay, so we can see how low we can go for the estimation, and to some extent to get an offset we have to decide how high you have to fix the U. That is one way. But the other things, they make use of the censoring number, even censoring time of each individual to tune up CI, and that CI is indirectly putting into some other structure. Okay, so finally we can see that the pattern reflects relative weights in your membership function. So though we define all these values here, okay, ultimately they are going to have a say in your membership function in the previous slide. So you can see your CI. Okay, you can see your CI here, AI here. So in defining AI, we need CI. In defining AI, you need CI. If you carefully see, it is occurring the denominator. Okay, So some such link is there, and ultimately that is going to say what is your mu I of x. Once that pattern is captured, I think other things immediately it comes. Okay, immediately, because I am going to generate a function called gi of x. That is going to be my, okay, it is better you consider the second part first. Event. If ti is an event, okay, then I think it goes by comparing with the ti and x 1 or 0. If ti is not an event, then I cannot say something, so I cannot be 100% sure what is going to happen. In that case, your membership function that catch hold of the thing, and that is going to decide your gi of x. But in all, if you see the structure of mu I x, it is going to be something like a weightage which lies in between 0 to 1. Okay, strictly speaking, we cannot replace it by a probabilistic function. It is only a membership function as far as the fuzzy structure is concerned. And as far as and it is a sigmoidal fuzzy, that is also we have to say. So it's not something like a triangular or trapezoidal. It is a sigmoidal structure as we expected. Okay, as we expected. And see, we can say if it is 100%.
Excuse me, Vishwanath sir.
How many
The
more?
timing is running out. Please
Yeah.
make it fast.
Yeah, I will. Can I have 2 more minutes?
Sir.
Okay, fine.
Sure, sir.
Thank you. So when you have the x structure, okay, so based on whether it is an event, okay, and we can immediately decide it is 1 or 0. If it is not an event, as I said, your membership function catch hold. So in this sense, so for a particular x, see, not only one I is going to contribute, because you can see in the next definition of s hat of or x tilde of x, okay, that is going to average over all the n. So for every x in the survival function, okay, for every time point in the graph or every time point in the estimation process, we will be roping in all the elements with suitable weights. So every x, okay, all that matters is when x gets very large, okay, going towards infinity or going towards a finite, but okay, as far as the human lifetime is concerned, 100 or 150, something like that, we can make it. See, as it goes towards infinity, okay, so the weights may differ, but every individual contributes to some extent. So that is the idea. So we lose no information, and in a sense, we optimize maximum possible extent. Okay, so this is a simulation part. So all the structures we have said, so we are going to simulate. Okay, so I will, and it is okay, non-informative only. Okay. And the U I said capital U we fixed at 0.9. Okay, you can even go for 0.95, something like that. The thing is that as this gap increases between U and L, okay, the simulation time and other things gets to wait away, and we have to even take help of cloud computing to get the results. It goes for not even days together, not even hours together, at times even days together. So that is the length of simulation or the process that it takes place. So we have generated this, and I think we can go to the table quickly, and this gives the view. So the table on the first column gives the proportion of censoring, okay, and the sample size. And the first one is with respect to mean. Okay, so we started with a mean, and then we introduced cutoff by randomly generating the censoring. So we know what is the mean of the original distribution we started with. So we have the original distribution, and we have the mean from the estimated from the survival distribution using our fuzzy structure, and you can see the closeness of the things. Okay, so deviation is also present in the second set, so you can see how it works. Okay, so when the sample proportion is low, in between 15 to 30%, okay, you can see that particular km 2.9 and then 3 point, and our proposed estimator is in between the Kaplan-Meier and the original estimator. Okay, and as things proceed, okay, as things proceed in the sense that when we increase the percentage of censoring for that particular sample size, okay, that particular sample size, we can see our our estimator provides better or reduced deviation from the parameter. Okay, this can be seen almost for all structures, all structure in the sense sample size 10, 30, 50 we are repeating. and percentage of censoring. And also in the graph also we can see, okay, when the percentage of censoring is increasing, okay, so how proposed things happens, okay. So I think I will complete this. So going by our reduced mean square error is, I think we to some extent, of course, we have covered by varying to the maximum possible extent certain parameters concerning the things. To claim it universally, more work needs to be done. As I said, we can extend this because this does not include non-exponential structures. And here we are more bothered about censoring, which is censoring, right censoring. We can go for other types of censoring that can be a generalized thing that we can think of, and particularly informative right censoring, okay, because when if it is non-informative, independence occurs between the survival time and the censoring distribution. If informative right censoring is taking place, the complication gets multiplied, but the advantage is that once a generalized structure for informative censoring is developed, okay, we can make that correlation structure 0, and we can bring it down to what we have done, all these things, okay. Okay, I think so. Some references here.
Thank you, Vishnu sir, for vibrating the invited talk. Really,
Thanks for the opportunity, Professor.
Informative. Sir, please stop your sharing, sir.
Yeah, I am.
Sir, Kavi Arasu is available now? Sir, Kavi Arasu is available now?
Yeah, available.
Yes, sir, I'm available.
Okay.
Available.
Thank you, sir, Professor Viswanathan, for providing very valuable inputs on fuzzy approaches and other related contents. Really great presentation. Now I request the next presenters onwards. We are already running behind the schedule of 30 minutes. So please make your presentations be apt so that we can make the program within the framework. Please. Thank you.
So now sharing the profile of Dr. V. Kavi Arasu.
Welcome, Kavirasu. Welcome.
Sir, thank you, sir. Thank you very much.
Right.
May I present now? So may I present now?
Just wait, you will be introduced.
Okay.
You will be introduced to the delegates, then only your turn will come.
Okay, sir.
So, Dr. P. Kavi, so welcome you, sir. He is the Assistant Professor, Department of Statistics, Bharatiyar University, Coimbatore. He is presently working as Assistant Professor in Department of Statistics, Bharatiyar University, Coimbatore, from 2008 onwards. He served as a guest faculty at the same university for 4 years and lecturer in statistics at Dr. G.R.D. College of Science, Coimbatore for 1 year. He has an overall 15 years of teaching experience at PG level and research level. He completed UG and PG programs at PSD College of Arts and Science, MPhil and PhD from Bharatiyar University. He also qualified with state eligibility test for leadership in statistics, and further he qualified with the MCA program with the same university. He has guided 15 MPhil programs and 4 PhD scholars, and now one is awarded. He published more than 20 research papers in the national and international reputed journals. He also participated and presented his research papers in more than 20 national and international conferences overall in all over India. He organized more than 50 seminars and workshop programs in SPSS, data mining, etc. He has delivered more than 25 lectures in university and colleges. He also serving as expert in board of studies and a reviewer for research journals. His research areas interest is statistics, quality control, reliability studies, data mining, expert systems, data analysis, and analytics. He visited a few countries like Netherlands, Switzerland, Germany, France, and Belgium. So now welcome you, sir, to present your talk to this international conference.
Welcome, sir.
Thank you for your nice introduction. Thank you very much, sir, for giving me this opportunity to share my research interest in this international conference of the birth century of Professor C.R. Rao. My screen is visible?
Sir, please share your result. As it's coming.
Visible?
It is coming, sir.
Okay, sir.
Perfect.
Yes, sir. Today I'm going
it's
to
visible, sir.
talk about. Okay, sir. Okay, sir. Today I'm going to discuss about my research area, that is a role of zero-inflated Poisson distribution in small-scale industries for quality screening and their applications. So today there are many research works has been carried out in quality control in various parts, and Department of Statistics, Bayesian University is one of the department who is working in quality control research areas. So here I give an outline of introduction to statistical quality control and zero-inflated Poisson distribution, Bayesian sampling plan, in review of literature, and designing the methodologies in various approaches using Bayesian sampling plan, then followed by discussion and references. Due to want of time, I'm just going a little bit more. May I know what is the maximum time I can take? Okay. Statistical quality control is one of the important techniques applied in industry for controlling the product quality. The quality of goods are produced and services rendered has been monitored either directly or indirectly through statistical methods to maintain quality. Here, the monitoring method is statistically tested whether the variation occurring in manufacturing products are free from defects or not. So simply tested by acceptance sampling methods, and decision is made either to accept or not to accept the lot. So here, these techniques are developed based on theory of probability and statistics. Probability and sampling being extensively used in almost all small-scale industries, as manufacturing industries like textile industry, wood industry, electrical equipment industry, plastic industry, rubber industry, etc. Acceptance sampling technique is one of the important technique in statistical quality control. It's a statistical technique in which a small part or a fraction of units or items are selected randomly from the lot and inspected to detect whether the lot should have any defective items on the basis of the information provided by the sample. So acceptance sampling is a middle path, is a middle of the road approach, where there is no inspection, 100% inspection. The middle part is what we call by the sampling inspection. So here, the quality control, the inspector used to test the item by inspecting a walkthrough and checkpoint review he made, and he come to a conclusion whether how to their sampling plan has been tested. So coming to types of sampling plan, according to Professor Dodge, 1969, the major areas of sampling plan be classified under the following 4 broad categories. First one is lot by lot sampling plan, method of attributes, lot by lot sampling, the method of variables, continuous sampling flow of units by the method of attributes, special purpose plan, including chain sampling, skip plot sampling, RGS plan, etc., and many more. There are two major classifications of sampling band classified. One is action sampling by variables and action sampling by attributes. So in literature, if you go through, there are many sampling methods are available, like single sampling, double sampling, repeating group sampling, then chain sampling, skip plot sampling, then quick sampling, MDS sampling, RDS sampling. So all these sampling plans can be applied in both variable method and attribute method. So here, this research work is concerned, the designing methodology in the sampling plan, what we followed is, according to Case and Keats 1981, the designing methodology of sampling, they categorized into 4 types. One is non-Bayesian approach, another is Bayesian approach, and the other category is risk-based and economic-based. So usually we will frame 4 types of method, that is non-Bayesian based, non-Bayesian economic based, Bayesian risk based, and Bayesian economic based. But this method, what we followed here is a risk-based approach. So now coming to the role of zip distribution, that is zero-inflated Poisson distribution. So in the competitive world, every manufacturing company strictly follows certain procedures at every stage of production to maintain their quality. So in count data, when excess number of zeros are present in the, it can hold the Poisson variable. For example, we see a situation where the insurance claim received in two-wheeler insurance company, the number of cigarettes smoked by a student in a college, the number of defective items occurred in production of manufacturing items, etc. In all situations, the excess number of zeros comes and plays an important role. So in situation, the occurrence of defective items is a rare phenomena. So that is, the non-conformities lots would be more in number of excess number of zeros occur. So in using these methods, one can identify less defective lots, or the inspector can accept the products early. However, due to random fluctuation and some unavoidable reasons in manufacturing process, that may lead a situation to occur few defective products that are perfectly functioning in the production system. Sampling plan based on Poisson distribution has been often been used to the number of defects on unconforming sampling units. However, one of the major problems in the existing excessive number of zeros of non-conformities even in production process of a long run from a statistical point of view. So there we need an alternative technique which is applied. So there is this zip distribution can be studied in such scenario, which helps the management to take a precise decision, and it can certainly reduce the error rate than the regular Poisson model. When the manufacturing equipments are properly aligned in an order, and the number of defects are impossible, say it is aligned with the probability P, and the number of defects may follow lambda. So when this environment situation occurs, then we need to study the situation in a Bayesian sampling plan. So the Bayesian sampling plan, the basic assumption is the theory of conventional sampling plan by attributes is that the lot or process fraction unconformed is constant, which implies the production process is stable, and we'll consider the previous production also. However, in practice, the lots are formed from a process will have a quality variation that occur only due to a random fluctuation. Generally, 2 types of quality variations in lot may occur. One is within lot and between lot. So in that, the sampling inspection such as within lot variation, between lot variations can be studied, and it can be interpreted. In such situation, many authors studied the importance of designing of sampling plans under the Bayesian methodology. So this methodology can be used when the quality engineer has some prior information on the production process to make a decision about the disposition of the lot present. So here I will consider some review of literature for the zero-inflated Poisson distribution and Bayesian sampling plan. So Lambert 1992 has discussed the application of defects in manufacturing process with zero-inflated Poisson model. Rideout et al. 1998 has discussed some models for count data with occurrence of excess number of zeros. Boeing et al. Has studied a zip is better than Poisson in dental epidemiology research to measure dental health. And Rogers at 2003 have made some discussion about zero-inflated distribution with the Bayesian perspective. Naya et al. 2008 established A comparison between Poisson and zero-inflated Poisson regression model with the application to a number of black spots in a sheep. Muzida et al. Reported the zip distribution is a well-performed model. The excess number of counts data and its OC curve is studied. And Logan and Shaw in 2013 developed a table and procedures of single sampling plan by attribute under condition of zip distribution. Srinivasa Rao 2017 has designed the resubmitted lots, the attribute single sampling plan with zip distribution. Kavirasu and Asif T. Thotathil 2018 have developed and designing a STDS plan for zero-inflated Poisson distribution. So in Bayesian sampling plan, Holt has contributed the Bayesian sampling plan, proposed a model to determine a single sampling plan, polynomial distribution. Holt discussed the procedure to determine the parameters of Bayesian single attribute sampling plan. Then Holt in 1981 suggested a method to find a Bayesian single sampling plan by minimizing the average sampling. It showed the producer risk of under non-Bayesian and Bayesian plans are not same. Calvi 1999 pointed out that many practical situations the lot proportion uncommon will vary over the lots. Then later Suresh and Latta in 2001 determined the Bayesian single sampling plan under the condition of gamma Poisson distribution using the tangent of inflection point. Loganathan et al. 2007 derived the OC function of single sampling by the attribute under the condition of polio distribution. Studied the behavior of the OC curve with respect to various set of parameters. Vijayravan et al. 2000 analyzed the behavior of the OC curves of single sampling by the attributes under the condition of gamma Poisson distribution. Muzida et al. 2011 presented the method to determine the OC function of single, double, and multiple sampling plan under the different statistical distributions. And he said that the zero-inflated Poisson gamma is to study it's a powered infant formula. The later, myself and my research scholar have studied the Bayesian sampling plan for repetitive group sampling plan has been modeled. So here we a model of zero-inflated Poisson distribution is studied. A zero-inflated Poisson distribution is used for count data that exhibits for over distribution and excess zeros. In such a way, this model is assumed to be a mixture distribution that includes proportion of more number of zeros and a proportion from a Poisson model according to Lambert 1992. Here we consider x be a non-negative integer value and a random variable with the probability mass function of this model as p of x is equal to x given the omega comma lambda. Here we have as the how this model can be framed, and here the omega is the weight parameter and lambda is the Poisson parameter. When you put omega equal to 0, this model is reduced to Poisson model. It is termed as the mixing proportion of degenerate of zeros with Poisson model. Here omega and lambda are the parameters of the zip distribution. So according to Loganathan et al., the OC function of the single sampling plan under the zip distribution is given as follows. Where P denotes the lot fraction unconformities, and P of B is given as the equation, and omega ranges from 0 to 1, and lambda is always greater than 0, where omega indicates the inflation of zero defects in a sampling inspection plan with parameter lambda takes the value always n equal np. The next we have OC function of zip distribution under Bayesian perspective. So when you consider the Bayesian perspective, we consider the previous information. We consider the gamma distribution. When the number of non-conformities items the sample P, which follows zip distribution with parameter P comma omega, which can change from lot by lot, the gamma distribution is assumed to be the conjunction prior to P. It will be considered as a random variable. The probability density function of gamma prior distribution of P is defined as given by here, where P is equal to S by mu and expectation of P equal to mu, and P is a scale parameter, S is a shape parameter. So here S denotes the prior knowledge and it's estimated from the past history of the production process. Sampling plan for the number of non-conformity units X with prior distribution with zero-inflated Poisson distribution is defined by these equations given here. The expression of the gamma zip distribution has been given by here, like this. So what are the various designing methodologies we can follow using this gamma zip model? So here I'm talking about the basic quality levels. First of all, when selecting a sampling plan, whatever the sampling plan, I already said about single, double, and RDS, MDS, then CRGS, then quick switching system, then TNT sampling, skip plot sampling, and etc. Many sampling methods are there based upon a sampling plan, sampling scheme, and sampling systems. So here the design methodology, what we adopt for the sampling plan we're choosing, the corresponding parameters are selected through a set of specification for various quality levels, and producer and consumer risk are to be satisfied under the condition of the corresponding probability distribution. So the two incoming quality levels, namely AQL and LQL, are considered along with their corresponding relative slopes on the OC curve for the selection of various sampling plan. And also we consider the incoming quality levels is also considered for the study. So when you have the AQL, LQL, and IQL, we can able to derive the slopes according to Hammaker 1950 has developed the slope study. It's another designing methodology by deriving the first order. So we can able to have H0, H1, and H2, the corresponding with respect to the P0, P1, and P2, designing a sampling plan in a similar manner. Various other set of processes P1, H1, P2, H2, and P0, H0 can also be considered for selection of plans for the relative slopes. Similarly, we can able to design a minimum sum of risk. So Golub 1953 introduced the method and tables finding the acceptance number C for single sampling plan for specified AQL and LQL when sample size n is fixed for economic and administrative and practical purpose. By minimizing the alpha and beta the same and maximizing the 1 minus alpha and 1 minus beta with alpha is the producer risk and beta is the consumer risk. So the expression for sum of producer and consumer risk of Bayesian sampling plan is given by alpha plus beta is given the equation 1 minus PA of P1 plus PA of P2. So there are some advantages of using this approach. The OC curve is sampling plans, the better shouldering effect we can able to find. When the producer and consumer belong to the same company or they have same interest, the sum of risk may be minimized rather than fixing them by various quality levels. The other designing methodology, what we can adopt for this method is minimum angle method. So Norman Bush et al. Used different techniques to describe the direction of this OC curve. Here the method involves the comparison of some portion of the OC curve against the corresponding portion of the ideal OC curve. Here the smaller value of the cos theta implies that the curve approaches to the ideal OC curve when tan theta is given by tan theta equal to opposite side by adjacent side. So n tan theta is equal to mu 2 by mu 1 minus divided by 1 minus alpha minus beta. So the smaller value of tan theta is closer to the angle theta, which is closer to the angle approach 0, and the corresponding AB approaching to AC, the ideal condition through AOQ comma 1 minus alpha. So we get the theta equal to tan inverse of n tan theta by n. So by minimizing this, we get the defects will be very less and the minimum risk will be minimized. Similarly, we have another designing method, what we call by weighted risk approach. So in this approach, it is applicable when testing of sampling plan or system, which is costlier or destructive test can be applied. When the sum of the risk is minimized, the producer and consumer risk are considered, and the resulting plan may be unduly a disadvantage to them. In such circumstance, this approach will minimize the sum of risk with different weights alpha and beta respectively. If the sum is minimized, both risks are having equal weights. So in such situation, a consumer has a larger weight, then it can be assigned to the consumer rather than producer risk. So let us assume that W1 and W2 are the corresponding weights, such as W1 plus W2 equal to 1, which implies alpha W1 plus W2 beta can be minimized to obtain the necessary designing of plans. The weights of a desired plan has two properties, which are when omega is greater than 1, the plan will be more favorable to the consumer, while compared to equal weight of plan. When omega is less than 1, it will be more favorable to the producer. And one more design methodology, what I suggested here is quality interval method. The quality interval method is another method of available in sampling plan. Is derived based on the range of the quality instead of point-wise description of quality is called quality decision region or quality decision interval. So this method seems to be a versatile and method which can be adopted in elementary production situations. Due to rapid advancement in manufacturing technology, suppliers require their product to be high quality with very low fraction defectives, often measured in parts per million. So a traditional method in some fails to find out minute defect in the products. Not to overcome such problem, quality interval sampling time has been studied. So here we call it a quality decision region, probabilistic quality region, limiting quality region, and indifference quality region are the different methods, names we can have. So the behavior of the OC curve for single sampling time can be studied by a zip distribution, gamma zip and is compared, and we can say gamma zip can have available the middle part of the OC curve of single sampling under the condition of gamma zip than the zip distribution and the gamma zip distribution for the corresponding S, alpha, beta, and P1 and P2. So here I take a simple application, small scale industry, that is small scale manufacturers in food industries have the responsibility to produce quality products to the consumer with a good quality. So quality is not a one-time achievement, it is a continuous process. It's to be achieved continuously for every product what they are manufacturing. But it becomes a necessary part of planning, preparation, execution, production of foods. And when it becomes a lack of consideration of quality, can result a serious threat for public health. Suppose that a food quality engineer wants to run an experiment to make a decision of food product whether to accept or reject an item. Assuming the quality of food products follow the gamma zip distribution with the estimated value of the prior production process S is equal to 5. Suppose one wants to find the strength, the planned parameter of SSP, that is single sampling under Bayesian, or specific value of AQL, LQL. P1 is 0.003 and P2 is 0.008. With producer is alpha and consumer is beta, and estimated value of omega weight is 0.09. And we can able to derive the optimum sample size for the particular plan. So here we can able to compare the risk analysis given by gamma Poisson and zip distribution and gamma distribution. So here the values of producer risk alpha percentage and beta percentage is given, and the total risk specified strength P1 is fixed like this, alpha is fixed like this, P2 is fixed like this, and beta is fixed like this, and S is given is equal to 5, and we can find the optimum sampling plan. So when the different weights, we have different gamma zip weights. So you can see the risk of a producer and the consumer is minimized, and when you have the sum of risk of the alpha and beta is also minimized for the producer and consumer. So coming to the conclusion part. So for this, from this illustration, when the value of omega becomes large, the sampling plan under Bayesian zip distribution has performed better than the classical sampling plan under the zip distribution over the gamma Poisson distribution, because of gamma Poisson distribution gives a better than the gamma zip distribution gives a better than gamma Poisson distribution. It should be noted that when the production process is zero defect manufacturing environment, the proposed plan will significantly reduce the producer risk as well as the consumer risk simultaneously. It is observed that from the table that the optimum gamma zip sampling plan may require more items to be sampled from a lot submitted for inspection. However, it reduces the risk of the producer regarding the rejection of good quality lots and safeguard the consumer against the poor quality lots with an assigned risk. So with this view, I thank the organizer for giving an opportunity to share my research experience in this international virtual conference. I personally thank our Professor Tirupati Rao for giving an opportunity to share my research area. So thank you one and all.
So thank you, sir, for your informative and a vibrant talk. So thank you very much. On behalf
Thank
of
you,
the
sir. Thank you, sir.
organization.
You may allow some questions, Ramakrishna.
Yes, sir.
You may allow for some questions.
Yes,
So,
one or two questions.
Any questions from
Yes, sir.
participants and inviters?
Raj,
Raj,
Any
about
questions?
Good afternoon, everyone, and good afternoon, Professor Kaviyaris.
Definitely, sir. Tell me, sir.
Your presentation has been nice, and zero-inflated Poisson distribution and comma zero-inflated Poisson distribution are all extensions. They
Yes,
might
sir.
be having a lot of applications. My
Okay,
one
sir.
simple question for clarification is whether
Yes, sir.
we are able to identify the industrial situations where these basic assumptions are satisfied.
Yes, sir. Actually, it's really a good question, sir. We fix the parameters and assumptions. So
Yes.
based upon the requirements of the products, what products we are taking for inspection is the first point we have to keep in mind. And what could be the production, is a continuous production or lot by lot production, that also take into consideration. So based on this only we can fix the application, sir. We cannot fix for, we can give for whatever the methodology. So we have some assumption and conditions. So when we fulfill these conditions only, we can apply the methodologies.
Yes, that is there. The success
Yes,
of our research is
Yes, sir.
to reach in the industry. It is, if
Yes.
it is possible to identify the industrial situation, whether our models will fit,
Yes, sir. That is
will
what.
be the success of our research.
Yes, sir. That is what I told for small scale industries, because today we
Yes,
have large
yes.
scale industry, the automatic production is coming. So Coimbatore city have a lot of small scale industries. So these industries, they will not go for 100% inspection, or they won't go for without inspection. So they should go only with some sample inspection. So that is what I give an example. Suppose they jam manufacturing company, they're producing the jam bottle, or the sauce manufacturing company, they produce the packets of sauce. The sauce packets, they can have such applications of this zero-inflated Poisson distribution. That is what I give two example of food industry for the zip distribution.
You are right, Professor Kaviyaris. Yesterday also I have asked the same question for some other Rayleigh model, I suppose. My objective of raising such queries is to encourage you researchers and your research scholars to identify for industrial situations to apply our models. If at least one or two popular industries apply our model, then they will come in search of statisticians. As mentioned by yesterday's talk, Professor Lakshmana Rao and others, how statistics is being misused because we are not involved. They use the statistics as their convenience. That's my objective. Thank you.
Thank you. Thank you.
Sujata madam is available?
Yes, sir. Yes,
Okay.
sir, I am available. Is it audible? Sir, is it audible?
Audible, madam.
Okay,
Audible,
sir.
madam.
Available.
Now presenting your profile, madam.
Okay, sir. Thank you.
Wait a while, madam.
Okay.
It takes several minutes, madam.
Okay. Okay, sir, no problem.
Madam, present now, want to present or what? Hello?
No, sir.
Are you want to present, ma'am?
No, sir. I will
Yes, no.
present, sir. My PPT with me. I will present, sir. Thank you.
No, just click your present now. Entire screen. Select entire screen.
Ramakrishna sir is doing that. Sir, Ramakrishna sir is present. Otherwise, you come out again, you present.
Ramakrishna.
He's already presented. So it takes time.
No. Madam was introduced yesterday, it seems, as a guest.
Yes, correct.
Yes, sir. Yesterday already I introduced.
Introduction part is over. Let us start, madam. You start.
Okay. So now, welcome Captain Dr. K. Sujata Madam. He is the professor and head of the Department of Mathematics, St. Joseph College for Women. So now, inviting Madam, please give your talk.
Yes, sir. I will present and I will start, sir.
You can share your PPT, Madam.
Sir, is it visible, sir?
It's coming, ma'am.
Okay, sir. Thank you so much. Thank you so much, Professor Ramakrishna, sir, for introducing me. And good afternoon, one and all. This is Dr. Captain K. Sujata, Professor of Mathematics, St. Joseph's College for Women, Visakhapatnam. And first of all, thank you so much to the organizers who has given this opportunity to share my research work. And also, I'm very, very much thankful to my guide and philosopher of Professor KPR Sastry Garu. He is a retired professor, Andhra University, Visakhapatnam, who is everything is what my research work entirely is behind with me. And in this talk, I am going to discuss what are the main recent developments in fixed point theory and its applications. Actually, in real life situations, we can use applications in various fields directly and indirectly. And in indirectly means we can apply these applications in biology, chemistry, economics, and engineering. Whereas in the directly, we can use in the real life situation, in real life traffic light signals in some, etc. In some areas, we can use these applications. And Professor Lakshman Rao, what I saw in the morning session, Professor Lakshman Rao sir rightly said mathematics research coming towards statistics. Yesterday I have seen some presentations in statistics. So many real life applications are there in statistics. Really, I very much satisfied and very much interested. If you give a chance to the sir, Professor Rao sir, then I too want to do some research in towards your operation research and in statistics, sir, if you give the permission. And I'll after that I'll go into touch with you. Then I'll ask, sir. And all these lectures in this international conference, almost in statistics and are having so many real life applications are there. Really, I'm very much thankful to the Professor Tirupati Rao sir. I got this chance to listen all these lectures in statistics. And mine is a pure mathematics and mathematics research. So now I'm going to coming to my field. No, fixed point theory. Main thing is my topic is the fixed point theory. My research towards in fixed point theory. In this, various fields are there. Now, in fixed point theorems, provide conditions under which maps, which are singular, multi-valued, have solutions. The theory itself is a beautiful mixture of analysis, topology, and geometry. Over the last 80 years or so, the theory of fixed points has been revealed as a very powerful and important tool in the study of non-linear phenomena. In particular, fixed point techniques have been applied in such a diverse fields as biology. That's why I told this indirectly we will use the fixed point theory. in real life, that is in biology and chemistry, economics, engineering, game theory and physics will use the fixed point theory. And fixed point theory plays an important role in function analysis, approximation theory and differential equations, applications such as boundary value problems. Fixed point theory has a lot of applications, not only in the field of mathematics, but also in various disciplines. Results of this kind are amongst the most generally useful in mathematics. Now, this is a definition of the fixed point. Everyone we know, suppose X is a non-empty set, a mapping T is a mapping from X to X is called a self-map of X. If there is an element X belongs to X such that Tx, the image of X, the image of that is a T of X is equal to X, then X is called a fixed point of the self-map T of X. Now, in fixed point theory, broadly speaking, demonstrate the existence, uniqueness, and construction of fixed points of a function or a family functions under diverse assumptions about the structure of the domain X, such as X may be metric or normal linear space or topological space of the concerned functions. The methods of the theory vary over almost all mathematical techniques. These are many works entirely devoted to fixed point theory. No, one of the most famous theorem is that is of author is in fixed point theory, Banach. He founded a modern functional analysis and made major contributions to the theory of topological vector spaces. In addition, he contributed to measure theory, integration, the theory of sets, and orthogonal series. In his dissertation written in 1920, he defined axiomatically what today is referred to as Banach space, the famous theorem Banach space. On the other hand, some of the interesting properties of Banach spaces are there: fixed point and weak fixed point properties. Hilbert spaces and uniformly convex Banach spaces are more generally reflexive Banach spaces with a normal structure have these fixed point properties. Due to the importance of fixed point theory and its applications, it is worthwhile to highlight recent advances made by mathematicians actively working in fixed point theory. So this lecture aims to give original research and review articles with a focus on the latest advancements in fixed point theory and its various applications to pure, applied, and computational mathematics. Now, some important topics for research, but are not limited to the following: fixed point approximations, nonlinear optimization, global optimization, engineering applications of fixed point theory, mathematical modeling via fixed point theory approaches, convergence of iteration approximations and applications, coincident point theory and applications. So you can select anyone in this topic, you will get the research and more more results in this. And fractional, differential and integral equations, operator equation and inclusion problems, and open problems related to fixed point property. Now, fixed point theory is a growing and exciting branch of mathematics with a variety of wide applications in biological mathematical sciences and proposing newer applications in discrete dynamics and superfractals. The present endeavor is to report the latest trend. This is a present research topic in fixed point theory, metric fixed point theory, emphasizing newer applications in numerical analysis, discrete dynamics, and fractal graphics besides traditional applications. The articles have been selected carefully so that the book is useful for sophomores up to the senior teachers, researchers looking for new materials and new ideas in the existence of fixed points, and new applications and survey articles. These are the recent developments in fixed point theory and its applications. Now, fixed point result for Garratti quasi-contour. These are recent recent survey they are done in this. Fixed point result for Garratti quasi-contraction type mappings in dislocated quasi-metric spaces. In this work, the fixed point results for newly introduced Garatti quasi-contraction type mappings are proved in more general metric spaces called T arbitrarily complete dislocated quasi-metric spaces. If you go through this survey and this article, this paper, we will get what about the Garatti quasi-contracted type and dislocated quasi-contracted type. just what they have discussed in this work, what they did their work, I am explaining. Gerati quasi-contraction type mappings generalize and amongst others, and Sirix quasi-contraction mappings and other Gerati quasi-contract type mappings in the literature they have seen, and fixed point results are obtained without imposing the continuity. So continuity condition they are not taken. Without imposing the continuity condition, fixed point results are obtained on the mapping, thereby further generalizing some other work in the literature, and examples also given in this work. And short and another research work is recent work is short and sharpened way to approach fixed point results involving fuzzy Mackel H contractive mappings. In this paper, they adopt a short and sharpened approach to prove fixed point results involving fuzzy HH contractive mappings. This process, they are able to relax some conditions utilized by the earlier authors, which in turn, this is an interesting paper also, which is in turn yields affirmative answers in some open questions raised by the earlier authors. A common fixed point, this is another one, common fixed point theorems for 2 and 3 mappings. In this survey, they provide common fixed point theorems for 2 or 3 commuting mappings, which generalize Darbo's fixed point theorem. An explicit example is given for the illustration. A contractive condition in terms of the measure of no compactness, firstly used by the Darbo, is one of the fruitful tools to obtain fixed point and common fixed points. And there are many extensions of this condition, which are known as generalizations of Darbo's fixed point theorem. Now, another survey is related Suzuki type fixed point theorems in ordered matrix space. In this survey, they use a Suzuki type. These are different one, and compared to the other research works, they have given the name as Suzuki type contraction to prove their 3 fixed point theorems for generalized contractions in an ordered space equipped with the 2 matrix. They obtained some generalizations of Kannan fixed point theorem, and their results on partially ordered matrix spaces generalize and extend some results of Rand and Ray rings, as well as of Newton and Rodrich-Lopez. And to illustrate the effectiveness of their main result, they give an application to matrix equations which involves monotone mappings. Now, it is well known that Banach fixed point theorems plays a very important part in the resolution of the various problems in non-linear analysis, such as integral equations and various non-linear problems. It also has applications in various scientific disciplines. This theorem knew intense generalizations by the introduction of various types of contractions. Now, another survey is ordered SP matrix spaces and some fixed point theorems for contractive mappings, which applications to periodic boundary value problems. In this survey, they introduce a structure of SP matrix spaces as a generalization of both SP as S matrix space and as well as a SP matrix spaces. Also, this is also latest one, SB matrix spaces. On this, so many results came. Also, they present the notion of S contractive mappings in the setup of ordered SP matrix spaces and investigate the existence of fixed point for such mappings under various contractive conditions. They provide examples to illustrate the results presented herein. An application to periodic boundary value problems also presented. There are a large number of generalizations of Banach contraction principle via using different forms of a contractive conditions in various generalized matrix spaces. Some of such generalizations are obtained via contractive conditions expressed by the rational terms. Now, another survey is F contractive type mappings in B matrix spaces and some related fixed point results. This paper, they define F contractive type mappings in B matrix spaces and prove some fixed point results with suitable examples. F expanding type mappings are also defined a fixed point result is obtained. In 1922, Banach proved the fixed point theorem for metric spaces, which later on came to known as a famous as the famous Banach contraction principle. This is a famous Banach contraction principle in fixed point theory. Since then, generalizations of contraction principles in different directions, as well as many new fixed point results with applications, have been established by the different researchers. It is a well-known fact that every Banach contraction is continuous. In 1968, Kannan proved an independent result without assuming the condition of continuity of the mappings. Now, relation is another survey is a relation theoretical coincidence and common fixed point results under FRG contractions with an application. In this survey, they begin with some observations on F contractions. Thereafter, they introduce the notion of FRG contractions and utilize the same to prove some coincidence and common fixed point results in the setting of metric spaces endowed with the binary relations. An example is also given to exhibit the utility of their results. They also deduce some consequences in the setting of ordered metric spaces. And as an application, they investigate the existence and uniqueness of a solution of integral equation of Volterra type. The celebrated principle, namely Banach contraction principle, is one of the pivotal results in nonlinear analysis. Now, another survey is some results on fixed point theory for a class of generalized, there's a different one, class of generalized non-expansive mappings. In this paper, they introduce a new class of generalized non-expansive mappings, which is wider than the class of mappings satisfying the C condition. Different properties and some points, and some fixed point results for these mappings are obtained here. The convergence of some iteration schemes to the fixed point is also discussed with suitable examples. The generalization of non-expansive mappings and the study of related fixed point theorems with the different practical applications in nonlinear function analysis have found great importance during these recent decades. Now, common fixed point theorems for finitely family multi-valued mappings in an ordered Banach space is another survey. In this survey, they prove some common fixed point theorems for a finite family of multi-valued and single-valued mappings operating on ordered Banach space. Their results extend and generalize many results in the literature on fixed point theory and lead to existence theorems for system of integral inclusions. A good part of the research publications on the fixed point theory was devoted to the existence of common fixed points for pairs of single and multi-valued functions in various types of spaces such as metric spaces, ordered spaces, and so on. Now, fixed point theorems for a class of generalized weak cyclic compatible contractions. In this manuscript, they establish coincident point and a unique common fixed point for a phi and psi weak cyclic compatible contractions. They also present a fixed point for a class of weak cyclic compatible contractions via altering distance functions. Their results extend and improve some well-known results in the literature. They also provide some examples to analyze and illustrate their main results. The iteration scheme of approaching the common fixed point for finite family mappings. In this, they introduce the new algorithm, the horizontal algorithm in a real Hilbert space for approximating a common fixed point of a finite family mappings without imposing on the finite family or of the control sequences and the conditions that for each. Furthermore, under approximate conditions, the horizontal algorithm converges both weakly and strongly to a common fixed point of a finite family type 1 demi-contractive condition mappings. It is also applied to obtain some new algorithms for approximating a common solution of an equilibrium problem and the fixed point problem for a finite family of mappings. Their work is contribution, ongoing research on the iteration schemes for approximating a common solution of fixed point problems of a finite family of mappings and equilibrium problems we will get in this. The fixed point theory, this is also latest one in cone metric space. This is a different one and compared to the others, remaining one. One extension of metric space in this metric space is so-called, we call it as a cone metric space. In cone metric spaces, the metric is no longer a positive number, but a vector. In general, an element of a Banach space equipped with a cone. Then we call it as a cone metric space. In 2007, Hong and Xian introduced the notion of cone metric space and established some fixed point theorems in cone metric spaces. An ambient space which is obtained by replacing the real axis in the definition of the distance by an ordered real Banach space whose order is introduced by the normal cone P. Now, my research in this area, cone metric spaces. So the objective of my research is to study fixed point theorems in cone metric spaces and cone metric spaces with weak distance. One extension of the metric space is called a cone metric space. In this, metric is no longer. So this is becomes a instead of metric, no longer a positive number. So we'll take the metric vector. In general, it is a element of a Banach space equipped with a cone, that we call it as a cone metric space. Now, in 1906, the French mathematician Fréchet introduced the concept of metric spaces. Although the name metric is due to Hausdorff, in 1934, Doro proposed a metric space in which an ordered metric space used as the codomain of the metric instead of the set of real numbers. In literature, metric space with vector-valued metrics are known under the various names such as pseudo-metric spaces, K-metric spaces, different types of metric spaces they named, and generalized metric spaces, cone-valued metric spaces, cone metric spaces, and abstract metric spaces, and vector-valued metric spaces. Fixed point theory in K-metric spaces was developed by Prof in 1964. This is a cone metric space by with weak distance was introduced by 1996 by Osamakada and Suzuki and Wataru, and these three, they first introduced weak distance in cone metric, weak distance in metric space. Now, after that, in 2009, Lexigen and Arabiani extended the above notion, that is a metric space in W distance. They introduced the notion of cone metric space W weak distance or W distance and proved some fixed point theorems, proved for fixed point theorems. Now, identified and derived some extensions of Banach contraction principle for a cone metric space also, which is not necessarily normal. So generally the normal cone metric spaces, we will do so much research in that, and identified and derived some extension of Banach contraction principle for a cone metric space which is not necessarily normal also is there. The cone metric spaces and fixed points theorems for generalized T contractive mappings, some fixed point results in cone metric spaces with weak distance, fixed point results under C distance in TVS cone metric spaces also done in my research area. And main objective of my research is to study fixed point theorems in cone metric spaces and cone metric spaces with weak distance. And common fixed point, this is one area. Common fixed point theorems for two self maps and in a cone metric space with weak distance, and fixed point theorems for a self map in ordered cone metric spaces under lattice ordered C distance. Now, in this lattice ordered C distance, I have done the minor research project on fixed point theorems for a pair of self maps in ordered cone metric spaces under lattice ordered C distance. This is a fixed point theorem self map. This is a pair of self maps in ordered cone metric spaces under the lattice ordered C distance. Some fixed, these are the recent, this is the recent work I have done. So some fixed point theorems in dislocated quasi B metric spaces. Fixed point results in SB metric spaces via alpha, phi, psi, generalized weakly contractive mappings. This is my work. These are some references are given. Thank you.
Okay, thank you, madam, for your informative, elaborate talk. So, any questions?
There's a pure mathematics.
It's a pure mathematics.
Pure mathematics. Now, some
Madam, please stop your sharing, ma'am.
Yes, sir. So, some references also, so many references I have given. If you want, I can go through. I will stop my sharing, sir.
So, Dharmaraj is there? Dharmaraj? So Dharmaraj is there?
Yes, he's available. He's available.
I see, sir.
Yes, sir. Namaste, sir.
So welcome, sir. So now our profile. So all of we are teaching profession, but whereas Dharmaraj sir is a scientist. So we have a recent research. The contribution of sciences are very necessary. So meanwhile, I can introduce this Dharmaraj sir. So later it will be shared. It takes time. So Dr. Dharmaraj sir is a scientist in biostatistics, ICMR, NIREH, Bhopal. He did PhD at Department of Statistics, Institute of Science, BHU, Varanasi. And he received so many awards. So he is the editorial board of London journals. Press has recognized it as the quarterly Franklin membership on 5th May 2020. The Council of Science and Industrial Research, CSIR Award Junior Fellowship in Mathematical Sciences 2017 and ICMR Award Junior JRF in Social Sciences in 2013 and UGC Award JRF in Population Science in 2013 and the scholarship from National Organizing Committee of Third International Conference Asian Population Association in 2015 and Census Data Dissimulation Award, third prize for best paper by the Registrar General and Census Commissioner of India 2015, the Government of India Fellowship for pursuing MPS course in International Institute for Population Sciences, Mumbai. A life member in Indian Association of Study Population and Indian Association for Social Science and Health and Indian Society for Medical Sciences and abroad visitor for the academic purpose. So he visited the Malaysia and Bangladesh and he organized 3 seminars and he presented papers and in national international journals in these 9 and he presented 22 papers presented in conferences and he organized 14 training and workshops and he is not only a scientist, he is a humanitarian, his extra activities shows like that and his contribution toward the community development act is also very good. So now, so I welcome you, sir, for this international conference.
Thank you, sir.
So, sir, please share your PPT, sir.
Yes, sir, I am just going to. I am very thankful to Dr. Tirupati sir, who provide a platform to young scientists to present our information on this platform. Today I am just going to present environmentalists and emerging science. Universally, the rapid pace of economic growth has been accompanied by the resource depletion and the environmental degradation, air and water pollution, water scarcity, desertification, and the depletion of natural resources are beginning to have adverse impact on almost from the economic activity by causing frequent disasters such as flood and the landslide, and the generally diminishing the quality in their life. To address those problems, a broad-based program of environmental policies and regulation is needed. Such program requires that we collect and compile authentic environmental data for the use of government officials and other decision makers. Data relating to existing environmental conditions is crucial for environmental planning and decision making. India is in the path of the rapid economic development and will therefore need to collect the information statistics way. The objective of the environmental statistics to provide the information about the environment, its most important changes over time and across location, and the main factor that influence them. Ultimately, environment statistics aim to provide high quality statistical information to improve knowledge of the environment, to support evidence-based policy and decision making, and to provide the information for the general public as well as for the specific user group. Environment statistics are multidisciplinary and cross-cutting involvement numerous sources and the stakeholders. As of the population, everyone health in consideration as the equilibrium. Our ecosystem, as we are human, as part of this ecosystem. Our climate is fully associated with our health. In this COVID-19 era, our environment has some fluctuation which is become healthier. At the all India level, during lockdown 21 days data and pre-lockdown 21 days data, we have compared the air quality index. In between this duration, our air quality index is become healthy. Number of cities where the quality is before the lockdown, 121 cities are unhealthy situation, and during first 21 days of lockdown, only 33 cities is unhealthy, and very drastic change that we have a good environment. Nitrogen, NO2, NOx, and with ozone correlation, we found that ozone is continuously decreased during the lockdown, which is after the lockdown again continuous. There is much variation. In Madhya Pradesh, there is 16 city information about particulate matter 2.5 and sulfur dioxide, carbon dioxide. There is number of changes which have seen here. You know, one of the interesting information in this presentation, when we measuring the NOx from, we find in Odisha there is one station from in all about India. Central Pollution Control Board have more than 200 stations. From there, they continuous recording the information about the environment. In Odisha, there is one station who is stopped or from during the lockdown. They recorded very high value when it is not possible to one-to-one check the data. But when we special pictorials that we find that there is a that point means that machine is giving the wrong record. So we analyze as presenting any information too much care about these of the information. In first 1984, the United Nations Statistics Division made a framework for the development of environmental statistics. It is present with environmental condition and quality with the environmental resource and their use, their residual, stream event and disaster, environmental settlement and environmental health, considering the environment protection management and engagement. There is continued session is ongoing in 2010 there was a meeting. In 2013 there was a meeting. From the Mosby ADJ of the CSO was as leading in that as an expert team. We have many issues: air, climate, land, soil, water, fresh resource, and these are the some information which is the making indicator for the framework. We have showing a interesting thing at that point, and direct at web. This is the worldcount.com challenging planet Earth. This is the site where we got information as instant. This is visual or not planet Earth. Hello? There is the number of planet Earth we need. As we produce resource and observe our waste, 1.77 Earth we need. Just our planet as Earth is not bigger as we want to degrade their resource. And there is a tons of resource straight from Earth is continuing information. As world population is continuing growth, today how many population is growth? There is 1,12,000 from today. In our population is growing on the Earth. Continuously, we get a lot of information here as Earth running our food, and time left till the world run out of fresh water. As we need our water only just less than 20 years, we have the fresh water to as for whole population. Also, today we have tons of solid waste generated. On this Earth, we have generated a lot of waste daily to daily. In the COVID scenario, when we got a lot of death due to the COVID, there is also a very huge death by the air pollution. Today, air pollution have death from the air pollution. Today, 13,000 death occurs due to the air pollution, which is also a very drastic scenario for the population. We not aware how much air pollution is for the worse for human. Also, this indoor air pollution is also a very critical scenario that from today we not have this type of death due to COVID, but we have indoor air pollution 5,000 deaths today. Just any can see, and I am just going to my presentation. So we have seen there a lot of information worldwide that organization is continue compile. So we want on the aspect of India, each state, each district has such type of platform where all the information like statistics about birth, death, migration, air pollution, water lagging, a lot of information should be continuous for the society. During the lockdown, I have an online survey about 508 individual participants. The perception and practice of community regarding prevention and opportunity for making social and environmental change in India. I have to emphasize there is some action for which individual their response in yes or no. This is the mostly every in the respect of gender and residence, every person mostly have emphasized to need that build better the environment, to encourage plantation, especially medical plant and the collective level. This is the some information. So when we have gradually restricted to use of AC and refrigerators, this have only 1/3 of the population have support that. So this is the our need, but we want to reduce this type of the facility. So during the before the COVID and after the COVID and during the COVID, there is all of data are needed. So every statistician who gathered the data is data variant. So here is type a water type. Water type, just think anywhere a water type, we just open and we have a pre-assumption. When we open the tap, there is flowing of the water. So when we say the probability of the water flowing or not, theoretically this is 0.5, but we find out 0.99 as 99.99%. We have find out that whenever we open the tap, the water is flowing. So we find out that behind this there is a lot of factor. Anywhere the water is gathered and the pipeline, this is the scenario. So our environment should be influence a lot of sector. In the environmental statistics, the living legend Professor C.R. is contributing in their Handbook of Statistics, Volume 12 and 18, with the in 1994 with the G.P. Patil sir, and in 2000 with P.K. Sen sir. Professor C.R. is also having their attention about the environmental study, which is very thankful to him, and I am very thankful to again to this platform. You are please thankful to you all.
Thank you, sir. Thank you for your very informative talk. Any questions?
Congratulations, Dharmaraj, for your nice presentation. And you have coined a new discipline, that environmetrics. Good. We have econometrics is there. Okay. Environmetrics is a new emerging discipline where your contributions are very much useful and give some impact. As you really pointed out that the relevance of statisticians and data analysts' role is very much essential to explore the hidden inputs of the data, hidden intelligence of the data, particularly in the context of environment related. You are correctly computed the correlations between the nitrogen oxide and the O3 levels, so that the correlation, the more the correlation negative, it indicates the danger signals. So we have to see that to keep the healthy levels of ozone or oxygen levels, we have to make this nitrogen monoxide, NO, and nitrogen dioxide, NO2, at healthy levels. So these are all will be known if we made a proper analysis of it. Really, as a scientist, your contributions towards the research is, and my salutes to the scientists working from different parts, and now they are taking statistics is an essential discipline which is indispensable for exploring the hidden intelligence. So your work has again proven and established that to understand the indicators or key performing indicators within the data, we have to do a proper analysis. Your work will contribute definitely much for the part of the coming research fields. Congratulations, keep it up.
Thank you, sir, for providing me the platform.
Thank you. Over to chairman of the conference. I mean,
So,
chairman of the
thank you, sir. Now the last invited talk of today's morning session. So she is Dr. Chaitanya Priya, Department of Mathematics, Jazan University, Kingdom of Saudi Arabia.
Welcome, madam.
So she received.
Yeah.
Madam, is it available?
Yeah, she is there.
She received 2 gold medals in.
Your mic. On your mic. Chaitanya. Yeah.
Yes, sir. Yes, sir. Yeah.
Okay. She received 2 gold medals in MSc Statistics, and she received meritorious research fellow grant from UGC, and reviewer for the journals Asian Research Journal of Mathematics and the Journal of Modern Applied Statistical Methods.
I'm unable to see her profile. You are speaking something and showing something. Yeah, now it is okay.
So, and she presented papers, 5 papers in national conferences and 2 papers in international conferences. And she published 10 papers in reputed international and national journals. And she has 6 years teaching experience for various graduate and postgraduate students at Jazan University, Kingdom of Saudi Arabia. So now I welcome you, madam, to present our talk.
Thank you, sir. Thank you.
Make it brief, madam.
Yes, sir. Yes, sir.
We are running back behind the schedule. Right.
Is it? Are you able to see the screen, sir?
No, not yet. You just share it. I think still it to come. Wissam.
Yes, sir. Yes, sir.
Sir, is it visible now?
Yeah, now it's coming. It's perfect.
Yes, sir. So before starting my presentation, I would like to thank the organizing committee for giving me this opportunity to present some work of mine in control charts. The topic that I have chosen for this talk is importance of sampling techniques to retrieve control charts. So the overview of this talk is control charts and its importance. What are the existing control charts that we have and significance of sampling? What are the sampling techniques that we use, simple random sampling and ranked set sampling, and the other modifications, and what is the further research scope in this area that I would like to discuss in this talk. So control charts and its importance. Basically, any process, any production process, though how much precautions we have taken, variability is always will be there. So there are 2 types of variability. One is due to chance causes, which is negligible, and the second one is due to assignable causes, which we have to take a proper care. So control charts are the graphical procedures to take care of those assignable causes, and if any production process containing assignable causes, we said it as an out of control process. So Shewhart in 1920s, that means it's already 100 years that he has developed the technique of control charts. And within this 100 years, there is a vast research has done, still going on by using the Shewhart control charts. So it is very popular control technique to identify the process, to identify the assignable causes in the process. But there are certain limitations for this Shewhart control charts. The first one is the normality assumption. In general, in practical data, normality assumption fails. So, and sometimes these control charts cannot identify the slight deviations from the aim, and these are not flexible also. And average run length also doesn't perform well when we are dealing with these Sheward control charts. So there is a scope for the new techniques that we have to use. So in these 100 years, almost so many new developments have been done in the research considering the control charts. So basically there are 4 types of control charts. One is sequential control charts, adaptive control charts, standardized control charts, and special control charts. So sequential control charts, when the normality assumption of the data is not respected, so they give false alarms. So in such cases, instead of Sheward charts, we can use sequential control charts also. The drawback of these Sheward charts is it uses the information about processing originating from the last observation of the sample and ignores all the information provided by a whole sequence of points. It also causes them to become less sensitive to small changes. In such cases, there are a vast number of techniques available in research, like a QSUM chart, moving average chart, exponentially weighted moving average chart. So many authors have done research. To name a few: Page, Lucas, Loberts, Montgomery, Hawkins, and RRL, Kantham, Chan, etc. These are all the they have done an extensive research in these areas. And the second type is adaptive control charts. These are alternative. We can say in another way that these are the alternative to the sequential control charts. They are very sensitive to small changes. In general, the design of these operation of the control chart requires 3 parameters. The one is sample frequency, sample size, coefficient of control limits. So if one of these parameters is changed in real time, depending on the position of the observation of the previous sample with respect to control limits, so if there is any change in these 3 parameters, we can go for these adaptive control chart techniques. So they are more efficient than the Sheward control charts because they are using the archived data. So the techniques that are available are variable sampling size control chart, variable sampling interval chart, variable parameter chart. These are the existing choices for normal cases, if the data is following normal distribution. For non-normal cases, we can go for symmetric or asymmetric bar charts. And standardized charts, in the case of if the production is characterized by short series. These charts are versatile in application and do not require any prior assumptions. These charts are perfect for analysis of products with different parameters on a single chart. The various techniques available are Z, Z star, U star, P star are the choices here. And the special charts, some special cases occurs when we are dealing with the practical data, such as short series data. In that case, we can use deviations from nominal chart, mean and range short run chart, Q chart, and multivariate distributions also, multivariate data also we can go for Hotelling T-square, generalized variance, etc. And for even we can use for monitoring the time between events. That also we can consider. And for if other than normal, if that is depending on the coefficient of skewness, depending on the coefficient of kurtosis, we can identify and we can find the control charts based on those methods, and weighted variance method also, weighted standard deviation method also. There are certain other alternatives that we can use. And in the case of autocorrelated data also, regression control chart, coefficient of variation chart, there are so many techniques that are available. And even I have worked extensively with my professor RRL Kantham sir about skewness correction, kurtosis correction control charts. Out of all these sampling techniques, out of these all control charts, sampling plays a crucial role. So what is the significance of sampling? The correctness of information obtained for the population strictly depends on the unbiasedness and efficiency of the sample. It is of crucial importance to use efficient sampling methods so as to achieve better statistical inference. The purpose of a sample is to have it as a complete representative of the population. So the first choice that comes to our mind is simple random sampling, because it is a subset of individuals chosen from a large set of population. And till now, even if we talk about a sample, definitely the best choice we feel is simple random sampling because of its own advantages. ease of use and accuracy of representation, lack of bias, no need to divide the population into subgroups. Each member of the population has an equal chance to be a part of sample, but it is having its own limitations. The time needed to gather the full population, it is time consuming. When the sample is not large, bias, there is a chance for the bias also. So what are the alternatives that have been used instead of simple random sampling in the construction of control charts? Yes, authors have used double sampling in 1974 itself, and importance of stratification has been discussed by Chang and Lu in 1995. So in general, what we think is the average of the sample estimate of means of subpopulations so determined must be the unbiased estimate of the population mean. So apart from these double sampling, stratified sampling, two-phase sampling, there are other important technique already discussed, defined by McIntyre in 1952, which is he suggested ranked set sampling. He proved that it is more efficient than simple random sampling, and also identified that the distribution of the population is symmetric, then the efficiency gain is high. If it is not symmetric, then the efficiency is low. He proved like that. And the procedure of ranked set sampling is, if we want to choose n samples, we have to first collect n square sample units and make them into group them into n groups, and within each group we have to rank them, and from the first group we have to take the first rank, and in the second group we have to take the second rank, and so on. We'll get n ranks data. And if we want to have
Priya, sorry for interruption. Can you put it in a slide mode so that lettering will be more? Slide mode will exist.
Okay, sir. Yeah.
Okay,
is it okay, sir?
Yeah, it's good. Now it's good.
Yeah. Sorry, sir. So if we want to have more samples, then we have to repeat this process, and I have given a picture here how the sample will be. The advantages: the ranked set sampling gives not only unbiased and more precise estimates of the mean, and also higher moments to be determined more efficiently by samples selected in this manner. It provides great observational economy, especially when the quantification of sample units is quite expensive, but suitable for cases when measurements of units are costly and time consuming also. It is applicable either when the latent values of the units are easy to rank by visual inspection, or when there exists concomitant variable which can easily be ranked. And also samples hold the information regarding both measurements on the variables of interest and ranks of the variables. RSS contains more information than the simple random sampling, and these estimators are unbiased, and they have lower mean square error when compared to simple random sampling estimators. So the number of false alarms is cut into half or even more when we adopt these ranked set sampling technique instead of simple random sampling in control charts. So these are the so many authors they have worked in these years, and they have slight modifications also they have considered for ranked set sampling. So why they have considered the modifications? Because when we are making ranking, there are two types of ranks exist: perfect ranking and imperfect ranking. So when imperfect ranking is there, so we cannot, that ranked set sampling that need little bit of modifications. Such modifications are extreme ranked set sampling, L ranked set sampling, median double ranked set sampling, moving extreme ranked set sampling, median ranked set sampling, ordered ranked set sampling. These are the various techniques. So they have all proved that this ranked set sampling is better than simple random sampling, and also they have identified that the modifications of this ranked set sampling is giving more better results than the ranked set sampling also, and these are the observations from those authors. So one latest article in 2019, they have got the result like this. This is the chart that just I want to display because of the short of time. So if you observe this graph, as the sample size is increasing, and they have it is a geometric means of ratios of average run lengths for simple random sampling control charts relative to ones obtained by each of the ranked set sampling. They have considered the sampling technique instead of simple random sampling, ranked set sampling, and their modifications. So if we observe, so if we observe this graph, the average run length for simple random sampling control charts is on the average 2.3 times larger than the corresponding new ranked set sampling. And also when the sample size is 4, it is 3 times larger. And when sample size is 5, it is more than 3.5 times larger than the simple random sampling. And also, this is in the case of perfect ranking. So they have also discussed in the case of imperfect ranking also. So if we see this graph, and this graph is about the correlations between the variables and their simple random sampling average run length with respect to the average run length. And as the correlation increasing, the new ranked set sampling is giving the better results. So with this, there is an importance of sampling techniques that we are using for the control charts plays a very crucial role. So what is further scope? What we can do in this area? We can apply these techniques for non-normal and skewed distributions also, and we can observe. And for practical data, other than these sampling techniques, any other techniques that are available apart from ranked set sampling? Are there any existing techniques, existing sampling techniques available? And we can search is though this talk is precise to variable control charts only, even this sampling plays a crucial role in statistics. So we can apply these techniques in the case of acceptance sampling plans and reliability test plans also. So this is my talk, and I would like to thank the C.R. Rao Garu for inspiring so many people in his 100 years of life, and still he is inspiring many more also. R.R.L. Kamtam Garu for who is behind me. He is like my father, and I want to thank him. And also the organizing committee for giving me this wonderful opportunity. Garu.
Okay, thank you for your wonderful speech.
Thank you.
Any questions?
I have some small observation. This is a wonderful presentation. Old is gold. Still, SQC has got a lot of application areas which is beyond manufacturing systems. I just wanted to share that I have done this in inventory control in hospital situations and queuing also using SPC technique. Finally, normal distribution and the bell curve are the basis for every statistical things, and we cannot ignore these classical theory and statistical methods are still very valid. I just wanted to check what happens if we take a moving average in fixing the middle line rather than taking the same average throughout. I just wanted a little clarification from the presenter. If you take a moving average, when the data comes here, the old data is eliminated and the new data is taken and the average is updated and the standard deviation is also updated. Will it improve the control systems?
It depends on the data also, sir.
I have done this in the hospital inventory systems and found it very effective. This is my sharing this one. I don't know whether this can be validated elsewhere also. In fact, RSS and SRS are to be combined depending on the situation. Then it will be much more effective. Thank you. It was a nice, practical, very helpful, enlightening presentation. Congratulations.
Thank you, sir. Thank you.
Sir, can I have? Can I ask one question, sir?
Oh, sure.
Sir. Thank you very much, Chaitanya Priya. Very nice presentation.
Thank you, sir. Thank you so much. You are also inspiration behind our research work, as you are our senior.
I'm also one branch of the Professor R.R.L. Kantam, and the first student of him.
Yeah.
And what about, did you see this Al Omar's research work? He has done a lot of work on the RSS control charts and also in sampling plans.
Okay.
Did you observe that?
No, sir.
Yeah. And also my response to the Lakshman Rao sir. So moving, there are number of moving average control charts and exponentiated weighted moving average control charts. They are answering this type of information. We can include the latest information. We can delete the old data. So therefore, instead of taking the control charts for the mean and the dispersion, we can take control charts for the moving averages and exponentiated weighted moving averages. They will give the good results than to the ordinary control charts, either in the simple random sampling or the ranked set sampling plans. I think I hope I answered. Sir.
Yes. Yes.
Okay. Thank you for the presentation and clarifications also. Chaitanya, I think we have met at UGC when you come for some presentation. Am I right? During in
2009 maybe, sir.
in 1995. 2005 as well, 15 also. Okay, so very nice presentation that as your teacher is inspiration for many people, and your Guru Parampara VL Narasimhan Garu is the founder of the Nagarjuna University, and he made Mayor World.
Yes.
And he is a true professor. Professor, there is a meaning for professorship. Those who are practicing, they are preaching through practice. Professor's meaning is that they are preaching through practice, not through mouth. Okay, that are the standing examples for Professor VL Narasimhan Garu, founder of the Nagarjuna University Statistics Department. And many disciples are there. Nagarjuna, our Kantam Garu is one of his disciples. Now you are extending that disciples chain. Okay, so wish you all the best.
Thank you, sir.
Good luck. Thank you.
Thank you, sir. Thank you so much for giving me the opportunity. I thank Pondicherry University and also Mrs. Avian College of Vizag also.
Lot of clouds have been cleared. There is sunshine now. In statistics.
Yeah.
Today in Chennai we are enjoying sunshine.
Now we are on the brighter side of the sun.
Yeah, right. Thank you, sir.
Good, good. Thank you. Now
I thank all innovator speakers for their excellent talk to all the presenters. On behalf of the organizing committee, I thank each and every innovator speakers. Thank you very much.
Yeah. Now as a general thing, I would like to just make it a point that okay. Now thank you and congratulations to sharing session. You have completed within the scheduled time, and all speakers also have made very lamentable contents today. And when the session starts with Rajeswari Sarkari, Professor of Mathematics of our university, and she has area of orthogonal arrays of Professor Priya Rao. And in fact, it is a very primary work. It's a Dr. Chaitanya and Dr. Dharmaraja is requested to mute off your mics. Okay. So, Dr. Rajeswari Sasajri has given a very good scope of the subject of orthogonal arrays. And in fact, C.R. Rao can be considered as a pioneering works of that this one. Now there is no field without the applications of orthogonal arrays. It's not an exaggeration. And now I would like to take this opportunity to request our Professor Rajeshwari Seshadri. Let us have some school of thought propagation of C.R. Rao's contributions. There are around 36 contributions are there of C.R. Rao, out of which orthogonal arrays is the most prominent. And another one, our Dattatreya Rao sir and Girija madam, both they have touched upon the directional data analysis. Directional data analysis is another area where now the predictions on different environmental factors like the movement of the cyclone, the movement of the earthquakes even, they are predicting through the directional data analysis. Now science and technology has making use of the statistical concepts in such a way that they are for prediction and forecasting different types of things using not only longitudinal data but also directional data analysis. So directional data analysis has another area, very scope area there the research can be done, for which Dr. S.V.S. Girija from Hindu College, Guntur, and Professor Dattatreya Rao sir is a another wonderful professor, and he can be considered as a giant in the statistics, and he has a passion of making the statistical computing or computational statistics as an area where he can be considered as a giant in a data mining and data related issues. So it is so privileged that we are having the giant in statistics, Dr. Dattatreya Rao garu spared his valuable time and sharing his valuable contents today in the area of directional data analysis. Another prominent speaker, Dr. N. Viswanathan, and he is from Presidency College. He spoke on estimation of lower order quantiles of survival distributions using a fuzzy approach. Fuzzy approach is another prominent and what we call it as vibrant area of mathematics now. Fuzzy mathematical approach for applying the statistical applications, in the sense statistical domains. So his talk has mostly concentrated on how best we can make the approaches of fuzzy related concepts in estimating the lower order quantiles of survival data analysis. There is another concept called order statistics, where we are, when handling the ordinal data, particularly categorical data, there are two types, nominal and ordinal. And among the ordinal data, when we are handling, then that is mostly a categorical approach. You cannot have the continuous scale approach in that areas. So therefore, Dr. N. Viswanathan has touched upon the area of the fuzzy approach for making estimations of survival data related, particularly calculating lower order quantiles. It's a very interesting talk by Viswanathan. And another speaker, Kavya Rasu, has given the topic on the zero-inflated Poisson distribution, and Dr. Kambampati has given fixed point theory. It is another area where a classical mathematics it is being done. I think Professor, if I'm correct, Professor Kambampati, Professor Sastri, KPR Sastri is working under on this area. Am I right? Mathematics Professor Ramakrishna, is it true?
It's true, it's true.
KPR Sastri of Mathematics Department of Andhra University is working on this area, and he has very good commendable productions on this area and fixed point theory. Now, of course, Dharmaraj from a BHU, Banaras Hindu University, once again, it has made his vibrant presentation on the area of environmetrics. Good. Environmetrics is the discipline in which the predictions of different environmental variables, eco-related variables, which can be handled by again, every activity is a statistician's concern. So he has presented the environmetrics related the different aspects of eco-related issues. So his presentation is a very nice presentation, and all this. Another one is a recent talk is Chaitanya Priya from Saudi Arabia. Of course, today is working day. Out of it, she has made her efforts out of interest to share her ideas and knowledge to this forum. She has contributed on again quality control related topics. So as Lakshman Rao has pointed out correctly, statistical quality control is another area where it is contributing the quality management related issues. And therefore, we all the 8 speakers today spoke on the very qualitative deliberations, and I hope these topics will create at least an epsilon influence on a researcher, then it will be proliferated and it will be grown. Now, it is time to thank to all the speakers for their valuable time sparing in spite of their engagements. And I thank on behalf of the organizers for their effective presentation and make this event very lively. And one more thing I would like to communicate to you people that all the talks, I am communicating this to all the delegates. All the talks we are making recording, and we will separate it. If anybody want the presentations of any individual resource person, you may feel free to write me, so that I don't want to dump all the material to all the people. I want to be specific. Those who are required, they will get it. Those who are not required, I don't want to send this material. Okay, I don't want to waste the data space. I don't want to waste the very spirit of the research work. So research is supposed to be pursued with an interest. I cannot rub any interest on you people. So if you are interested in any specific topic, and that topic video will be shared to you on demand basis only. Don't expect that all the presentations will come as a dumping part. I don't want. So I am just informing you people, if you are having any attraction towards any topic, any talk, let me know, so that for that people only I will share this knowledge component. This knowledge component is a very valuable. I don't want to make it as a unworthy people are sharing to non-necessary people. Okay, so this is what I want to announce today. And with this, now it is 1:45. Of course, it's 1:30 to 2 is a lunch period. Now we have a break up to 2 o'clock. From 2 to 5, we will have technical sessions. You are all requested to leave the meeting now. If anybody wish to be, that is up to you. There is no need of logging out. And the next session, technical sessions, will be 2 parallel technical sessions. Technical session 7 will be the same one, and technical session 8 will be another link. You have to join for that link. Thank you, one and all. Thank you very much. Okay, welcome. Welcome to that. Hello. Anybody there?
Yes, sir.
Hello.
Rekha, sir. Rekha, sir.
Yes, sir. Yes, sir.
I think this is the prime link for which Dr. Rajeshwari Seshadri has to chair. Am I right? Ganapati?
Sir?
Hisham is there?
Yes, sir.
Ganapati?
So he is now only eating, sir. So he'll come, sir. He will come, sir. Still, madam is not joined, sir. Rajeshwari madam is not joined, and Vaidyanathan sir is also.
I think this board is Vaidyanathan and Rajeshwari madam, no?
What, sir?
Unmute your mic, sir.
Huh?
What, sir?
This board, this link, who are the people related?
Who are, sir, you are joining both links, sir. Within your line.
I am both, but I will shift to there.
Okay.
No problem.
With the same camera, how can I join, sir?
No. I will disconnect from here.
Okay.
I will disconnect from here and I will go to that board. No problem.
Okay.
I think you just Hisham.
Sir,
Hisham. Which
Sir,
board you are?
Isam is taking your session, sir. Session 8. Taking your session 8. I am
Session 1, 7, 8.
8. Sir, you are a chairperson for taking the session 8, sir. Now you are joining.
I'm going. I think Rajeshwari madam just came.
Madam came.
Just I will request her and both are there. I will request both of them and I will go to that board.
Okay.
Welcome Vaidyanathan and Rajeshwari.
Yes, sir. Good
Thank you, sir. Good afternoon.
Good afternoon, Rajeshwari madam.
Good afternoon, sir.
Sir Vaidyanathan sir,
Yes,
I have to go to the next session.
Yes.
I have to be there. You please take care of this.
Okay.
Madam, welcome, madam.
Okay, sir.
Please.
Okay, sure.
I am
Thank
just disconnecting here. Right.
Okay.
So, welcome to all the participants for this technical paper presentation. So, we have with us the chair, Professor Rajeshwari Seshadri. I will just introduce madam. And, just give me a second. I am sharing the PPT. So I think this my screen is visible to everybody.
Yes, sir.
Yes, sir.
Yes. So it's a privilege to introduce the chair of this session, Dr. Rajeshwari Seshadri. She is currently the professor and head Department of Mathematics, Ramanujam School of Mathematical Sciences, Pondicherry University. So, very brief bio. Anyhow, I can, without looking at it, also I can tell because she happens to be our sister department, and we know her as a faculty member of the mathematics department for more than a decade. So, her area of specialization basically is differential equation and computational fluid dynamics. And she has contributed much actually in PDEs and this computational fluid dynamics. And she has got appreciations from IIT Bombay for conducting these spoken tutorial projects. That's a project that we basically cutters about the computer in the sense that MS Word, MS Excel, so popularizing these computer software among people who do not know.
Training courses.
Courses, yeah. Right. So that is a spoken tutorial project, and she is a recipient of the Best Teacher Award and from Pondicherry University, and she has got summer research fellowships, and you can see here from IIS Bangalore and INSA New Delhi and National Academy of Sciences Allahabad. And she has got appreciation letter from the chairman, Indian Academy of Science, awarded one of the best poster presentation from International Conference on Frontiers in Fluid Mechanics, and awarded consultancy from Jawaharlal Nehru Center for Advanced Scientific Research, Bangalore, and she has got a Young Scientist Fellowship. And she has got a Research Associate and Senior Research Fellowship. She has totally published more than 30 papers and UGC approved journals, so all these things. And she has got 4 PhD awarded, and one more candidate is going to submit the synopsis very soon, for which I am also a member of the DC. And yeah, she is basically a product of IISc Bangalore, if I am correct, madam.
Yes.
PhD from that. Yeah, and she for a brief period of time, maybe for 5 years or 6 years, I don't know, visited foreign countries. She has been there, and she joined Pondicherry University in 2010. And it's almost a decade that Madam is in the Department of Mathematics. And one positive thing about Madam is that whenever an opportunity comes for a conference, she immediately accepts. Basically, we invite people from Max also, and she is one of the first person to respond and say that yes, this has to be some sort of an school level, and interdisciplinary between mathematics and statistics should flourish. So that is our attitude. So with these brief words, I welcome you for chairing this session, madam.
Thank you, Dr. Vaidyanathan, for your kind words. Thank you very much.
Yeah.
So shall we begin the session now?
Yeah. We can begin, and I hope so all the participants are ready actually for this. So maybe do you have the list with you, madam?
Yeah, I have just opened it in my mobile.
Yeah, maybe I can share that.
So there are 11 speakers in this session.
Correct. So
each have 10 minutes presentation, I guess.
Yeah. Correct.
So I request all the paper presenters to be very alert, and the moment one person finishes, keep ready with your PPT. We will just be calling out your name, and we'll be telling what is the topic you are going to speak on. Parallelly, you get ready. So we should reduce that in between talk time. We should minimize as much as possible.
Correct. Madam, can I just check whether all the speakers are available? Maybe one or two.
Sure.
So
you want me to you have the names, or you want me to read the names?
No, I will read.
Okay, sure.
My laptop, so I can read. So is there Rama Mohan Reddy is there? Rama Mohan Reddy?
Please unmute your mic and say yes. The speakers.
Yeah. Rama Mohan Reddy? Okay.
Not present, sir.
You are present?
Not present. I am Ganam.
Not present. Okay, fine. BG Manjunath is there? Manjunath?
Manjunath is also not there.
Okay. Seema Singh?
No, not there. Next.
Amlan?
Yes, sir.
Is there? Yes.
Amlan is there?
Yes, sir.
And so if the first speakers are not there, and possibly I think Amlan should start. Anyhow, we can check with others. D. Ram?
Yes, sir. I am here.
You are there. Okay, fine.
Thank you.
Then Yasyan Murthy Kodukula?
Yes, I'm here.
You there?
Yes, sir. Yes, I'm there.
Okay, fine. V. Anusha?
Yes, sir. Present, sir. I'm
Yes,
there, sir.
fine. Madam. T. Revati? Revati is there?
Yes, sir. Revati is there. Revati,
Seema Singh joined just now.
Oh, okay, fine. Anyhow, we are just checking. Vinay Kumar? Vinay Kumar?
Others, please unmute your mic yourself.
Yes. Muruganandam? Okay. Sarode Rekha?
Yes, sir. I'm present, sir.
Yes.
Sir, Revati is present, sir.
Revati is present. That's fine. Madam.
Thank you, sir.
Yeah, fine. So madam, the first I'm not able to get the response. Rama Mohan Reddy?
Seema Singh joined just while you were introducing. Seema Singh joined.
Okay. So
And first and second have not yet joined. Manjunath and
basically, in that case, we can start with Seema Singh. Seema Singh,
Yes,
are you
yes.
ready? Are you ready with your presentation? Can you present it now? Your talk? Seema Singh?
Sahar joined.
Seema Singh is there?
No,
Not
she
sir.
left.
No, sir. She's not present, sir.
Yeah.
Okay.
So I think, madam, we can start with Amlan in that case.
Okay, fine. Yes.
Yeah.
So,
So,
one request to all the presenters is introduce your name and affiliation. Say if you are a research scholar or a faculty in any institution, and then proceed with your talk. Okay?
yes.
And please
Other
stick to your
participants?
time of 10 minutes for each presentation. Stick
Other-
to your time, and otherwise we will stop you abruptly.
Other participant, please mute your mic yourself and don't present in between the session. It will affect our current session. Okay. Please.
Yes,
Very good, very good. That's an important announcement to be made. Yeah. Thank you.
Thank you.
Thank you. Thank you.
So now, for this paper presentation session, technical session 7, I invite Amlan to present his work.
Thank you, ma'am. Am I audible? Hello?
Yes,
Yes,
you are
yes,
audible. Yes.
My presentation is visible, madam?
Yes, it's visible. Yes.
Okay, thank you. So, a warm good afternoon to all. I am Amlan Kanti Haldar. I am a PhD scholar in the Department of Mathematics, Pondicherry University. So, the title of my talk is Integrability of Heston Financial Model through Point Symmetries. And this work is done under the supervision of Professor Rajeshwari Sheshadri and Professor PGL Leach from the Durban University of Technology, South Africa. So in this talk, I'll be discussing the Heston financial model. It is actually a partial differential equation. I'll be discussing the integrability methods of this equation using two different methods called as the symmetry analysis and the singularity analysis. So before I present my model, I'd like to give a bit of history of that model. So the Heston financial model, it's a PDE and it is of 1 plus 2 dimension. So 1 plus 2 dimension, it means that the 1 refers to the variable time and the 2 refers to the 2 other independent variables which are denoted by X and Y, where X denotes the the price of the stock and Y denotes the volatility. So in the recent past, Professor PJ Leach and his team in the year 2011, they had actually did the symmetry analysis of the Heston financial model, where all the parameters, for example, the rate of return for any investment made and the rate of the volatility and some other arbitrary constant terms and parameters were considered to be constant. So for that very specific and confined model, they were able to obtain some result, and the solutions were given in terms of a linear combination of trigonometric hyperbolic function and a general function which in general is linear in nature, and it satisfies a first order differential equation. So but for the time dependent parameters, so they actually worked on a 1 plus 1 model. For the time dependent parameters, they could not proceed further. The symmetries which were obtained were incomprehensible, and they suggested in the paper that instead of a point symmetry, so they basically used the point symmetries to compute the solution. They suggested that the non-local symmetries, which is also another kind of symmetries, can be used, or a generalized symmetry which can be used to obtain the solutions. So the work on this in Heston financial model, it was again a follow-up work of another financial model which is called the Steinstein model, and this work was also done by Professor PJ Leach and his team, in which they found that the Steinstein financial model, it gives again a linear combination of certain certain special functions. Then later on in 2014, Andronikos Paliathanasis, he revisited again the Heston financial model, but this all the parameters, specifically the rate of return of any investment was considered to be constant, and they obtained a solution which had an exponential term plus a function which is a function which satisfies a second order ordinary differential equation which is linear in nature. So this is the model which I have. So this is actually the same model which was worked out by Andronikos et al. In 2014. But a slight difference here is that the rate of return, which is denoted by R, here we have considered it as a function of time. The other parameters, which is beta, it is actually, it comes at the two independent variables, which is the stock price denoted by X and the volatility, which is denoted by Y. They satisfy a stochastic differential equation. So the beta term actually comes through that. And then there is C1, C2 also, it comes from those stochastic differential equations. And now this equation 1, as you can see, it's a linear differential equation and it is of second order. And rho is my correlation factor between the two variables, which is X and Y. So I have to introduce, I have to compute the solution for this equation 1 using symmetry analysis. So before that, I just give a small brief introduction to symmetry. What do you, when I say symmetry, I mean a certain kind of transformation which can keep the differential equation completely invariant. So by invariant, I mean that it looks completely, so those transformation which can keep the properties, which can preserve the properties of the equation, which can preserve the properties of any differential equation. So such class of transformation, those are called infinitesimal transformations, and they can be generated using an operator which usually represented by a gamma. So that I'll show it in my slides. And there are many different kinds of operator. Here I'm using the most simplest type of operator, which is called the point symmetries, as I said before. And so this is just symmetry, how and all, where and all it is observed and everything. So symmetry method, it is actually one of the most efficient method when it comes to, you know, when it comes to see how visually how the, you know, the solution procedure can be obtained. So this method, it was initially introduced by a German, by a Norwegian mathematician by the name of Sophusli in the year 1870, and he started working on certain transformation which can keep the geometry invariant. Later on, he termed these things as symmetry, as quite obvious. And later on, some more works were introduced where people started focusing. So he, Sophusli's work was mainly based on point symmetries. Later on, many other people started working on non-local symmetries and other various forms of symmetries. So this is just an available program which is which are currently not in market, but it is reliable code. For example, Professor Alan Head, he had used the symbolic manipulation code using DOS, and Maria Clara Nucci, she uses a software package called Reduce to do the computations. And then there is a new package which is currently in use. It is called SIM, and it is developed by Stelios Dimas and Dimitri Tosoblis. So I'll just go to my equation. So I'll just go to the calculation which I have done. So the symmetry of the my model 1, which I showed before, the general symmetry, it is represented in the form of gamma. As I said, it is a point symmetry. So here it means that all the functions, they are dependent only, all the function, it is the functions such as C1, Psi1, Psi2, Psi3 and eta, they are functions of the variables, independent variables only. So this is the point transformation. So if they are dependent on, if they are a function of dependent variable also, or their higher or their derivatives, then we go for, then it is called a non-local symmetry or a generalized symmetry. So with respect to the time t, I have a component which I denote by, which is denoted as k1 to t. So here it means that my c1 is actually k1, then my c2, it is component with respect to x. So here, as you can see, the b1, it is a function, c1 is again some complicated function, and then comes my component with respect to y, and then there is my component with respect to u, which is denoted by eta. So as you can see that the computational, it becomes a bit difficult when the time factor is considered, comes into picture, but this is not the case when the arbitrary, not the case when the constant case is being considered. So of all these symmetries, I use the, yeah, so the functions which were represented in the general symmetry C1, B1, D1 and D2, they actually satisfy certain differential equations, ordinary and partial, and sometimes a mixture of both. So as I have represented two of those equations here, so these two equations need to be solved so as to get a clear picture of the point symmetry. So these two can be again can be again done using the Lagrange's method. So for simplicity, I use the time translation symmetry, which I represented the time component. So using the time component, which I have captioned as the first reduction, when I use the time component, I can rewrite my equation 1 in terms of equation 2, where my function u is nothing, it is given in terms of z. Now this equation 2, it has a symmetry of the form as represented gamma. So again I do the symmetry analysis, and here the functions are a1, b1, c2 and c3. So again these four functions, they satisfy certain partial differential equations, which is denoted by equation 3 and 4, and there are still 4 more equations, but I have not listed them. So I take two such equations which are very compatible, and I obtain a values of a1 and b1. So again this is a special case where I have to again work out with certain PDEs and get a specific value. When I substitute these two, a1, when I take the value of a1 as minus log x and b1 as log y over 1 plus 1 by the correlation factor, then my computation for the other two function, which is denoted by c2 and c3, it becomes bit easier. So my c2 now, it gets the form of equation number 5. Now this equation number 5, it is bit easy to solve. The solution, it is given in terms of exponential integral function. So now from this I can get a solution for my equation model number 2. So here z is equal to integral over c2 over log of x. So from this I can get a solution of my equation number 1. So so this is with respect to c2. Now there is a one more function which is represented by c3. So if you again, if we try to if I use certain PDEs, and when I can certain PDEs, I get some solution also in terms of c3. So in this way I can get solutions in different subspaces of the plane for the same equation. But as I said, this is only for the only one case, for the time case. So similarly, some with respect to the time component, the same analysis can also be done with respect to the stock price, with respect to volatility, and with respect to the other one, u. And also linear combination of all the components is also possible. So then after that, the another method is singularity analysis. Actually this one I should have done earlier, because this method, it has one advantage. It will tell us that whether a method, whether a model, whether it's a PDE or a ODE is integrable or not. So we use this method, singularity analysis method. I'll just give a brief overview. What we do in this method is to try to observe a pole, whether the equation has any pole. Then if it does, then we try to give a solution, Lorentz series solution along, around the pole, around that singularity. So here what I do is I just want to check whether the model which I have considered, it is integrable or not. So here for that I make a substitution. Vu goes to u0 phi to the power p, and where p denotes is the leading order exponent, and when if it is negative, then it means that there is a singularity, and that singularity is nothing but my pole. And then I make a substitution in that my equation number 1. As you can see, the substitution leads to this. It's a big equation. Then I have to analyze it and get the value of p. So for this I get value of p as -1. Then I obtain the value of leading order coefficient, which is denoted by u0, and then again I have to go back and obtain the value of the again I have to do the substitution which is shown, where u goes to u0 phi to the power -1 plus m times phi to the power minus 1 plus s, where capital S denotes the resonances. So now my objective is to get the resonances. Once I get the resonances, I can say, so once if I get some feasible value for the resonances, I can say that there is a possibility that there will be a series solution around that pole, and the system and the model satisfies the Paine-Levé property, which states that the pole should be the only singularity. So this is a weak method when it comes to check the integrability of any equation. So in this work, I have presented on only the basic, only a partial calculation which I did with respect to the time component. With respect to the other components, it is still under study. So that thing, and also there is, as I said, the singularity analysis method, the solution, it can be represented in terms of series. But then we thought that the series solution, if we provide a series solution for the PDE, then it may not be of any specific interest. So we are focusing on the method using symmetry analysis method to get a compact closed form solution. So the singularity analysis method is being used here only to check the integrability of the equation, and later on the study can be extended when all the parameters such as beta, C1, C2 and R, which is the rate of return, it is dependent on time and both stock price and volatility. In that case, the model will be more finer and calculation will be more precise. But as I said, the computation will be difficult. Okay, thank you. These are my references.
Yeah. Thank you. You can unshare the screen, Amlan.
Yes.
Yes. So the next speaker is B. Ram is ready.
Sir, Vaitranam, sir.
Yes.
Sir, please inform the participant. Please switch on the unmute your camera, sir.
While the presenting, no? Yeah.
Yes, sir, while presenting.
All the participants, when you make your presentation. Yeah, when you make your unmute your audio as well as your camera also, because we should know who is presenting and it is being recorded. Okay, so that's a gentle request. Please unmute your audio as well as video and camera. So next person is B. Ram is ready. Do we have B. Ram? No. Do we have Rama Mohan Reddy? Rama Mohan Reddy is there?
No, sir.
No?
No, sir.
Seema Singh? No? B. Ram? B. Ram?
So I think we should not give opportunity after 2:30 if they join.
Yeah. So I am
they
just
cannot come and join at their own will, right?
I am just calling names in that case. Down Amlan. Okay. So the next person after Amlan as such is B. Ram. I am not able to hear any response from him. So is Murthy Kodukula is there?
Yes, sir, I'm there.
Murthy Kodukula?
Yes, sir, I'm here.
Yeah. Can you present now? The next speaker will be Anusha. You can be ready.
Yes, sir.
Yes.
Murthy, please come closer to your mic and speak.
Yeah. Murthy Kodukula is going to present.
Is my screen visible, sir?
Yeah, proceed.
Yeah, good afternoon, respected
Yes.
Madam and sir.
Yes.
Myself, I am
One second, please. Can you just unmute your camera?
Yes, sir.
Yeah, we want to know. Yes, please.
Yeah, good afternoon, sir. Madam Secretary and sir. My name is Murthy Kodukula.
Please switch off your fan, Murthy, or something. Some noise is coming from your end.
My son is already switched off, sir. Yeah, my name is Murthy Kodukula, working as Assistant Professor, School Management Studies Maharaj Physical College, Vijayanagaram. And the father of this chapter is my research guide, Sirika Dharmakuni.
Excuse me, sir. Your audio is not clear. We are not able to hear you properly. Yeah, some sort of noise is disturbance is coming.
So now is it okay, sir?
No.
Hello? So now is it okay?
No, it is still not clear.
You just leave the mic. You just leave the mic and speak. Yeah, you can just speak. Yeah.
Hello?
Yes. Please continue, sir.
Am I audible, sir?
Yeah, your voice is feeble actually. You can just come a bit closer to the laptop. Possible?
Otherwise, you are using a laptop or a desktop?
Desktop, sir.
Desktop. You don't have any separate mic?
It's a separate mic, sir, actually.
Okay, fine. Please proceed,
Yeah,
sir.
you just continue.
Please proceed.
I did my MSc in same department, sir, Department of Mathematics, Pondicherry University, in 2005-7. My topic is new ranking method for interval value intersection regular fuzzy numbers, ID and T. So the ranking of fuzzy numbers was presented by Mathematics and it is extended to institutional subjects because of its attraction and applicability. So in this chapter, we will discuss a new ranking method for finding interval value intersection regular fuzzy numbers by using the concept of center of gravity, by using the geometrical viewpoint. The fuzzy set introduced by Zeta, which are characterized by a numeric function or describe the successful applications in various fields. In fuzzy set, the numbership of an element is defined to be the number from the interval close 0, 1, and the non-numbership is simply its complement. But in reality, the hypothesis does not match with human intuition. Octonian introduced the concept of impressionistic fuzzy sets, which are generalization of fuzzy sets. The IFS has received considerable attention since its inception. Bohr and Burhat proposed the notion of load sets, which is identified with that of impressionistic fuzzy sets. As counterbalanced by Burhat, Burton and Brillo, Octonian and Burhat further generalized the concept of IFS and introduced the concept of interval valued fuzzy sets, IVFS, which combines the concept of IFS with IVIFS. IFS and IVIFS have been applied to many different fields such as optimization, decision making, supply selection, investment options, and
Mr. Murthy, Dr. Murthy, I suggest since you have 10 minutes, you just focus on your aim, objective, and the results. Introduction, don't waste so much time.
Okay. So in this paper, in section 2, some basic definitions and arithmetic operations of interval values, intersection regular fuzzy numbers are reviewed. In section 3, a new ranking method is provided by using the center of gravity method. And in section 4, some numerical examples are discussed by existing methods. So here we will discuss some preliminaries, some basic concepts. So IFS, intersection fuzzy sets, and IFS, our limit of discrete x is of the form A equals to set of all x, mu A of x, B A of x, where mu A represents the numeric function and B A of x represents the non-numeric function. If the condition the sum of numbership and non-numbership value is applied to 0 and 1, if the 0 less than or equal to mu A plus B A less than or equal to 1. And second definition, interval value intersection fuzzy set. An interval value intersection fuzzy set A or x is of the form A equals to x plus mu A L of x, mu A U of x, L refers to lower values and U upper values. This interval is the lower and upper values of numbership function. Some lower and upper values of non-numeric function, VAL of x, comma, V value of x. Where all the lower values and upper values are functions from x to closure to 0, 1. Lower values always less than or equal to upper values. Mu L less than or equal to mu U and VL less than or equal to VU. Interval value equationistic procedure services. So that here the interval value equationistic services its number two function is defined as mu value of x, that is number two function upper value, that is x minus a by b minus a into mu u of a for x lies between a and b, which is equal to mu a where x lies between b and c, equal to b minus x by b minus c into mu u of a for c less than x less than or equal to b and equal to 0 otherwise. And here the number six lower values are defined. And then this non-numeric function is defined as b value of x equal to b minus x plus b of x minus a, x lies between a and b, equal to b value for x lies between b and c, that is equal to x minus c plus non-numeric upper value into b minus x for c less than x less than or equal to b and 0 otherwise. And similarly, if non-numeric value is defined as VAL of x, where 0 less than or equal to numbership lower less than or equal to numbership upper less than or equal to 1, and similarly non-numbership lower upper, and then sum of numbership upper plus non-numbership upper value mu u plus vu lies between 0 and 1, and sum of numbership lower plus non-numbership lower values lies between 0 and 1. Then this is the representation of interval value equationistic procedure for the number. A is equal to A, B, C, D. Closed interval mu L, comma mu value, numbership lower value and upper value, and then non-numbership lower value upper value. It is called interval value equationistic procedure for the number. A, B, C, D represents procedure values and this numbership function and non-numbership function. So, from arithmetic operations in interval value equationistic procedure for the numbers, from addition, subtraction, multiplication, and division are defined here. A1 and A2 are two interval value equationistic procedure for the numbers, from addition of A1 and A2. It will be as addition of respective values A1 plus A2, B1 plus B2, C1 plus B2, and B1 plus B2. Minimum of numbership values and maximum of lower upper and maximum of numbership lower upper values. Similarly, subtraction, multiplication, and division. These four are some basic arithmetic operations with interval value equationistic procedure for the numbers. And proposed branching method.
So kindly move to your conclusion page, sir. It's already time.
This is proposed method now. Actually, the region is divided into three regions: S1, S2, S3. S1 is the triangle, S2 is the rectangle, and S3 is also a triangle. By using area and centroid of each part, we will calculate the center of gravity as x square plus b square minus a square minus b square plus 2b minus 3b by 3 into a plus b minus c minus b. And the y coordinate is a plus 2b minus 2c minus b into 2 minus mu u minus vu minus mu l minus vu by 3 into a plus b minus c minus b. The ranking is defined as the Euclidean distance of x and y, that is square root of x square plus 4x square. And the ranking is if R of A1 is greater than R of A2, then A1 is greater than A2. If R of A1 is less than R of A2, then A1 less than A2. If R of A1 is equal to R of A2, then A1 is greater. Some number of examples are discussed. Here A1 and A2 are two IDIT as an interval value equationistic procedure for the number. By using JY John and S2 line, A1 is greater than A2 by using this method. In the proposed method also we got some X and Y values for both A1 and A2, and ranking of A1 is greater than ranking of A2, hence we got A1 is greater than A2. In another example, by using U and U, A1 is equal to A2, and another B3 plus another reference of B2 greater than A1. By using the proposed method, we got the value A1 is greater than A2. So that's the concept for this chapter. Thank you.
So what is new in your proposed method? What is new in your proposed method?
Membership function. New.
So you have taken a different membership function.
Yes, ma'am.
So what was the advantage for taking a different one?
New is a membership function and V is a non-membership function. In an infinite value education procedure of the number, there are three functions, namely membership, non-membership, and efficiency. New reflects membership value. For finding the uncertainty of interval value education procedure for the number.
Okay, thank you. Next speaker.
Yeah, the next speaker is V. Anusha. You there, ready?
Yes, sir. I'm ready, sir.
Yes. The next speaker is T. Revati. Please be ready.
Yes, sir.
Okay, so is my presentation visible to everyone?
No. Yeah, now it is coming. Yeah, yes.
My voice is clear? My voice clear?
Yes. Yes.
Okay, thank you. Good afternoon, each and everyone, ma'am, sir, and all the participants. My name is Anusha. I am PhD scholar in the Department of Mathematics, Geetham, Vishakhapatnam. Today I am presenting the paper Fuzzy Stock Weights Valuation based on Ambiguity Index under T2IFS Type 2 Intuitionistic Fuzzy Sets under the guidance of Dr. Sirisha Dharan, Associate Professor in the Department of Mathematics, Geetham, Vishakhapatnam. So let us go to the introduction first. So stock market is one of the most attractive places for investment who affords high risk for expected high profit. Basically, a stock portfolio is a portfolio for investment which is a combination of stocks. So here concerned with selecting a portfolio containing large number of stocks to reach the investment goal. So the purpose of the stock portfolio selection is allocating the capital of the investor to a large number of stocks in order to bring a most profitable returns by the investment manager. So the prediction of future returns is one of the most important factors in theoretical and practical investment studies. They have been treated as only random variables in many previous studies. Since the stock market is so complex and the occurrence of new stock is so quick, in many cases, the returns cannot be accurately predicted by only historical data, so have impact on the prediction. Since there is other factors impact, they are best with ambiguity and vagueness. So since there is vagueness, here the introduction of fuzzy set theory takes place. Since the fuzzy set theory is also known as uncertain theory, it covers the uncertain nature of the subject being discussed. It was developed by Zadeh in 1965. So assuming the returns as fuzzy numbers, a lot of research has been done on stocks and portfolio selection also. So literature findings, here are my findings about the literature that I studied. So who has a certain amount of money to be invested in number of different stocks with uncertain returns, always the rule states that he should diversify the funds among the stocks, which gives the maximum expected return. So this diversification has the first stage and second stage. The first stage is observation and experience performances and the relevant beliefs about the future performances, and the choice of the portfolio selection happens in the second stage. Since the future performances being in the second stage, here there is an uncertain nature in the second stage. So I have taken this uncertain nature about the future performances and my research dealt with the second stage. As the surveys claimed that ambiguity has uncovered a number of significant advantages in the ability to rationalize important features of stock returns and portfolio decisions. Hence, it is reliable to use ambiguity as a risk measure for investment. So surveys claim that ambiguity uncovers a number of uses. So it has been used as measurement for the risk. So my objective here is, while investing in stock portfolio, always a good portfolio investment should be done according to the weights of the stock in that portfolio. So if there is a portfolio of different stocks, the investment should be done according to the weight. So here in this paper, I proposed an index which can calculate the weight of each stock in the portfolio, whereas the performance are taken as type 2 enthusiastic fuzzy numbers. So here the performances are taken as fuzzy numbers. The generalization fuzzy number, I have used type 2 enthusiastic fuzzy numbers. So these are the variables that are being used in this paper: fuzzy set, type 2 fuzzy set, enthusiastic fuzzy set, membership value, and non-membership value. So these are the basics of the fuzzy theory: a fuzzy set, type 2 fuzzy set, and enthusiastic fuzzy sets. Since a fuzzy set is developed by ZADE, after that another extension has been developed by ZADE only to cover the uncertain nature of the membership function, first membership function, that is type 2 fuzzy set. So there is not only a membership function, there is also a non-membership function to be considered. So Atanaso and Gargo developed enthusiastic fuzzy sets, being the addition should be lies in between 0 to 1. So this is the generalization of the another fuzzy set, which is type 2 and enthusiastic, both the combination of type 2 and enthusiastic. This is the new fuzzy set, type 2 enthusiastic fuzzy set, recently being introduced in the last decade only. So in this, the set of the elements contains first membership, second membership, first non-membership, and second non-membership. It has enthusiastic, both membership and non-membership, and type 2, so that will have first and second ones also. So here the definition comes about the ambiguity. So since we are considering here ambiguity to obtain the weight, this is the definition of the ambiguity for the T2IFS, which is type 2 enthusiastic fuzzy set. If A is any type 2 enthusiastic fuzzy set, as you can see here, the element X belongs to this T2IFS. If this element is being represented by this fuzzy number T2IFN, then the ideal set is always be represented by this fuzzy number only. Since the ideal means the perfect set always contains the membership functions as 1, belongingness as 1, and non-belongingness, non-membership as zeros. So this I is the ideal fuzzy set and A is the T2IFS. Then we can calculate the ambiguity, uncertain nature, ambiguity of A to the ideal set by using this formula: ambiguity of A equal to mod M1 minus 1, mod M2 minus 1, mod M1 minus 0, and mod M2 minus 0. Example has been given here to explain the ambiguity. So like this A be a T2IFS, then the ambiguity of the A to the ideal set is given by like this. If we substitute the values in the above formula, we can have this. So here is methodology. First, I'm going through the methodology. After that, I will give a numerical example to give you a clear view. So let S1, S2, so on Sn be set of stocks. So these are being for evaluation, for being weighing. The expert who is here in the case of stock market investment manager, so being played by the first stage, he gives a performance matrix. So the performance of the stocks has been done by the investment manager as stage 1. Since here we are considering the environment of T2IFN, each performance of the stock is taken under T2IFN only. So you can see here T2IFN numbers, these are the performance and these are the notations. So after giving the performance matrix by the investment manager, then we find the ambiguity of each stock. Since as you can see in the definition itself, ambiguity is also again a T2IFN. So if the performance is a T2IFN, we get the ambiguity again a T2IFN, a fuzzy number only. Whereas if for any comparison purpose, we have to get a crisp number. That means a real number. If there is a real number, the comparison will be done. So again, now we have to convert this T2IFN, a fuzzy number, into a crisp number. So that involves in the step 3. So in step 3, we defuzzify the ambiguity, which is a T2IFN, by using this formula. So this is the formula for defuzzification of a fuzzy number into a crisp number. So this is the T2IFN. We will substitute the values of membership, second membership, non-membership first, and non-membership second. So after defuzzification, the ambiguity comes in between the 0 to 1. So this is a real number, this is a crisp number, which comes in between 0 to 1. But now we have to calculate the weight of stock. So the weight of each stock is calculated by using, I have taken this formula, since a lot of surveys have claimed, and after being a lot of study, always the weight is inversely proportional to the ambiguity. Conclusion also, since always the weight is always the weight is inversely proportional to the ambiguity, so I have taken here weight of each stock equal to 1 by ambiguity of each stock. Since the ambiguity lies between 0 to 1, the weight we will get is always greater than or equals to 1. But in a portfolio, to allocate the investment, the sum of the weights of stocks should be equal to 1%, which means 100. Means 1. The sum of weight of each, the sum of all the stocks, weights of all the stocks should be equal to 1. So weights should also lie between 0 to 1 only. But here, the sense ambiguity lies between 0 to 1. The weight we get is greater than or equal to 1. Then what we will do is the normalizing the weights. So we will then normalize the weights by using this formula. So normalized weight of each stock, we will use this formula, so that each normalized weight comes in between 0 1, and after getting the normalized weight, those can be satisfied this equality, which is necessary for the stock investment in a portfolio. So I'm giving now a numerical example to get a clear view. So I have taken here 3 stocks for the investment. One, a performance matrix has been given by the investment manager. So this is the performance matrix that he has given. So the performances are represented in T2IFN. So after that, I have applied the ambiguity formula to the step 1. So after that, I obtained a ambiguity matrix, which is this. So again, this ambiguity, since it is in T2IFN, I have applied the defuzzification and obtained these values. Ambiguity of S1 is 0.35, ambiguity of S2 is 0.30, and ambiguity of S3 is 0.1. So these are the ambiguities. So clearly, these lies between 0 to 1 only. So after obtaining the ambiguity, we will calculate the weight by using the formula, a weight equal to 1 by ambiguity. Then we can get that weight of S1 equals to 2.86, weight of S2 equal to 3.33, and weight of S3 equal to 0. So as now you can see, these are greater than or equals to 1 and the total is not equal to 1, but we have to get the total equal to 1. Then we will use the normalization method as practically uses. So now we are normalizing the weights. So after normalizing the weights by using the formula we have, we will get normalized weight of S1 like this, S2 and S3. So now you can observe these weights lies between 0 to 1 and the total of the weights is equal to 1. So therefore the weights of the stocks are given by this. Thus we have obtained like this. So if now you can see ambiguity of S1 is 0.35, then normalized weight of S1 is 0.176. Ambiguity of S2 is this one, and normalized weight, ambiguity of S3 is 0.1, normalized weight of S3 is 0.617. Okay, ma'am, just the conclusion. Yes, ma'am. So, as you can see, ambiguity, the lowest ambiguity of the stock has the highest weight. So that is my conclusion. So in between these 3 stocks, S3 has the lowest ambiguity. So after obtaining the weights, we get S3 has the largest weight. So that is my conclusion, that by using ambiguity index, we can get the weights of the stocks. So lower ambiguity gives a larger weights. With in return, we can have less amount of loss expected in return. So these are the references I have used. Thank you.
So
yes, ma'am.
So
any questions? Any questions?
If there are no questions, then thank you, Anusha, for your presentation.
Okay, sir. Okay, sir. Thank you, sir.
Yeah,
Okay,
and
sir.
Madam Rajeshwari, Madam. So
Yes.
there are a couple of speakers who have been listed at the beginning, but they have joined now.
Come to second cycle now, Revati, get a chance.
Okay, so I will go by the order. So they have to wait actually, correct? Because somebody, they are asking through chat also. So
Because we will make and you people did not respond, so we will come in the second cycle. Now Revati will present.
Yeah. Now
so
Revati will
Madam, is the time of the presentation was 2:30, na?
You joined at 3 o'clock, 2:40, na?
Me.
No, actually,
I joined.
I don't know
At
who he
2:30
is
itself, I
talking.
joined.
Is it Manjunath?
Manjunath.
Yeah, actually at 2 o'clock or 2:05, I read all the names and I asked the responses, but some people didn't respond. One was Seema Singh, B. Ram.
I was
your
having
name.
lunch, sir. Yeah,
Sir,
I was
wait a
having
sir.
lunch. I thought that.
Yes.
Sir, wait a sir.
I
Sir,
thought
by
that.
mistake that guy Manjunath is joined in another link, sir. Now only I just find out. I just
Oh,
rejoined
fine.
in this room,
Okay.
sir.
So he has
After
joined
No
in
problem.
another
He
room.
will get his chance.
Fine.
Don't worry. He will
Yeah, yeah.
present
Oh,
definitely.
okay.
Yeah.
Yeah. Good. We don't know that. Yeah. Yes, yeah. Revati, yeah, you can present.
Yeah, good afternoon, everybody. I'm Revati from Assistant College of Engineering, Chennai. I'm a research scholar. I'm going to present my research topic and Octonian color image pre-processing for deep nets, which is a part of my research work. Shall I proceed, ma'am?
Yes. You can proceed.
Yes. Going to be abstract. The deep net is an optimized version of deep neural network, which is used in a computer vision and natural language processing. That is an NLP. Pre-processing an image is a necessary step in computer vision applications for the improvement of image that conceals an unwanted distortions, that is the image features for the next level of pre-processing. In recent years, network research is deep into the multidimensional complex algebra. In this paper, we discussed the various forms of Octonian, which is the 8-dimensional complex algebra, which is used for pre-processing. The variants of Octonian discussed in this work are simple Octonian, Octonian wavelet transform, and Octonian Fourier transform. These methods of pre-processing are well suitable for process of deep neural network architecture for effective image classification and object detection, as well as object recognition. We have taken SGA and INRA dataset to show the results of image transformation using the simple Octonian wavelet transform, and Octonian Fourier transform. And going to the deep learning, what is a deep learning? First into the deep learning, we first know about artificial intelligence, because it is a one topic is under the topic of the deep learning is under the topic of the artificial intelligence. Artificial intelligence is nothing but it can sense, react, and reason and adapt the situations. It is a program that coming upon to the machine learning. It is a study of computer algorithms that improve automatically through experience. So under artificial intelligence, machine learning is there. Under machine learning, it's a deep learning is one of the concepts. Let's go into the deep learning. It's like a subset of machine learning. What exactly deep learning? Deep learning is a machine learning algorithm based on learning multiple levels of representation or abstraction inspired by the structure and function of the brain, called artificial neural network. Basically, deep learning is a large neural network. What would the several layers of node between input and output do? It would do like it will identify the features like step by step, like our brains do. Next, going to the architecture, first I present about the shallow architecture, which is a traditional one is there. That is shallow architecture is like nothing but the machine learning. It's like it will have the input layer and only one hidden layer, and at last it has the output layer. But in deep learning, it has multiple layers used to detect the features, multiple features, that is low level features, mid level features, high level features. At last it will give the output layer. What were the applications the deep learning exist? It says many applications are there. Some of the applications are self-driving cars, visual recognition, natural language processing, automatic machine translation, and healthcare, and demographic and election predictions also is there. It's like photo descriptions for pixel restorations and deep dreaming also it is used. So many applications the deep learning or exist into. So going versus the traditional versus machine learning versus deep learning, as I said, the traditional language in image processing, I give an example for this, like a traditional machine language and deep learning. Take an image, actually a traditional method will extract the features that like a principal component, take the example as a principal component analysis. It takes the features from that and it go into the trainable thing. And in machine learning, after the PCA, it will input into the mid-level features, that is a machine learning algorithms. After that, it get into trainable thing. And in deep learning, raw image is getting into the extracting the features. No features like PZA, no extra algorithms needed in the deep learning, because it itself has an algorithm to extract the low level, mid level, and high level features. That is the difference between traditional versus machine learning versus deep learning. Then going to the why not traditional machine learning. This is deep learning is not a traditional one. It is a developed and is updated one, because as the size of the data growing, the performance of ML algorithm is depreciating. So that's what we have going into the so that's what we move to the deep learning algorithms to increase the performance, as well as growing the data. We can maintain the performance, as you see in the graph. Next, what is the pre-processing of an image? Because I said I'm using Octonian for pre-processing the image for the deep neural network. As I said, this is a pre-processing is a common name for the operations with image at lowest level of abstraction. The aim of pre-processing is an improvement of image data that suppresses unwanted distortion or enhances some image features important for further processing. Octonian pre-processing. What is an Octonian? Octonian is an 8-dimensional thing. That is an Octonian algebra, which is an extension of complex algebra and as well as a quaternion algebra. Quaternion is nothing but this 4 component is constructed based on 4 feature maps, including 1 intensity map, 2 color component map, and a motion map. Due to the limited channel capacity, we cannot incorporate many features into the quaternion image. Hence, in order to accommodate more features, we propose extending the quaternion image into Octonian image. That's what we are converting a quaternion image to Octonian image to extract more features from this. Octonian representation from quaternion. So here I'm giving the quaternion representation. QNM represent the quaternion representation, and ANM is a real part of it, plus IRNM plus IGNM plus summation of these RGB is a red, green, and blue values, blue components of the image, and IJK or the imaginary components of the image, as it is the quaternion is a complex algebra. As we know, it has imaginary and real parts. And advantages of Octonian processing. The Octonian pre-processed image is suitable for what we are doing is pre-processing for getting efficient object detection, efficient object classification, and efficient object recognition. For these purpose only we are doing the Octonian pre-processing. Variants of Octonian. In this work, I have given the 3 parts of Octonian, known as a simple Octonian, Octonian discrete Fourier transform, and Octonian wavelet transform. Simple Octonian transform. This is the Octonian representation, which I get it from the quaternion representation. F of nm, the summation of f of nm plus f of n m plus 1e. What is that? F of nm represents a 1 quaternion, and f of nm comma plus 1 is another quaternion. So 2 quaternion image will give our Octonian image. This is the representation of it. And RNM and GNM and KNM, GNM, BNM represent the RGB components of the image. Going to the Octonian discrete Fourier transform. The Octonian discrete Fourier transform, which allows for processing a color image as an 8D dimensional image in a spectral domain. The 2D ODFT can be calculated by using the dice. As I said, it is a calculation of 2 quaternion discrete Fourier transform. This is a representation of Octonian discrete Fourier transform, where it is an as you know the Fourier transform formula. The addition of that is a summation of 2 quaternion, 2 DFTs, f of nm and QNM e, the 2 for 1 real part and for 1 imaginary part. So next, going to the wavelet transform. What is a wavelet transform? Wavelet transform is nothing but it is a time frequency method. It is a linear transformation method, and in the image processing, it gives a multi-resolution representation of image, so it can reduce the size of the image. Wavelet transform is more powerful when compared to the Fourier transform, because the ability to describe any type of signals both in time and frequency simulation, which As tends to the Fourier transform, it describes a signal from time duration to frequency domain. So this is an Octonian wavelet transform. As I said, a real part and imaginary part. F of nm gives a real part, and g of nme gives a imaginary part of the image. This is the Octonian wavelet transform for the image. And these are my results as I go. Input image, the real part of this is fully the Octonian image, the first real part, and ijk, small ijk components of the image, and the e component, the next real part of the image, and capital ijk component of the quaternion image. This is the quaternion discrete Fourier transform image, and at last is a quaternion discrete wavelet transform image. And this is object detection results using the simple Octonian as a pre-processed method, and the next object detection Fourier transform method, and object that is a Octonian wavelet transform method. These are the three object detected that is pre-processed using the methods. After that, I am using CNN and getting the results. Only pre-processing I used Octonians here, various forms of Octonians, and after that I am using convolution neural network for the object detection method. This is a small part of the research I've executed here, so I didn't tell about the CNN and all, because pre-processing is a major topic in this paper. These are my references. And at last, thank you, ma'am. Hello, ma'am.
Thank you, Revati, for keeping up your time. Any
Yes,
questions? Revati, you can stop your presentation, Revati.
Yes, ma'am. Sure, ma'am.
Any questions? Okay, if
Thank
there are
you.
no further questions, let us move to the next speaker.
Thank you, ma'am.
Vaidyanathan,
Thank
sir.
you so much, ma'am.
Yeah, the next speaker, Vinay Kumar is there. Vinay Kumar? Vinay Kumar? No. Do we have
Sir,
Muruganand?
I am ready, sir. So I will finish up my presentation. No?
Yeah, possibly. I think the chair has to permit you, madam. There is one request from Manjunath. Should we? Hello, Rajeshwari, madam, are you there?
Muruganandam is there.
Muruganandam is not there. Is not.
Okay,
Muruganandam is there?
Rekha is there.
Yes, ma'am.
Yeah. So, Rekha,
Sir, good afternoon.
Dr. Rekha.
This is Rajagopal.
Yes, sir.
My candidate is Muruganandam. He has sent a mail yesterday that he is unable to present. That's why I want to inform.
Okay.
So it will not be presented.
Yes, he is unable to come today.
Okay.
So we are not presenting today. Thank you. Sorry for the inconvenience.
No problem, sir. Thank you.
Thank you. Thank you.
So, Rekha, you can start your presentation now. After Rekha, is Ram Mohan Reddy is there?
Sir, I have some work, sir. So your gap is there, na? You would have included me.
No, please, I'm just asking if Ram Mohan Reddy is there. If he is there, can you please answer? So after
Yes, madam.
Rekha, you will present. After Rekha, you will present. After Ram Mohan Reddy, Manjunath will present. Is it okay?
Okay, madam.
Yeah. Mr. Ram Mohan Reddy.
Problem, madam. Madam, yes, madam.
Yes.
Hello.
Hello,
Yes,
sir.
madam.
I'm Bhagwatam.
Madam.
Yes, Bhagavan Ram. Yes.
Yes, madam.
Ma'am, in 2 weeks.
Hello.
Can I start?
Bhagavat Ram and Rama Reddy, please mute your mic. Revati, Rekha is going to start her presentation now. Ram Mohan Reddy, if you wish to share something, put it in the chat box. We don't want to lose time. Rekha, you can start.
Is there or not? Sarodi Rekha, are you there?
Yeah, she said two logins she has done. Rekha?
Rekha is there, ma'am. Yes, Rekha is there, ma'am. He is presenting.
Yeah, from the beginning she is here. I have seen her. Yes.
Yeah, but she is not responding.
Rekha?
Rekha, please unmute your mic. Huh? You are muted. Please unmute mic.
Rekha, are you there or not?
Not working, sir. Yes, ma'am. Yes, ma'am.
Yeah, please start. I've been asking you to be ready, no? Last 5 minutes.
This one, right?
Yes, sir.
No. Yeah,
Is my voice is audible, ma'am?
Yes, we can hear you. Proceed.
Yes, ma'am. I'm Sarode Rekha, DRS1 Project Cell, Department of Statistics, Pondicherry University. I'm going to present a paper on enhancing credit card fraud detection techniques using stochastic models. This is the introduction. The credit card is a small plastic card issued to users a system of payment. Credit card security relies on the physical security of the plastic card as well as privacy of the credit card number. Globalization increases the use of the internet of online shopping that has resulted in a considerable proliferation of credit card transactions throughout the world. Credit card is also as a form of sophistication our money without actually carrying cash along with you. It's short form of cash have in your wallet. Hence, every holding a bank account has a credit card. Credit card fraud has a wide-ranging term of the theft and fraud committed using a credit card fraudulent use of the fund. This is the usage of credit card in the different platform. In online shopping, they are used credit card in 48%. Travelers using 47%. In overall, they are using the credit cards in 44%. Credit card for fraud can be done in the multiple ways. That is the application fraud, manual credit card implements, virtual card not present, fulfillment card fraud, main non-receipt fraud. Off track of stolen the card fraud, false merchant sites. These are the platforms for credit cards stolen. Usage of credit card account holders. Year by year, the credit cards and debit card cash here shown in the figure. These are the some literature review I collected, and this is the main objective of my paper. The objective of this paper is to forecast and predict and create the credit card fraud by applying the hidden Markov model. The chance of happening credit card fraud in the future using historical data of credit card users through hidden model Markov approach. This approach helps in finding the probability of making out the next possible credit cards. The main aim of this paper is to detect the credit card with minimum cost and more accuracy. It uses the two hidden states and two visible states transition probabilities in finding out credit card funds more useful than other models. This is the schematic for hidden Markov model. Here, the credit card fraud is done in the online and offline because some credit cards are stolen by someone means it happening in the offline fraud, and online means we are using the online payment like phone pay, Google Pay, and like etc. Then they are using the problem of online. Next, these are the mean and central movements. Next, these are the central movements. characteristic function, and probability generative function. These are the results and discussions. I collected the 500 sample credit card transaction is gathered from the secondary source of data. The constructed a transaction probability matrix for this data is applied in hidden Markov models. 500 number of transactions I collected. This is the credit card shopping mall in the transaction details. When the transaction is high, then it is a more possibility to happen the fraud. Next, this is the transaction probability matrix for when I collected the data. This is the transaction probability matrix. In second stage, fraud followed by fraud. This is the probability for finding the happening of fraud. In third stage, this is the probability of finding the fraud. Next, this is the fourth stage, finding the fraud in credit cards. In the fifth stage, and in the 50th stage, it is a fraud followed by fraud. And these are my references. And thank you.
Okay, thank you, Rekha. You can stop your presentation now.
Okay, ma'am.
Any questions? Any doubts? Okay, Rekha, you say you have collected some data regarding credit card from secondary source.
Yes, ma'am.
What data you have collected?
Amazon, ma'am.
What data? What is the information you got? What are the variables?
Online transactions, ma'am.
What are the variables in your data? Just this, only some details about what factors you have got from this data.
Transaction details only, ma'am.
Means some X person has spent this much amount, Y person has spent this much amount. Only the amount,
yes,
is
ma'am.
it?
Yes, ma'am.
So that is permissible under the Data Protection Act?
No, madam, not that one, ma'am. Just per day, how many people are transaction? That
Okay.
data, ma'am. Transaction data, ma'am.
Oh, just how many are using, that's all. That's the information.
Okay, ma'am. Thank you.
But how that can give you something about fraud?
That's what.
Sir?
That's what.
No, actually, your thing is you are talking about something about fraud detection. Am I clear? So the
Yes,
number
sir,
of
yes,
transactions with that, how do you identify whether it is a fraudulent transaction or a good transaction? Some piece of information should be there.
Sir, can you repeat the question?
No, your topic I understand is on fraud detection, correct?
Yes, sir.
Yeah, but when you collect the data from the secondary source, you are saying that you are seeing only the number of transactions that has taken place.
The number of transactions, sir. If the number of transaction is more, there is the probability to detect the fraud. Happening the fraud will happen.
No, but you don't have any fraud data.
HMM model study. This is direct. Just to say that, if you more number of usage, more probability of being fraud is, it's a known fact. Yeah, it's a common sense.
Yeah.
So some specific variable should be involved, which is going to tell you exactly the percentage, or you should be how much percentage of time it happens. If a person transacts 10 times in a month, this is the percentage by which it can happen, something like that. That's more meaningful.
Okay, ma'am.
Okay, thank you. Give a thought about that, okay?
Okay, ma'am. Okay, ma'am.
So, who is the next person? Dr. Vaidyanathan? Ram Mohan Reddy.
Can I speak? Sir, ma'am, I am Bhagwatram.
Bhagwatram, you have to wait, please. The next chance is Ram Mohan Reddy.
Okay, ma'am. Thank you.
Ram Mohan Reddy.
Okay.
That's it.
Ram Mohan Reddy, are you ready?
Ram Mohan Reddy. Are you there? Please unmute and speak, sir. We are not able to hear you. Ram Mohan Reddy. Yes. Are you ready, sir, with the presentation? Can you present now?
Sir, technical problems are not clear. Network problems, some problems are
Okay, fine. So,
not clear voice. Sir,
okay, so in
technical
that case, you have
problems
to
are.
wait.
So do you
Okay,
want to
okay.
present or not? Hello?
Present, madam.
So please try
Present,
now.
present, madam.
We are able to hear your voice. You try to present your screen. Let us see if it
Present,
is visible.
present. Madam, I present, madam.
Yeah,
Some
please,
technical
please.
problem, madam.
Present, sir.
Okay, see, please then wait for the next cycle. Okay, we'll move to the next person.
Manjunath? Yeah. The next is Manjunath. Are you ready?
Oh, yes, sir, I am ready.
You can give your
Yes.
presentation.
Yeah, please.
Yeah, thank you.
Please on your camera and then share your presentation, sir.
Yeah. So good afternoon, everyone, and I thank organizer during this pandemic. So what? So that effort and also I thank organizer also. Today's topic, what I selected, so yeah. Yeah. So full screen. Okay, so I today I decided to discuss about the family of the regression function. For example, I would want to know the complete family of bivariate distribution whose conditional expectation will be linear. So that means uh, it's a regression function. So that is my interest, and I started working on that. So. And this is the agenda of the talk. So motivation, how we got motivated to this.
Yeah.
And
Can you just make it as a full screen or a slideshow?
Yeah.
Go to view button.
Video.
View after edit, like third one.
Third one, na? View, okay.
Yeah.
View full screen.
Last one, enter full screen.
Zoom out,
Last
zoom
one,
in, zoom
last
out.
option.
Let's come down.
Yeah.
Enter full screen.
So yeah. So these are my topic I'm going to discuss. So now, so you have a bivariate normal distribution. So what do you have? So you know the marginal distribution is also normal, and the conditional mean will be a regression function, and the conditional variance is free from the conditional variable. So all these properties are, if you want to look at the counter example for this, so here's 1 minute. So you look at this density. So this density is not a normal, but still we have a conditional means non-linear, so biquadrate, and the variance, conditional variance also biquadrate. So here what we do is, now what I want to do is, so I fix my function. I want the linear function for the data set. I want to construct a test whether it is a normal distribution or any other distribution, looking at only the video of that. So now, so I included one of the topic was compatibility. So compatibility means if you say that the given density is compatibility with the bivariate density, okay. So then this compatibility is satisfied. Means at least one density should exist. So we say it is compactable. So this kind of things and all for Gaussian, Gibbs sampling and Bayesian. So all this application you can use. So now if you look at, so here this is shifted exponential density. Both the conditional belongs to shifted exponential. Okay. Which is not compatible. So compatible means at least one bivariate density should exist. So that condition, if you want to satisfy, so you have to take the ratio of the two conditionals. If the ratio of the two conditional integrate to infinity, then we call it as a it's not a compactable density. So this is the thing. So now what I do, main concentration is, so so let take x given y belongs to normal mu y and sigma square y, and y is also marginally normal. So then the conditional density will be typically so it won't be the normal unless mu y is linear and sigma square y is constant. Okay. So in this scenario, so if you look at here, the functional form of mu x and sigma square f, we don't have any restriction. Okay. So this kind of density also exists. Okay. So if you combine these two, it will be a bivariate density. So now what I do is, so there are so many characterization. So in the literature, if you look at, so now since marginal is also conditional is also normal, another conditional is also normal, y given x is equal to x is also normal, then this mu of x is enough to characterize the bivariate normal. So that means you can characterize the bivariate normal with the two conditional distribution and at least one linear one conditional mean and conditional variance. So this 4 is enough to characterize the bivariate normal. So now I will show you how to yeah. So Poisson case is there. So now I told you, right? So how do you get the marginal? So there is common. See now. So if you want to find all the families of regression function of, see, this is the formula. So this is the formula you have to follow to compute all the regression function. And another thing is you have to, if you want to construct the other way around. So what are the function is? So if I will fix mu of x is some function arbitrary, I don't put any condition on that. So what are the densities or distributions? So that this kind of transformation is allowed. So this is my aim. And if you want to look up, recently we wrote a paper also. Okay, thank you.
Okay, thank you, Manjunath. May I know your affiliation, please, with the University of Hyderabad?
Yeah.
What are you at the University of Hyderabad?
Assistant professor in statistics.
So you are Dr. Manjunath.
Yeah.
You could have put your designation properly in the first slide, no?
No, usually we won't put designation in the slides. Only will include the names.
And during 10 minutes of your presentation, so much of shaky in your mobile or desktop, or I don't know what you are using for presentation. So you must be teaching online classes, right? Using this.
So you are guiding me, or what? What are you doing? I don't understand. Take the class or how to do the presentation.
No, just checking why is there a problem with your presentation? I'm just asking. That's all.
No, that's what I asked you. Na? So are you? So what is your intention? I didn't understand. Are you grading me?
I'm very not comfortable with your presentation. Why was it shaking so much? Was there any disturbance? It's only from your point of view I'm asking, okay? Okay, anyway,
my
thank
point,
you so
your
much.
point. Yeah.
No, Professor, I think Dr. Manjunath. Hello? You're there? Dr. Manjunath, you're there?
Sir, continue with other presenter, sir. This.
Yeah. Fine, madam. I think lots of connectivity is lost there. Yeah.
Oh, yeah, I think she discontinued.
Yeah. We can go for the next speaker in that case.
Yes, please.
Yeah. The next speaker is going to be Seema Singh. Are you there?
Yes, sir. Yes, sir.
Yeah.
Sir, is my screen visible?
It's coming up, yeah.
A very good afternoon to all of you. My name is Seema Singh, a research scholar from Department of Statistics, MD University, Rohtak, Haryana. Today, I am here to present my paper, Application of Fuzzy Soft and Interval Value Fuzzy Soft Matrices in Dimension Reduction and under the supervision of Professor S. Malik, Department of Statistics, MD University, Rohtak, and Professor D.S. Sudda, Honorary Professor at JJ University of Science and Technology, Hisar. This is the abstract. There are different techniques used in decision-making problem. Many researchers use fuzzy set, soft set, and fuzzy soft set in handling imprecise information. Matrices are the important tools to handle such problem. Researchers focused on the use of fuzzy soft matrices in decision-making problem. In the proposed keynote address, fuzzy soft and interval valued fuzzy soft matrices are defined with example. The application of fuzzy soft matrix in data dimension reduction by geometric mean approach is studied. Geometric mean method for interval valued fuzzy soft matrix. A method is also proposed to study Sanchi's approach for medical diagnosis through geometric mean of interval valued fuzzy soft matrix. This is the introduction part. Fuzzy set was and was extended to interval valued fuzzy set by Gorzal, Zeni, and Tuxen to represent the degree of membership of an element by interval rather than exact membership value. Extremely important area in mathematical sciences as that plays key role in analysis of data and also principal tool in validating theoretical results in fuzzy set theory. Soft and interval valued fuzzy soft set are presented in fuzzy matrix are called fuzzy valued fuzzy soft matrix respectively. The concept of interval valued fuzzy soft matrix is the generalization of fuzzy matrix by extending the max minimum operation on fuzzy algebra. The parameterization tool of interval valued fuzzy soft matrix enhanced application of interval valued soft set. To develop the soft set theory, Kagman redefined operation of soft set to improve several new results, and unique decision-making method was constructed by using these new operations. These are practical and can be applied to many problems that contain uncertainties due to vagueness. Studied Sanchi's approach of medical diagnosis through interval valued fuzzy soft set and improved of the same was presented by D et al. The concept of interval valued fuzzy soft matrices as a generalization of fuzzy matrix was introduced and developed by Schaumel and Paul. Studied fuzzy soft set in dimension reduction and medical diagnosis. Fuzzy soft set, a universal set X and a set of parameter E, and a set A is a subset of E. Let Fx be the set of all fuzzy subset of X. Then the pair Fa is called fuzzy soft set over X, where F is a mapping from A. This is the example for fuzzy soft set. Fuzzy soft set. Let U be the universal set. with the set of parameters, and P with the powers of interval value for G set, and A is a subset of parameter set E. Then the pair FA is called interval value for G of set over U. F is a mapping from A to power set of U. Interval value for G of set, where H is the set of 4 houses and E is the set of E is the subset of E contain E1 and E2. Valued for G set over H to give the attractiveness of the houses. Oriented object grade for fuzzy subset FE, let X be the set of object and E is the set of parameters. Then oriented object grade with respect to parameters. Summation over J Vij divided by absolute value of E, where Vij is the membership value of object in fuzzy subset. Parameter grade with respect to object is given by summation over divided by magnitude of X, where Vij is the membership value of object in fuzzy subset. Threshold value for the fuzzy subset F and E are the set of object and parameter respectively, then the threshold value is given by this. Fuzzy soft matrix. Next, fuzzy soft matrix and some operation are defined. Let the universal set and E be the set of parameter and A is a subset of E. FA be the soft set over U, then the fuzzy soft set A in matrix form is represented as a matrix M cross N order, where Ij is the membership function given by mu J if Ej belongs to A and 0 if Ej does not belong to A. Example 3.1. This is the example of the fuzzy soft matrix. Some operation form of fuzzy soft matrix. Union of two fuzzy soft matrix is given by A union B is equal to C M cross N matrix is equal to Cij, where Cij is given by Aij plus Bij minus Aij into Bij, where Aij is the membership value of A and Bij is the membership value of B. Of union, A is a matrix, where B is a matrix, and the union of A and B is given by matrix C. Intersection of two fuzzy soft matrix is given by A intersection B is equal to matrix C of order M cross N, where the Cij is given by Aij multiply Bij. This is the example. Maximum operation of fuzzy soft matrix. Maximum operation is given by C M cross N, where Cij is equal to maximum over Aij Bij. This is the example of maximum operation. Again, the minimum operation in the similar way. Minimum operation on fuzzy soft matrix is performed by AB is equal to C, where Cij is Aij Bij. Max minimum operation on fuzzy soft matrix. The max minimum operation of fuzzy soft matrix A and B is given by maximum minimum over AB is equal to CM cross N is equal to Cij is equal to, first we take the minimum of Aij Bij, then we take the maximum over the this is the example for max minimum operation. Next is minimax operation on fuzzy soft matrix. In the similar way, minimum max operation on fuzzy soft matrix as minimax AB is equal to CM cross N, where Cij is equal to, first we take the maximum, then we take the minimum. This is the example of a crisper matrix than B. A matrix A is crisper than B if all the elements of Aij are less than equal to Bij and Bij is less than equal to 0.5, or each Aij is greater than equal to Bij and Bij is greater than equal to 0.5. This is the example complement of matrix. The complement is considered complement of matrix is given by 1 minus Aij, that is all elements are subtracted from 1 and 1. Is the usual manner. Now, application of fuzzy soft matrix in data dimension reduction. This is the algorithm for data dimension reduction. First, we input the soft set, then we construct the soft set of He, then we construct the matrix He. Then we find the oriented object grade and parameter grade using the geometric mean respectively. Then we calculate the threshold value by using the usual method. And next we remove those rows for which oriented object grade is less than threshold value, and those columns for which oriented parameter grade is greater than threshold value. Matrix is our desired dimension reduced matrix. Be a set of 6 houses and E is a set of parameter 8 parameter. Let Mr. X is interested in buying a house on the basis of his choice of parameter given by P. Matrix representation of subset HP is given by. Convert this matrix given in table 4.1 into Fudge's soft matrix by using the algorithm 4.1. This is the Fudge's soft matrix after the calculation. Oriented object and parameter grade by using the and EJ given in the matrix are the oriented object and parameter grade respectively. Values of the given matrix is 0.42. Now we remove those rows and columns which are given in as we suggested in the algorithm. This is the reduced dimension reduced Fudge's soft matrix. It is noted that the data size is reduced by approximately 80%, where our method is simpler than that of arithmetic mean due than Ritu. Valued Fudge's matrix. For the pair of Fudge's of matrix A and B, such is equal to B, let us define the interval value for the matrix denoted by AB, whose ith, jth entry is interval limit Aij and Bij called lower and upper limit respectively. Basic operation performed on interval value Fudge's of matrix are the 2m cross n order Fudge's of matrix. These are the operation. Now algorithm for geometric method. Method and algorithm for application of interval valued Fudge's of matrix in medical diagnosis. Geometric mean of interval valued Fudge's of matrix A, ALAU is defined by GMA is equal to under root ALAU. Thus, we get the resulting matrix as the Fudge's of matrix. Algorithm. Input interval valued Fudge's of matrix FD and FD complement over the set S of symptoms where D is the set of disease. Represent matrix this by relation R1 and R2 respectively. Input the interval valued Fudge's of matrix by represented by relation matrix Q. Matrix R1 and RQ in the form A is equal to ALAU. Then we compute the geometric mean of interval valued Fudge's of matrix R1, R2 and Q denoted by this. Then we combine the relation matrix GM_R1, GM_R2 and GM_Q separately under max minimum composition of Fudge's of matrix. Then we calculate the diagnosis score ST1 and ST2 for and against disease respectively. In the last, we calculate SR maximum of SJ ST1. If SR is maximum for exactly one pair, that is for pair PI-DR, then we can say that patient PI is suffering from disease DR. Otherwise, we have to repeat the symptom for the patient. Illustration. Let S is the set of symptoms of certain disease, D is the set of disease, and P is the set of patient. Let S contain 4 symptoms: headache, cough, stomach pain. Let possibly disease relating to symptom are viral fever and malaria represented by D1 and D2. The approximate description of medical knowledge of 2 diseases and their symptom is given by interval valued Fudge's of matrix, Fudge's of set as this. We represent this in a matrix form as R1 and R2, where a favor of is the symptom disease matrix and R2 is a known symptoms disease matrix. 2S is called the relation between patient and symptom matrix, represented in Q. We write R1 and R2 in the form AL and AU. Similarly,
Seema
Q is
Singh,
written in the AL.
time is up. Try to conclude.
Okay. Fudge's offset theory is being applied to many theoretical and practical fields. In the present paper, we define Fudge's of matrix and interval value Fudge's of matrix, which are matrix representation of Fudge's of and interval value Fudge's offset respectively. Fudge's of matrix in data dimension reduction using geometric mean method and illustrate with an example. We also Define the application of interval valued fuzzy SOM matrix and study its application in medical diagnosis by geometric mean method, which is new technique different from Kaliraja's method. Thank you. I have done, ma'am.
Thank you, Seema, for your good presentation.
Thank you, ma'am.
Any questions? Okay, if there are no questions, we move on to the next speaker. The next speaker is Bhagavat Ram. Bhagavat Ram,
Yes, madam.
kindly present your work.
Hello, ma'am.
Yeah, we can hear you. You
Okay,
also
ma'am.
on your video for the recording.
Madam, my internet connection is 2 weeks, so if I open the video, then I will be lost my network.
Okay, start. Let us see. Just for 5 minutes for the record's sake, 1 or 2 minutes to come online,
Okay.
and then you can switch off and make
So
the.
can you, are you able to see the slide, ma'am?
It's not yet come.
How to share the screen, ma'am?
See, on the bottom white bar, you have what is called present now. Click that.
Yes, ma'am. Click on clicking.
Present now, it's a share. Share the entire screen, you click.
Okay, ma'am.
Then down share, you give again.
Okay, ma'am. So is it visible, ma'am?
Did you click the share also once again on the bottom? Yeah, now it's coming.
Okay,
Yes.
ma'am. So I am a senior research fellow at final stage from DST Center for Interdisciplinary Mathematical Sciences, Institute of Science, Banaras Hindu University. And my supervisor is Professor S.K. Misra, Department of Mathematics, Institute of Science, Banaras Hindu University. And Professor Mohammad Ismail Sami from Abu Ali Sina University. He is my co-author. Now the paper is basically funded by the Science and Engineering Research Board, grant number DST SIR MTR 2018 000121. And the second author is supported by Abu Ali University. And myself is supported by University Grant Commission UGC 2015 UTT 59235. My abstract is like that. We trying to present an algorithm for solving unconstant optimization problem using Q gradient descent method, and the idea is that we construct an algorithm using the approximation of the Q gradient, which is computed by the Q derivative, and for convergence part we apply the quasi-convergent method to prove, which is basically without any level set boundless assumption, and at last we show the numerical experiment which perform the effectiveness of the proposed algorithm. So what is algorithm? Algorithm is a collection of set of statements which solve the optimization problem. Here we consider the optimization problem in this form, where f Rn to R is called the objective function, and the variables x1, x2, xn which are in Rn are called the decision variable, and omega, which is subset of Rn, is called the constant set or feasible set. So optimization problem in the field of optimization is divided into two parts. Optimization problem and second is constant optimization problem. So here we are dealing with the unconstant optimization problem. In unconstant optimization problem, each omega is equals to in Rn, then optimization problem here will be in the form minimize f of x subject to x in omega. And basically in optimization problem we take any nonlinear function and we try to minimize. So minimizer is divided into two parts. One is local minimizer and second one is global minimizer. So the basic difference is like that. When the function omega, which is subset of Rn to R, a point x star in omega is a local minimizer of f over omega if there exists epsilon greater than 0 such that f of x star less than equals to f of x for all x in omega excluding x star and norm of x minus x star should be less than epsilon. We are speaking about the global minimizer, just we remove the norm of x minus x star less than epsilon and x should be in omega excluding x star, then it will be the global minimizer. So in the gradient, we are applying generally Q gradient function. So before going to know about the Q gradient function, we must know what is gradient of function. So when the function Rn to R, the first derivative df is like that, and the gradient of f will be in this column form. So here one simple example can be given as suppose function of two variable f of x1 plus 8x2 plus x1 x2 minus x1 square minus 2x2 square. So gradient of f of x equals to 5 plus x2 minus 2x1 and 8 plus x1 minus 4x2. So here we are doing, first we are differentiating with respect to x1 and keeping all the variable as a constant, and in the second time we are differentiating with respect to x2 and keeping x1 as a constant. So we are dealing with the feasible direction. Feasible direction means where we should move. Rn where d is not equals to 0 is a feasible direction at x in omega if there exists alpha not greater than 0 such that x plus alpha in d in omega for all alpha in close interval 0 and alpha naught. So full example is consider a function f r3 to r where f of x equals to x1 x2 x3 directional derivative at d. So here this is the simple calculation to find the directional derivative, and this is a one important theorem which will be used to develop the algorithm and show the convergence theorem, which is first order necessary condition. Let omega be the subset of Rn and f is the first differentiable function be a real valued function on omega if x star is a local minimizer of f over omega, then for any feasible direction d at x star we have d transport gradient f of x star should be less than equals to 0, and this is one corollary which is a special case of first order necessary condition. This is called the interior case. Let omega be a subset of Rn and f in C1 be a real valued function on omega if x star is a local minimizer of f over omega, and if x star is an interior point of omega, then gradient f of x star should be 0. Ma'am, I am audible? Hello?
Yes, you are audible. Proceed.
Okay, ma'am. Okay, ma'am. So this gradient descent method was developed by the Cauchy in the year 1847, and first it was developed to solve the system of linear equation, but after some years it was used to minimize the nonlinear function. Here gradient method, we know that the gradient acts in a direction in which the function f increases more than in any other direction. Therefore, the direction of negative direction is a good direction to search if you are looking for the minimizer of the function f. So this negative direction is called as the descent direction. When you take the positive direction, that direction will be the ascent direction that will be used to find the maximizer of a function. But in the optimization, we find the minimizer of the function. Therefore, we take the descent direction. So this is one overall picture how to move from one point to another point to find the minimizer of any nonlinear function. If a sequence xk from k equals to 0 to infinity is a steepest descent sequence for the given function f Rn to R, then for each k the vector xk plus 1 minus xk is orthogonal to the vector xk plus 2 minus xk plus 1. Means the difference of the two consecutive points should be orthogonal to the next difference of two executive points. So this is the basic strategy of the steepest descent method or the gradient descent method. So here, if the sequence xk from k equals to 0 to infinity is the steepest descent sequence for f Rn to R and gradient f of xk not equals to 0, then f of xk plus 1 should be less than f of xk. So here xk plus 1 is the next iterative point and xk is the previous point. So the next iterative point xk plus 1, at this point the function value must be decreased to the point at xk. So now we move ahead. So this is a one simple example. Suppose this is a simple quadratic function and we find the gradient descent method or steepest descent method to with a starting point 2 1. So here what we do, first we take the gradient of the function and then again we find the Hessian q2002. We choose the initial point x0 as a 2 1. So at point we find the gradient of the function. So here we'll get 4 4 and we just apply some formula. This is a formula x1 equals to x0 minus alpha 0 g0. This alpha 0 having formula is like that and it gives 1 by 2 and x0 the initial point, just we put the value, so we get 0 0. If the gradient at this point is 0 0, we will stop because this is a stopping criteria. Gradient of the function is 0, then we will not move again. So the function is minimized as x star equals to x1 equals to 0 minus 1. And this is a one recommended book that my supervisor shared for the students. So I'm sharing here also. This is a very popular book for understanding the steepest descent and other algorithm in the field of optimization, written by Chong and Dock. Now we are applying the Q calculus in this steepest descent method. Q calculus particularly has again a lot of interest in various fields like science, mathematics, physics, etc. And it was developed by the Jackson in the year 1909. It is a 100-year-old theory. The Q derivative dqf of a function f r to r is given by dqf of x equals to f of x minus f of qx by 1 minus q into x, where q, we have taken q in between 0 and 1. So when the q is approaching to 1, so it will work as a classical derivative. So therefore q should be in a open interval 0 and 1, so that it will be treated as a q derivative. And it is obvious that q derivative of a function is a linear operator. Then for any constant a and b, we have dq a into f of x plus b multiply g of x equals to a multiply dq f of x plus b dq g of x. This is a good recommended book for the quantum calculus written by Bachman Chong, which is written in the year 2002. So why we apply Q derivative on constant optimization? It comes in mind because the Q gradient is implemented in such a way that search process gradually shift from global in the beginning to almost.
Your time is up. You
Okay,
should
okay,
wind up
okay,
fast.
okay. So this is the algorithm that we have written here, and based on this we have solved 28 test problem, and we have shown the performance profile through which we can show the performance of our algorithm in a graphical mode. And this is the two book we have written with my supervisor, and some good papers we have already published in the SCI journal. Almost we have published 6 paper. Okay, madam. Thank you.
Thank you, Dr.
Okay,
Bhagwat
madam.
Ram. It was a good
Okay,
presentation.
Thank you, ma'am.
Thank you. We can unshare the screen now. So any questions? Bhagwat Ram's presentation? Yes, sir.
Dear madam, good evening.
Yes.
I want to just to convey a small opinion regarding the presenters. The last presentation by Bhagwat Ram, during the last presentation, he has been giving the basics which have been available, all the fundamental books Until then, his time is up.
Yes.
The last part where he has worked something, he has developed some algorithm and he wanted to discuss some algorithm. And the same for the previous person.
Yes.
To extend 1 or 2 minutes for such cases.
Okay.
So that we can see what they have concluded, what they have obtained.
Actually, in the beginning of that, if I'm rolling the chat, if you can see,
yes,
I keep telling the lesson, kindly focus on your objective, your study, and your findings and conclusion, because you have only 10 minutes. They take so much time in introduction, literature survey, and the main focus they are missing. Yes, sir. I will give 1 or 2 more minutes. No problem. Thank you, sir.
Thank you, madam.
Bhagavath-ram, you defined what is a Q derivative, right? Bhagavath-ram, you are there?
Yes, ma'am. I'm here, ma'am.
So, how is it different from the fractional derivative? Is there a relation between dq, the perfects, and the fractional derivative of?
Yes, in fractional derivative also we apply the Q derivative, and in that case, the Q should be greater than 1. But in my case, we had
the derivative, this Q should be greater than 1.
Yes, greater than 1. So it will be more than 1 also. The value of Q should be maybe more than 1. But in my case, I have taken the value of Q which is approaching to 1.
Okay.
Means it will be treated as a classical derivative so that the convergence should be fast.
Okay.
Basically, ma'am, in Q derivative, we have applied the objective is to show the least number of iteration.
Okay.
And based on this, we have published 6 papers in good journal, ma'am.
Okay. Now,
Can you
I
show
want
that
only
application?
clarification. I never doubt your work at all. Don't worry. I'm just asking the clarification between dq and the fractional derivative and the dq derivative. That's all.
Okay. Sir, one book we have written, Introduction to Unconstant Optimization with R, and here we have shown the real life application also with the help of optimization algorithm.
Madam, can you allow him to show that application?
Yes, definitely. You can present again, no problem.
So can I open my book or what, ma'am?
No. I don't think you have to open your book. But
Professor Rajagopal is asking a specific doubt.
Yeah.
Your application. You open your presentation, he will ask you where.
Okay.
Open your presentation.
Only from his presentation, not from other material.
Exactly.
Okay, ma'am. Okay.
Yeah.
Again, I am sharing.
Yeah.
In my presentation, I don't have shown the application, but in this, can you see my screen, sir?
Yes, your screen is visible.
Yes, but in this book, the application part is already we have provided.
No, that is fine, Bhagavath-ram. But the thing is that when you give a presentation, you should give an application. That's what Dr. Rajagopalan is interested in knowing. So
Okay, sir.
And one more suggestion to the researchers is, this is a forum to discuss and convey our new findings. We can take support from the existing literature. So the very objective is to display or demonstrate our findings. Thank you.
Okay, thank you, Bhagavath-ram. Thank you.
Thank you, madam. Thank you.
So we have 2 more speakers who are left. One is Vinay Kumar. Are you there? Vinay Kumar? And Ram Mohan Reddy. Are you there, sir? Ram Mohan Reddy? He was telling some sort of connectivity issue.
Both
are you there?
Present, sir.
He is not present.
Yes.
Oh, fine. So maybe the next person is Vinay Kumar.
Vinay Kumar.
Vinay Kumar.
Vinay Kumar is also not present.
Okay. So Vinay Kumar is also not there. So in that case, yeah, we have 3 speakers who have not presented, madam. One is Ram Mohan Reddy, another is Vinay Kumar, other is Muruganandam. Of course, for Muruganandam, Dr. Rajagopalan has given a reason for his non absence in this meeting. The other 2 speakers, we don't know what happened to them.
Hisham, are you there? Hisham.
Yes, sir. Yes, sir.
Yes, sir.
What about that speaker's information, that paper presenters? Any communication given whether you have?
Yes, sir. Yes, yes, sir.
already
Yes,
joined,
sir.
sir.
They joined
But,
and they went left, sir.
Okay.
Due to the technical issues,
They have mailed everybody.
Okay, okay.
So
So,
already joined, sir. But due to the technical issues, he can't able to present, sir.
no. What I wish to know whether they want to change to another sessions or something like that. Any adjustments were made?
Yeah. No, sir. In this session, only Regas was shifted, sir. Remaining everybody's was the same. It was already communicated for 2 weeks back.
I think one adding talks are also everything can be accommodated here only.
Yes, sir.
Yesterday, some talks were postponed to. If there are any other things, you ask them to join here.
Yes, sir. And everybody's
You made
over.
it already. I think
Yeah,
you
yeah,
made
yes,
it.
sir.
So,
Yes, sir.
then there are no presentations. I think these 2 people, 2 or 3, it seems, sir.
Yes, yes.
They are unable to attend, it seems, sir.
Correct.
Okay.
Fine, sir. That's okay. That's okay. So, madam, yes. So we don't have any other speakers in that case. So
shall we conclude, sir, this session now?
Yeah, madam, I would like to write a mail letter. So I need of course, I will send the videos also. Videos of individuals after breaking the total video content into parts.
Okay.
I will send the respective chairpersons to adjudicate that presentations, because we have a plan to select the best 2 presentations among technical papers,
Okay,
as
sir.
well as best 2 talks among the invited people. For
Okay, sir.
invited people, I want to make some another mechanism. For this technical paper, I would like to send that videos to you people again, so that you can make. Otherwise, if you have any
Sir,
idea,
now we have listened, both of us have listened to all the talks. Maybe in another half an hour we can chat together and finalize also.
better. Otherwise, I will do.
But you
one
want to
thing,
give the rubrics on which we want to evaluate some markings.
yeah. I will do one thing, madam. Both you people will be sent that videos, so and you can make individual evaluation, so that you rate them on a 10-point scale.
Okay.
So from most inferior to most effective, 10-point scale. So after that, we will consolidate and arrive to the best paper. Okay, madam?
Okay.
Right, that might be good. Okay. So I will do it in within next week. I will do it, madam.
Okay, sir. Okay.
So valedictory function also, I mailed to CRO's daughter, and I'm waiting for her response.
Okay, sir.
If sir health conditions and other things permits, he may join us for a virtual award presentation.
Okay.
So if not, then for the second week of December, we may have valedictory function exclusively, like inaugural.
Okay, fine. Okay, sir.
Okay. At that time, we will reveal all these results and everything.
Okay, sir.
madam?
Okay.
Right. Thank you. Thank you for your. You
session,
on your cameras, madam. All participants also try to on their cameras, so that I will have a group snap, dashboard snap. It is a group snap of a dashboard. So you please on your cameras. All are. I'm I'm just making.
Yeah, one person joined now.
Okay, no problem. And one person means any participant to present paper or what?
Yeah, he is actually the speaker, but he has got connectivity issue. 4 or 5 times he has left, he has joined.
Oh, technical issues. Okay.
Yeah, technical issues.
So whether he's able to present now, anyway, now you just make yourself all on their cameras. You just make some sound so that you will pop up the first position. That is the thing you will have a alignment is correct. Yeah, otherwise, okay. Right, I want to see my face and to camera. Right. Okay, now thank you.
Okay.
So, do you want to make it that person you want to inquire?
We'll check once the last call. Mr. Ram Mohan Reddy, are you there? Would you like to make a presentation?
It's our last call. All participants that there will be.
Sorry, again left. Okay.
Yeah, Ram Mohan Reddy is there. Reddy. Yeah.
Reddy Garu, would you like to make a presentation now?
Yes, madam.
Okay, so only yours is the last. So kindly make
Okay, madam. Not to presentation, madam.
Yeah.
It's coming now. Yes. Open your file now.
You minimize the screen. You minimize this Google Meet screen.
Not to.
No, just minimize. No, don't stop presenting.
No, don't do that.
You just
Go
minimize.
to the bottom. Already opened the presentation file, right? Just click that file. That's enough.
You just minimize this browser, Google Meet screen. Yeah, just now you open your PPT.
Yeah.
Okay, sir.
Yeah, it's coming now.
My topic, sir.
Just
action boundary layer flow of a double display and rotating fluid fast vertical porous plate.
You please make it an
formulation of the problem, sir.
Hello, Dukiriti.
Sir.
Dukiriti,
Yes, sir.
Screen option. That is a full screen option. Slideshow option is selected.
Rather, you can press F5.
Top menu
F5.
slideshow. You
Okay.
click on the slideshow on the top menu. Next to file, home, insert is there, no? There you choose slideshow.
Just press F5.
F5, madam.
Yes.
F5. No, sir.
I think F5 along with another button you have to manage.
No. See, you can go to slideshare
just
and
come down.
view full screen.
Reddy, you just come down bottom. There, zoom option is there, right? 70% is showing, right?
Come down.
Last
sir,
right side, 70%.
Bottom right corner, rightmost corner.
Okay,
Before that, you just click that one.
That you pull that.
No.
Right, so option.
Left. Left bar.
Little left. You can see one mark there, right?
Yeah.
Not
there you
before
pull
70.
it to
I
the
mean,
pull it to the right.
before 70. No. Just
Yeah,
left. Come.
Not
left.
increase, sir.
Pull it to right.
No.
Pull it towards the right side.
No, ma'am. Please wait. I will just you just come before 70%. No. You just come left.
You can see a symbol like ice cream cup. Just
ice
click
cream
on
cup.
that. Yes, just click on that.
Okay, sir.
Now it is
Okay, sir.
Sir, please,
it's okay.
one only you tell that.
Okay, you now proceed with your presentation.
Okay,
Go to
madam.
your first slide.
Ganapati,
yes,
only
sir.
one person.
Madam, that's all.
Ganapati, you tell.
Yes, sir.
Ganapati, you tell.
Yes, sir. I will go on it, sir.
Okay, sir. This is flow geometry for coordinate system, sir. This is equations, my non-dimensional equation, sir. Boundary conditions, sir. These are boundary conditions. Now we these are non-dimensional equations, sir. Then we return these equation, we get the corresponding boundary conditions. So equation technique, sir. Then temperature. Now we find temperature, concentration, and velocity, sir. Is heat transfers, rate of mass transfer, result and discussion, sir. So topic, gross of number is increasing, sir. Velocity is increasing for the gross of number is increased also, sir. These are effect of solution of gross of number on primary velocity and secondary velocity increases, sir. Velocity is increases of the gross of number. These are effect of magnetic parameter on primary velocity and secondary velocities. Now here velocity is increasing for magnetic parameter. This is effect of porosity parameter on primary velocity and secondary velocity, sir. Here also velocity and secondary velocity is decreasing. These are effect of suspension parameter, primary and secondary velocity, sir. Here primary and velocity opposite, one is primary velocity decreasing, secondary velocity decreasing for sir. This is effect of heat absorption and general velocity. In this graph, velocity is increasing for the heat of primary velocity increasing and secondary velocity is decreasing. This is effect of heat absorption and secondary velocity. Here also primary velocity increasing, secondary velocity decreasing for the Q values. This is Prandtl number and temperature. Temperature here for the increasing values of PR numbers. This is effect of suction parameter on temperature. In this figure shows that temperature decreasing for the suction parameter, increasing values of suction parameter. This is effect of absorption and generation of parameter on suction. Here we observe that concentration decreasing positive values and increasing positive value suction parameter concentration. This is effect of Schmidt number on concentration. Concentration decreasing for increasing of Schmidt number. This is effect of chemical reaction parameter on concentration. In the decreasing of this figure, effect of Soret number on concentration. In this figure shows concentration is increased in Soret number. This figure effect of suction parameter on concentration is that concentration decreasing for increased suction parameter. These are tables, sir. Primary velocity, primary velocity profiles increasing with an increasing in gross of conclusions, modified gross of number, whereas reverse observed in case of magnetic parameter. Primary velocity increases values of porous medium and whereas secondary velocity shows reverse turn. primary velocity decreases and secondary velocity increase parameter. Boundary layers increase in Prandtl number and heat source parameter. Concentration boundary layer increases in the presence of Soret number. Thank you, sir. Thank you. Thank you. This opportunity, please.
Thank
Thank you.
Dr.
Thank you, sir.
Reddy.
Okay. Thank you, madam. Thank you, madam.
Can you give your affiliation, please? Which institution are you from?
Andhra Pradesh, madam.
Which institute?
Hello.
Which institute do you belong
Mekapat
to?
Rajamohan Reddy Engineering College, madam. Mekapat
You are a faculty there.
You go to the first slide.
He has not given the first slide at all. That's why I'm asking.
Not clear.
Just give the title and proceeded. He did not give the affiliation there. That's
Okay.
why I'm asking.
Madam.
That's why. Okay.
Okay, madam. Okay, thank you,
Are you
madam. Thank
faculty
you,
member
madam.
there or?
You are a faculty member?
Yes, sir. Yes, sir. Yes, sir.
See, it's customary to put your name and your affiliation institution in the first slide, okay? So that we know.
Okay, next, madam. Thank you, madam.
Okay, thank you.
Okay,
And
okay.
just one suggestion, you have
Okay,
assessed the various parametric values towards the primary and secondary flow, and several
madam.
graphs you have given. Okay, you should also
Yes,
justify why
madam.
it is increasing, why it is decreasing with respect to certain parameters. Just rather than saying that is increasing, this is increasing, that is increasing, this is increasing. With, say, if for example, if you take a Prandtl number or a Grashof number, why it happens? That will be more appealing. That is my suggestion. Okay.
Okay. Okay. Thank you, madam. Thank you, madam.
Thank you. So the last and the final call for Vinay Kumar, is he here?
Thank you, madam.
You can stop your presentation now. Is Vinay Kumar here? Okay, so with this we conclude this technical session 7, in which we had originally 11 paper presenters. Out of them, one expressed his inability to participate because of his ill health through his collaborator. And out of the remaining 10, 9 were present. Only Vinay Kumar is absent. So 9 persons have presented their research work. And I thank all the paper presenters who are present and stuck to their timings. So thank you very much. Thank you, sir. Thank you. Over to Professor Rao.
Over to first Vaidyanathan. Vaidyanathan is the rapporteur. Just
yes, sir.
take the formalities of extending the thanks both to chair and participants.
So, yeah. Yes. So it's not actually a formality. It is actually a big thank you for sparing your time. I know that
I believe formalities have certain purpose. The purpose is that the participants should know who is chairing and what about his or her related highlights, so that before people are in the impression that why should you are introducing much about the speakers. For them, not you I am answering. For them I am answering that before listening any significant person, it is not for praising that particular individual. It is for making reference a personality who is significant that has to be known by the listeners or participants. That is the very objective. So therefore, today it is not any, what we call it as any praising to Seshadri madam, Rajeshwari Seshadri madam. Really, when I am working from, I think, 2014 onwards, I am actively working with her. And I came to know that she is a very good resource person. And Pondicherry University is one of the notable professors. She will come under that category. Okay. So today it is happened. No, madam, it is not praising to any individual.
Thanks.
I don't like to praise anybody unless I have something in my heart. I won't speak. That is my tempo. Naturally, my tempo is like that. If once I convince to praise, nobody can stop me. Also, that is even that individual also cannot stop me. Okay. So what I'm speaking, that is the reality, madam. And very interestingly, this name coined Professor Rao School of Thought, I mean C.R. Rao School of Thought. And in that propagation, the speakers, particularly Rajeshwari Seshadri madam today, has given very good inputs, and I have a scope, or I have an idea that if we make some sort of research side contributions, there is a lot of scope. Let us do with our two departments, madam. Okay. So anyway, why the formalities I am following that? It is an occasion to just review our abilities. Sometimes we may not notice our strengths unless our neighbor has mentioned. This is the very purpose of making some introduction, madam. So what I observed today with our Vaidyanathan's reporting, you have done a very wonderful job of conducting the technical session, and in spite of your busy schedule, you have spared, particularly for ladies, and you have to play so many roles, domestic role.
Today is also Kartike Deepam.
Yeah, it is. Today is holy day, not holiday. It is a holy day, as well as domestically you are supposed to spare your time. Your family members expect your quality time with them. So in spite of that, you spared valuable time. Thank you very much, madam, for your nice participation and today morning session as well as technical session. Thank you very much. Thank you. Okay, now I can declare that we have 30 minutes more to, not 30 minutes, 5:30. Next session will be started up to 5:30. So now it is 4:30. We have a break of 1 hour for this session 1. I think parallel session 2 is going on. It may take up to 5:30. So because there are more speakers in that session. Now at that time we will meet again. Ganapati.
Yes, sir.
Ganapati.
Yes, sir. Yes, sir.
After that, we can stop the recording process.
Yeah, already stopped, sir.
Yeah, keep our banner as a display.
Okay, sir. Okay.
Okay. Thank you.
Thank you, sir.
Thank you, madam. Thank you.
Good evening, Malik sir.
Yeah, good evening, good evening.
Yes, sir. How are you, sir?
Yeah, fine, fine.
Good to see you.
Yes, how are you? Everything is going smoothly?
Yes, yes, sir. Everything going smoothly and fantastic way.
Very good, very good. So really a grand success for the conference.
Yes, sir. Yes, sir.
We observed.
Yes, sir. Yes, sir.
Yes, good, good.
Yeah. Good to see you, sir.
All of you made good efforts. Yeah. So the program will be starting, I think this is the last invited session.
Yes, sir. This is the last invited session of this virtual conference.
Yeah, yeah.
Yes, sir.
Okay. So where is Professor Tripit now?
Yes, sir. I am also waiting for him. If the Tirupati sir comes, then we can start these proceedings. Yeah.
Yeah, yeah, yeah. Good.
So continuously, his efforts are being visible here like this. We are all doing to the maximum best of our things.
Yeah, yes, definitely. You all are making good efforts to carry out this conference.
Yes, yes.
Really.
No, especially
appreciable efforts.
main efforts are of Professor Tirupati Rao bringing many people across the world.
Yeah, yeah, he's a very dedicated. He's a very dedicated person, dynamic person.
Yeah.
Always take interest to carry out such things.
Exactly, exactly.
Yeah.
So good evening, sir. Tirupati Rao, sir. Sir, unmute, please. Sir, still not audible. Unmute, please.
Welcome, sir. Welcome. Welcome, Vishnu. Welcome, Malik sir.
Yes, sir. Good evening.
Thank you. Thank you. Good evening.
Very good evening, sir. Very good evening.
Yeah.
Just now, the second session is completed within, 5:20.
Oh, very
5:20.
Very great efforts. Great efforts.
And luckily, 4:30, 4:40, I think 4:45 is the first session. but it is up to 5:20. It is second session. Today is the last session, and sir, I need your help. We have a plan to identify the best paper presentations as well best talks. So my students will split all the total video into pieces, and that will be sent to the adjudication. And we have to decide two best presentations among technical sessions, two best speakers among invited sessions, and already 3 prizes were already arrived for quiz competition. For all these things, it is tentatively planned that December 12th is the valedictory function. We are like September 10th, we have a valedictory. It is tentatively proposed. But meantime, I wrote a mail to daughter of Professor C.R. Rao. So if C.R. Rao's health and other conditions permits, and sir agrees, then virtual award presentation might be given by C.R. Rao. That is what our plan.
Wonderful,
Okay.
wonderful, great, great.
If that is the case, then a date will be extended. Depends on her mail.
Availability and suitability.
Otherwise, we will do it on 12th December, sir, valedictory exclusively. So in that, there are some speakers which were not allowed this time. That 1 or 2 speakers. Along with that, we have a praise and award distribution celebrations. Okay, Vishnu, shall we start?
Yes, sir. I'm waiting for you.
Oh, okay.
Yeah.
So I think you have every material with you.
Yes, sir. Yes, sir. Hisham has sent me.
Okay.
I have kept it ready. So, shall we proceed, sir?
Speakers are this
Yeah,
time.
speakers are R.K. Bharadwaj, Bindu Krishnan.
Yeah, Vishnu, what we are going to do is that in the morning session, we have given the last priority to the assistant professor category. Okay.
Oh.
1 or 2 people are in the morning session. Therefore, but this time, T.S. Raghavan has asked me that it has to be in the daytime of Illinois. Illinois State University at Chicago. He is in Chicago.
Yes, sir. Yes, sir.
Therefore, his time will be 9 o'clock if our time is 8:30. Okay.
Okay.
So that is the reason why we made his talk is in the last but one. And Suresh also is made in the talk.
Sure.
So they will be the last speakers. The most eminent is in the last. It was placed.
Yeah, fine. So we can conclude the proceedings with eminent speakers.
Yeah, that is what I want to say. I want to say. Now you can start.
Okay, thank you, thank you. So, welcome all. So this is the last invited session of this virtual conference, invited session 8. So as already mentioned by the general chair and all the organizing thing, that all the invited speakers will get 30 minutes of time for presenting their deliberations, presenting their content. And we have around 8 speakers in this invited session. So hope R.K. Bharadwaj is present now. R.K. Bharadwaj is present now.
Just a moment.
No, sir, he's not there. I checked it.
Let us know who present now.
Yeah, then Bindu Krishnan, Dr. Bindu Krishnan is present as of now.
Yes, sir. Yes, sir. Good evening, sir.
Yes, madam. Good evening. Good evening.
Yeah.
Yeah.
Good evening, sir.
So, welcome to this virtual conference.
Just ensure with the others also, if anybody.
Yes, sir. Yes, sir. Yes, sir.
They will join.
Izhar Khan. Sridevi. Dr. Sridevi, EP.
They were given detailed timings, therefore they may come at that time.
They may join at
at their time. Yes,
okay, sir. So we can start.
So let us start with the available speakers.
Yes, sir. Yes, sir. Then fine. we can go with Dr. Bindu Krishnan.
Yes, sir. Sure, sir.
Hello,
Madam,
sir.
please turn on the video. Yeah, thank you, thank you.
Sir, sir, Bharadwaj has come, sir. Like Bharadwaj sir has come, sir.
Bharadwaj came, it seems.
Wait a minute, madam. We will just
Okay, sure,
make
sure.
1 or
No
2
issues,
minutes
no
to
issues. Okay, sir.
make
Okay,
it. Bharadwaj, where it is?
Just
Where
now he
is-
joined. Yeah, just now he joined. Yeah.
Yeah, now he got Rohtash. Yes.
Rohtash Kumar Bharadwaj. Yeah.
Yeah, good
Dr.
morning, all of
Bharadwaj.
you.
Yeah,
Yes,
good
good
evening,
morning,
Dr.
sir.
Bharadwaj.
Yeah. Good evening. Good evening.
Welcome, Bharadwaj. Welcome.
Yeah, thank you, sir. Thank you.
Yeah. So we're just waiting for you. Okay.
So, Bharadwaj, as informed, you will be having 30 minutes of your time for presenting
Yeah,
your talk. Okay. So, welcome again. You can share your screen and start the presentation.
No, Vishnu. You just introduce the speakers.
Yes. I have to do that. Before that, I have to do that. 1 second.
Yeah.
Hope my screen is visible.
Yeah, it's coming.
So, I'm very happy to introduce Dr. R.K. Bharadwaj, who is currently working as Assistant Professor in Department of Statistics, Punjabi University, Patiala. And today is going to deliver his talk on concerns and claims about improving the system reliability and performance. So before he presents, let me give his brief profile. Dr. Bharadwaj presently working as Assistant Professor in Department of Statistics, Punjabi University, Patiala. Prior to this, he served in DC, Gurgaon.
Rohtak, Bharadwaj, you stop your presentation. Bharadwaj.
Okay, sir. Just time.
You stop your presentation.
Okay. Stop.
Okay. So still my screen is visible, right? In a full screen?
Now you have to select again, Vishnu.
Okay, sir. I'll do that.
You have to do again.
Okay, sir. I'll do that.
Sir, Vishnu, sir. Please stop sharing and 1 second you share, sir.
Okay.
Yeah. Wait.
Hope my screen is visible now, right?
Yeah.
Okay. He received doctorate in statistics from MD University in the year 2007, and he has been engaged in various research assignments and consultancies. He has worked as a principal investigator for a major research project funded by Government of India. Many of his papers have been published in research journals of national and international repute. He is actively associated with known national and international academic bodies and researchers working in different areas of statistics. His expertise includes stochastic models, reliability theory, failure impact analysis, and high-dimensional data synthesis. So, with this brief introduction, I welcome you, Dr. Bharadwaj. I welcome you, Dr. Bharadwaj, to make your talk.
Okay, thank you, sir. Thank you very much. Okay, please let me know, sir. Screen is visible?
Not yet. I will. Yeah, now it is visible. We can put it in a full screen mode, full presentation mode.
Okay, should I start now, sir?
Put it to slides now.
Make it in a slideshow mode, sir. Make it in a slideshow mode.
Okay, actually it is not possible to make in the slideshow mode actually.
It's possible. You select
You can go to slideshow option. Slideshow in the ribbon, in the menu.
In the taskbar, yeah.
Actually, the device I am using is not supporting
next to two animations. Next to two animations, there is a slideshow.
Okay, actually the device I'm using is not supporting for that actually. Is it not clearly visible?
No, sir, not clearly visible. That's what.
Okay, just a minute. I'm trying.
You can press F5, sir. Function F5. If you're in laptop, you can press F5 function key.
I think it's okay, no problem. Some extent better.
Okay, good evening, all of you. First of all, I'm extremely sorry that I could join a little bit late. This could happen because of I have to leave my station because of some unavoidable reasons. So I'm extremely sorry for getting late. First of all, I'm very thankful to Professor Tripati Rao, who arranged such a beautiful platform for all of us and to share our views. Thank you, sir. Thank you very much. And above all, I'm very extremely thankful to my mentor, Professor S.C. Malik, and luckily he is present right now. I am very thankful that he introduced me to this field. So today's the title of my talk is Some Concerns and Claims About Improving the System Reliability and Performance. Through this talk, I would like to share some of views on the reliability aspects of the product, starting from its initial phase, from the designing, and after that in the life period, and in the last some maintenance and all those things. I will try to discuss the managerial aspect as well as some engineering aspect, and in the last I will try to summarize my talk by telling some importance of the statistician, what we have to do to improve the reliability of some of the systems and the products. So almost every day we listen of another company that has failed. In the new millennium, this rate of failure will increase. Competitors are rapidly entering the marketplace using technology, innovations, and reliability as their weapons to gain market share. This is the current scenario. Some another changes pattern that we are observing in these days are the profit margins are shrinking. Yes, of course, the profit margins are shrinking. Internet shopping challenges the conventional business model. The information highway is changing the way consumers make buying decisions. Consumers have more resources available for product information, bringing them new awareness about product reliability. There are some benefits of these changes are also, these changes have made it easier to consumers to choose the best product for their individual needs. The information age actually allows today's consumers to research an entire market efficiently at any time and with some little efforts. Also, the conventional shopping is being replaced by the smart shopping. All of us are observing these things in the present time as well. And a big part of smart shopping is getting the best product for the best prices. So what are the lessons to learn from these kinds of changing scenario? The consumer electronics, the list of manufacturers who make high quality product is continuously evolving. Actually, the manufacturers who didn't participate in the quality revolution of the last 2 decades were replaced by those that did that. They went out of the business because why? Because the companies with high quality systems were producing products at a lower cost. Also today, consumers demand products that not only meet their individual needs, but also meet these needs over time. Quality over time, actually the reliability is becoming the requirement in the 21st century. This is fact. So in today's marketplace, product quality is necessary in order to stay in the business. And in tomorrow marketplace, reliability will be the norm. This is the fact. In simplest terms, we can state about the quality and reliability, where the quality is conformation to the specifications, but the reliability is one step ahead. It is actually the conformance to specifications over the time. So the reliability is continuous sort of quality over the time, we know very well. So the quality revolution is not over yet. It is just evolved into the reliability revolution in these times. So the fact is, the manufacturers who have no reliability engineering in place typically have very high warranty cost. A company that implement reliability in their process can diminish warranty cost to lowest. This is the fact, and this fact addresses the main benefit from a reliability program. There are many benefits that are gained by improving product reliability. Some of them are, for example, the better product image, reduced time to the market, lower risk of product recall and engineering change, and more efficient utilization of employee resources. So we can say in general terms that there are many concerns and claims about the reliability improvement of, or indeed various challenges and the remedied as well that need to be addressed. And today I will try to discuss some of these concerns, claims, and the remedies as well. Actually, reliability is a matter of survival. Anybody is in the market, if he don't care about the reliability of their product, they cannot survive. So reliability, in broad sense, can be taken as the matter of survival. There are various factors and the aspects that can be covered under this heading. Some among them are the competing in the 21st century. So what it means actually, first, understanding the competition in the 21st century. I'm giving one real example from automobile sector in the USA. What happened over there? The major car manufacturer in the USA, they saw that their dominance eroded by the Japanese automobile manufacturers. This was happened in 1970s. Why? Because the vehicles produced by the US company are significantly more problematic in comparison to the Japanese manufacturers. The slow downward market slide of the US automobile industry was predictable. When the effect rate of US automobile is compared with the Japanese automobile companies, industries, much has been written about how this is happening and how the US manufacturer began implementing the TQM techniques, continuing improvement, and concurrent engineering to improve this product. Now we know the US automobile industry produce quality vehicles, and the perception that Japanese vehicles are better has eroded significantly. This is given by the report by J.D. Powers published in 1997. Another perspective associated with this scenario is the warranty period perspective. In the 90s, automobile manufacturers were offering 3 years warranty or 36,000 miles. Bumper to bumper warranties came into play at that time. After that, in 2000, these same automobile manufacturers, they come up with 7 years or 1 lakh mile warranties. Now the Jaguar is advertising 7 years or 1 lakh mile warranty on its used vehicle as well. Same scenario, same is the case with the BMW vehicles. So the reason these manufacturers can offer long warranty period is why? Because they could understand why and how their vehicles are failing and can therefore produce more reliable vehicles. So the improvement by these US automobile manufacturer did not occur overnight. It was the result of commitment to provide the necessary resources along with a credible plan for producing the reliable vehicles. So it was a paradigm change that took years and evolved through many steps actually. So now I would try to discuss some of the aspects related to this fact. The first is, as I cited earlier, the competing in the 21st century that can be discussed with the following heads. First is the gaining competitive advantage. Second is the competing in the next decade. Third is the concurrent engineering. Fourth is the time to market advantage. And 5 is accelerating product development. So I will try to discuss all these aspects right now. So first is the gaining competitive advantage actually. The companies successfully competing in the 21st century will have a common thread. They will all produce quality products that meet or expected customer expectations over the time. In some industries, technologies moves so fast that customers tend to trade up to the next generation product before it stops performing to specifications. This may seem like the ideal environment for a manufacturer because the product life expectations of the consumer are shorter. However, in reality, achieving product reliability with decreasing product development time require a change in the way we develop products. Of course, this is highly dependent on the product complexity, regulatory, and safety requirements. But the trend cannot be ignored. Actually, the companies pay a heavy price for releasing a product that is buggy or having some kind of deformities or some kind of defects or unreliable products. So satisfied customers are actually the repeated customers. A faulty product usually results in the customer communicating satisfaction to anyone who will listen until the product or service is replaced with a more reliable one. So gaining competitive advantage is necessary for these kinds of giant companies that are working in the market to gain profit. This aspect is necessary to understand. If they could not understand these kinds of things, then there will be very difficult for them to make profit. Another is the competing in the next decade. Yeah, of course, the winners will compete on the part of reliability. This is the platform where there will be the tough competition among the the players in the markets. The business practices of the past few decades will not be sufficient to ensure success in 21st century. We all know this fact. So the consumers make buying decisions based on their perception. What is the perception of which products had better quality when the competing products were of the same approximate price actually? So in the past few decades, reliability was not a deciding factor for most consumers. I'm talking about some past few decades, not the current scenario. This is mostly the result of consumers' lack of knowledge about the product quality at that time. However, the average consumers in the 21st century right now will make buying decisions based on a price and quality, but also on perceived reliability of the product. So consumers make buying decisions based on which product offer the best value. So the product value can be defined simply by taking the ratio of the customer's perceived value divided by the price. Here actually the customer perceived value means it is related to the quality and reliability of the product. One of the key advantages of implementing reliability throughout the organization and at every phase of the product life, product value increase because of an improved customer perception of the value of the product and lower cost of production. This is essential fact that should be considered by these companies. Another is the concurrent engineering. Actually, an important ingredient for successful design and implementation of new technology into manufacturing involves the establishment of concurrent engineering practices. Concurrent engineering is what it is actually. It is a process used from design concept through product development and into manufacturing, in which cross-functional representative from all relevant departments provide input on key decisions. All collectively provide their input on the key decisions. So these decisions have a direct impact on the price, performance, quality, as well as the development time required for the product as well. And thereby they can improve their efficiency as well as the betterment of their product they can think about. However, the cross-functional teams they consisted of marketing decisions, test, and manufacturing. The team didn't include a separate representative for reliability. They lack in this aspect, since this was considered part of the design and test engineering responsibility. But that is not the best practices. The reliability expert must be there so that they can come up with the better product by implementing these concurrent engineering strategies. So this convention needs to be changed, and a more encompassing version of concurrent engineering developed that take into account the entire product life cycle. So the product life cycle approach actually includes the reliability, serviceability, and maintainability inputs that begins in the design concept phase and continue through the product development and product life phase. These are the necessary changes that should be focused. Simultaneously, these are the things that are putting challenges to these companies. So the testing performed at the prototype stage, where a statistician can help a lot in developing the model. It will validate product performance to specification prior to engineering release that is necessary. So this does not, however, consider the ability of every product produced to meet specification in manufacturing. So the problem with this approach is that decisions are continuously made in product development that have significant impact on the product performance. So the reliability and ease with which the product can be serviced and maintained. So at this very stage, the decision need to be made very fast. They include input from everyone affected, and that must include some reliability professionals, so that the reliability aspects can be judged and can be stated in advance. That is very much required for such companies. Another is time to market advantage. This is also another important aspect that need to be discussed here. Actually, over the driving forces affecting the product reliability is in greatly reducing the product development cycle that organizations are facing right now. Coincidentally, this is also the biggest reason a product cannot undergo the additional activity required for the reliability. So when time to market goals are achieved, the benefit include product name recognition, their ability, set industry standards, recognition as a reader, expansion of the customer base, and also the maximization of the products. So using a product life cycle approach, product development time will be significantly reduced in such cases. So time to market advantage definitely will help in this aspect. Another component in this regard is the accelerating product development. So there are many ways to accelerate the development of a new product. There are numerous ways that can be studied and debated. Is concerned. So the product development can be accelerated by simplifying the product design, process improving communication between the cross-functional organizations, implementing an escalation process to resolve conflicts. That is very, very necessary, essentially required step. Eliminating unnecessary steps, maintaining development workload at no higher than some standard level. In some of the companies, it is implemented not more than 85% of the capacity. Parallel processing can be considered. Most importantly, actually eliminating the delays. These kinds of actions, if these kinds of strategies are implemented, then they can stop the delay, they can diminish the delay, and they can accelerate the product development process. So these are some of the aspects. Also simultaneously, it is the need of the time that we should also discuss some of the barriers to implement the reliability. There are also some barriers that can be discussed here, that should be discussed here. So now we will discuss one by one some of the barriers that put some obstacles in implementing the reliability strategies in some of the companies. So first is the lack of understanding. This is big problem and big barrier to implement the reliability plans in any industry. Lack of understanding. probably the greatest barrier to improvement reliability is the understanding of what reliability actually is. People could not understand actually what reliability is. So much of the resistance you will experience in implementing the reliability will come from individuals who believe that quality and reliability are the same thing. This is the confusion. But as we have shown before, they are not the same. They are not the same. Reliability is one step ahead. People are putting their efforts just concerning the quality, but over the period of time, they are lacking in this aspect. So quality, we know, is the conformance to specifications, where reliability is the quality over time. So the reliability from a customer perspective is that the product works the way it was supposed to work for its desired period of use. So before you start improving reliability, you must be aware of what you are improving. That must be understood to the company or the implementing personnel. So the study, what can be done in this regard? Here is the role of the statistician. The data play a vital role here. Study the data that you already have. First, gather the data from the manufacturing process and from field failure data. This can have immediate impact on lowering warranty cost. Problems that can be corrected by design take longer time. So very often the decision has to be made to apply your resources on new design rather than on the old current designs. After gathering the data and analyzing the information of the failure, corrections, and the related processes, there will be a better understanding of where to start the reliability improvement process. In most of the cases, this is the actual scenario. It will be apparent that there are both designs and process problems. So select from the data the low-hanging fruit and take corrective actions to make these easy problems. Of course, they can be disappears if such kind of data practices are used. Another is the internal barriers. The internal barriers will seem enormously at the beginning phase. Many companies find that a couple of years after they implemented their reliability program, the improvement they have made in product reliability are not significant. This is not significant. Actually, what is required there is the perseverance is necessary in times. You will be amazed at what happens within the organization once these barriers begin to break down. This is essential practice. So if I try to summarize some of the most common internal barrier, so these can be the resistance to the change. This is the common human nature. Another is the lack of knowledge, as I cited in the presentation, about the reliability in the management level as well. Lack of knowledge about the reliability in engineering as well. Inadequate training to the personnel that are engaged in such type of fields. Another is the problem of management that doesn't support the process. Another is the capital resources that there are support to the process. No adequate staff in some of the companies is also the problem. That is again some management issue. Goals not well defined or set arbitrarily. Another management issue is there. And importantly, adequate time not to put the schedule to fix the problems. This is the common practice. Another is the attitude that it won't work for us. This is the common human, the nature. So these are some of the internal barriers that these companies or the enterprise or any system developer that is running the system developer as well, they are facing such type of barriers. So implementing change and change agents, these are also another, the barrier in the reliability implementation. If you are building quality product that do not meet the test of the time, you have a reliability problem. This is the message that we need to drive into the organization. The way we are doing business today will no longer work in the tomorrow competitive environment. We must think about it. So there are actually two necessary requirements that are needed to deliver the knowledge of the process. The first requirement is to have the charismatic leader or a champion who is highly knowledgeable about the process and is a good communicator of what is needed, what can be done, what appropriate personals or the things or the materials should be needed, so that the statisticians, the reliability practitioners can be put in proper place and they can develop the simulated models well on time and things can be corrected. So the second requirement is that the management need to support the necessary change required to implement the new process. So both these requirements are necessary ingredient for the success of any plan. Otherwise, they put some, the kind of obstacles or the barriers to the implementation of the reliability. Another is the building the credibility as well. This is also the necessary ingredient in the implementation process, establishing the internal knowledge. So this is another important aspect, the point of credibility. Another is the perceived external barriers. Perceived external barriers, these are also the things that should be considered. Various types of barriers are there. There are many perceived external barriers are also there, facing some companies that want to implement the reliability. Some of them are for the time to market. Some actually these are most of these barriers, they are related to the management personnel or management point of view. So no local test facilities are there. Local yeah, I'm just concluding.
Sorry for interrupting. Could you please conclude your things, please?
Yeah, I'm just taking 2 minutes, sir.
Okay, fine. Right. Yeah, thank you.
Yeah, just within 2 minutes. So actually take time to gain acceptance in the market. So perseverance and the patience is necessary. So there are many other things. Reliability in the 21st century is the totally paradigm shift actually. So here today we hear from all of our colleagues. Also from our personal experience, we know that the rules are different at different places and different installations. With companies that takeovers, buyouts, merge, and downsizing, it is becoming clear that the old rules no longer hold up, because the reliability, along with the quality, reliability strategies are needed to be implemented so that we can get better results. So actually here this world is changing and companies have to change to stay in the business, in the market. Today's mergers have to adapt their companies to these new paradigms. It becomes very difficult for them to stay in the competitive markets. Also, we have reliability toolbox. Various kinds of tools are there that can be implemented to study. This is the statistical parts from here, the failure mode and effect analysis process. We can use these kinds of process. This is the HALT process, accelerated test design, identify field failures before the first product is shipped. So the highly accelerated testing plans can be there. Also, the screening plans can be there. So now the concluding remark in this talk, actually, I will read some of the main important points here. The modern engineering products from individual companies, the components to large systems, individual components to the large system must be designed and manufactured to be reliable in use. The manufacturing process must be performed correctly and with the minimum of variation. All of these aspects impact upon the cost of design, development, manufacturing, and use, or as they are often called, the product life cycle cost. So the challenge of modern competitive engineering is to ensure that life cycle costs are minimized, simultaneously achieving the requirements for performance and the time to market as well. So if the market for the product is competitive, improved quality and reliability can generate very strong competitive advantage. Finally, the prevailing conditions are not all deterministic. We all know very well, most of the things are uncertain. In a company, in a manufacturing giant company, there are so many things that cannot be deterministically predict in advance. So therefore, the role of statistician become prominent here. Starting from the developing the initial model, by incorporating all the uncertainties to final testing and implementing at the final product phase. These kinds of targets can be achieved if we utilize the expertise of an expert statistician who can develop the models concerning the prevailing uncertainties in the working environment. So a statistician can provide a practical resource of development for these strategies, covering all aspects of quality and reliability, engineering and management as well, related to present and future conditions. This is necessary. So these are some of the references of this talk. Now, thank you. This was all about from my side. If there is any suggestion or discussion, then
yes,
all
sir.
of you
Doctor,
are
thank you so much, Dr. Bharadwaj, for your insights on the concerns on the reliability, quality improvement. And yes, definitely changing dynamics are essential in this changing environment. Okay, so I will allow one quick question or a kind of a clarification to Dr. Bharadwaj, please.
Quantify the barriers, sir. Any way to quantify the barriers for reliability?
Quantify the barriers?
Is it only qualitative or can it be quantified so that it can be controlled?
Yes. You are
these
right.
are all market-oriented reactions. How can we quantify these things so that controlling can be exercised in the reliability?
Yes, sir, you are very right. Most of the barriers, as you said, that these are of qualitative natures. Of course, because these are the, the consumers' perspectives and the persons who are engaged and working in the industries, even the professionals, their attitude-related problems are there. And it is not very easy to quantify such kind of things or the perspectives or the behavior. But being a statisticians, we can utilize different elementary or simple techniques. We can, go with some studies. Even we can analyze the qualitative data. So that kind of things can be needed here. And most of the things need to be corrected in these cases are the managerial part. They have to focus. The role of a statistician is to deal and play with the numbers and the data. If the qualitative data is there, even then the statistician need to help the managers and the persons who are running these companies, and they are coming out with different types of products. So I think I could able to.
Yeah, thank you.
Yes, Bharadwaj, you have correctly pointed out that there is a need of management view on application of reliability theory. So all your concerns are mostly addressed with the customer point of view, seller point of view, entrepreneur point of view, quality point of view. There are many points that you have considered as concerns. Yes, it's a correct term. That is a managerial point of view using reliability quality like TQM. Total quality management, we are using the quality control aspects. Like that the reliability applications in management is maybe the concern. Total your summary of the talk is mostly concentrated on it. So basically it appears like qualitative, but any qualitative conclusion is a research problem. It has to be substantial evidence, statistical evidence. Definitely that Lakshman Rao's concerns is addressed with the statistical evidence. That is
sir, can Likert scaling can help in some way? Likert scaling.
Many tools, sir. There are many tools we can
to convert a qualitative into a quantitative methods. This is a very interesting situation.
Yes, sir. Thank you. Thank you for the interaction. Okay. Sir, Dr. Bharadwaj, can you stop?
Stop sharing.
Can you stop presenting? Yeah, stop presenting.
Yes, sure, sir. Sure.
Thank you. Thank you.
Okay. Thank you, sir. Thank you, all of you. Thank you, please.
Right. So we'll move to next invited speaker, Dr. Bindu Krishnan.
Yes, sir.
Good evening, madam. Welcome to this
Good evening.
event. So before you start your presentation, let me give you a brief profile of yours to the gathering.
Okay.
Yes. Hope the screen is visible now. Yeah. So Dr. Bindu Krishnan, presently heading the Department of Data Science, Jain University, Kochi, Kerala. Now, today she is with her to present her insights on some aspects of a heavy-tailed distribution. So, Dr. Bindu Krishnan is a doctorate holder in statistics with more than 20 years of experience in academics. She is currently working as Associate Professor and Head of Department of Data Science, Jain University, Kochi, Kerala. Prior to this, she served as Head of the Department of Data Analytics and also as Assistant Professor in various institutions. She had achieved her PhD in statistics from Bharatiya University, a study on certain heavy-tailed distributions and their applications in time series modeling. And her master's degree in statistics is from Cochin University of Science and Technology, and she has a few more master's degrees like Master of Technology in Computer Science and Engineering, Data Science and Artificial Intelligence, also from Cochin University of Science and Technology. She had published a book entitled Probability Distributions, Random Processes and Numerical Methods under Wiley Publications, and also published several research articles in reputed national and international indexed journals, including SCI, Web of Science, and Scopus journals. She had delivered a number of invited sessions as well as hands-on sessions, particularly in the field of machine learning, data science, artificial intelligence, using various programming languages. She is an expert in statistical softwares like R programming, SAS, Python, Tableau, Mathematica, MathCAD, Minitab, and SPSS. Her broad areas of research interest includes distribution theory, time series modeling, data science, and machine learning. So, Madam, we welcome you for this virtual conference, and kindly start your talk, and talk will be for 30 minutes. Thank you.
Thank you, sir. Thank you, sir. Is it visible, sir?
Not yet. Yes, now. Now. Is it PowerPoint or PDF, madam?
Is it okay, sir? Yes, sir. Yeah, PDF, sir. PDF.
Now it is visible. Thank you. Yeah, you can start. You can start.
Okay, sir. Okay, sir. Thank you, sir. Respected dignitaries. So first of all, I thank Dr. Tirupati Rao sir and team for the opportunity given here in delivering this talk. My title of this talk is on some aspects of new heavy tail distribution. This is the brief talk.
When this department was started, madam? Data science department? Hello?
Yes, sir.
You have exclusive department of data science? This is Tirupati Rao.
Yes, sir.
Department of Data Science exclusive department is there. Good. Very good. Carry on.
Yes, sir. Definitely, sir.
Yes. Carry on.
2 years. Yeah. 2 years. Yes. A number of probability distributions are used for model data for M-states. The concept detailed distributions of finance, economics, environmental science, etc. Then engineering, insurance, etc. and so on. And this class of distribution has found many real applications analyzing extreme values. So heavy tails are actually characteristics of a phenomena where probability of extreme values are relatively very large. So a distribution is said to have heavy tails when the decay of probability density function is low. When the thickness of tail is measured by the tail index, the order of highest absolute moments, which is finite, or the index, the heavier the tails. So the definition of heavy tails actually it is based on the theory of regular variation highlights importance index, which indicates the existence of moments and characterizes the rate at which the tail decays. Or roughly speaking, regularly varying functions, those functions which behave like power functions at infinity. And heavy tail distributions are actually probability distributions, simply saying whose tails are not exponentially bounded and are characterized by heavier tails than exponential distribution. The most popular heavy tail distributions are Pareto distribution, Weibull distribution, Laplace distribution, Cauchy, log normal, and so on. We can express this heavy tail condition for heavy tail distribution as given by equation number 1. So the distribution is said to be have a heavy tail if the tail probability than x greater than x, that is the survival function, decays more slowly than those of exponential distribution, which is given by either equation 1 or another form is given by equation number 2. Or in other words, we can say the distribution has fat tail if it satisfies the equation number 3, where tau is called the tail index. So this is a brief review of literature for heavy tail distributions. Actually, this presence of heavy tails are first recorded in 1932 by SIP. And in continuation of that, so many works are there, especially based on the applications of heavy tail distributions. And in 2016, Hassan reviewed all the applications of heavy tail distributions in various contexts. And in 2020, Jayakumar, myself, and Kutty Krishnan introduced a heavy tailed Pareto distribution whose tails are more heavier than Pareto distribution. Actually, Pareto distribution is the most important heavy tail distribution. So in this paper actually we have introduced a distribution whose tails are heavier than Pareto distribution. So here also I'll be focusing on a new generalization of Pareto distribution, which satisfies more properties of heavy tail distributions. And of course, we proved that this distribution has a very competitive model compared to some other generalization of distribution. So since it is a generalization of Pareto distribution, I'm here starting with Pareto distribution, basics of Pareto distribution. Actually, this work is a combined work with Dr. K. Jayakumar from University of Calicut and Hamadani. Okay. So this is a brief review of literature for some generalizations of Pareto distribution. Only generalizations I have included in literature review because here I am focusing only a new generalization of Pareto distribution, which is again a new heavy tail distribution. Injection to Pareto model called generalized Pareto was introduced by Pickens in 1975. Then Stoppa in 1990 introduced another generalization known as exponential Pareto. Then Nataraj introduced exponential Pareto 1. Akinseti et al. Introduced the beta G class of distributions. Then Mahmoudi 2011 applied beta generalized Pareto distribution. C et al. Defined beta exponential Pareto distribution, and so on. So many generalizations of Pareto distributions are there in literature, and I have included only a few. Now, this is actually the genesis of our distribution. So Nataraj, Jayakumar, and Rustic in 2013 introduced a family of lifetime model distribution using truncated negative binomial random variable whose survival function is given by equation number 6. And this family can be interpreted like this. If we consider, suppose we consider a failure time of a device. let us observe a failure time of a device, and every time a failure occurs, the device is repaired to resume function. And assume that the device is deemed no longer usable when the failure occurs at a certain level of severity. If x1, x2, etc. denote the failure times, and if n be the number of failures, then the minimum of x1, x2, etc. xn represent the time to the first failure of the device, and maximum represent the lifetime of the device. So the above equation could be used to model both the time to failure and the lifetime. So this is a brief review of literature for this corresponding distribution. Jayakumar and Shankaran 2016 introduced uniform truncated negative binomial distribution. Babu 2016 introduced Weeble truncated. Kamal et al. 2016 studied the properties of uniform truncated distribution. Jayakumar and Shankaran 2017 introduced generalized exponential truncated distribution. And myself and George 2019 introduced Marshall-Olkin-Weeble truncated negative binomial distribution and its applications. Focus on the new work. So using the approach by Nataraj, Jayakumar and Rusting in 2017, actually, Jayakumar and Shankaran 2016 introduced a generalized uniform distribution with PDF given by equation number 7. And we know that a uniform random variable can be transformed to a Pareto random variable through the transformation x equals beta by y power 1 by alpha. So by using this transformation, where y has the PDF equation number 7, and here we obtained a new distribution known as new generalized Pareto distribution with 4 parameters alpha, beta, gamma, and theta. The PDF cumulative distribution function and survival function of the new distribution and given by equations 8, 9, and 10 respectively. This is the shape of PDF of this new distribution, the shape of CDF. Now, it's very obvious that when theta equals 1 and gamma tends to 1, since I took the gamma tends to 1 because in the denominator 1 minus gamma power theta. So, of course, while applying that, either L'Hospital's rule or some other methods in limit. So, when gamma tends to 1, so this new distribution reduces the classical Pareto distribution. And it is also clear that the limit of this distribution when x becomes infinity is 0, and when x becomes beta, this tends to equation number 11. Now, so this is the main focus of my talk, heavy tail properties. So the importance of this new distribution compared to other distributions. One of the important distribution property, one of the important property, this important thing which this distribution satisfies is that this new generalized Pareto distribution satisfies many heavy-tailed properties in literature. We showed that it is very easy to show that limit condition for heavy-tailed distribution, that is limit x tends to infinity, e power sx into f bar x is infinity, which is the first thing to prove our distribution as a heavy-tailed distribution. So then, now come to the property of regularly varying tails. A function L is said to be regularly varying at infinity if for every t greater than 0, equation 12 is satisfied. So the following theorem actually proves that the survival function of this new generalized Pareto distribution is a function with regularly varying tails, which is one of the important property of heavy tail distribution. Next one is, if we have a set of x1, x2, etc. and x are IID random variables with a common survival function given by our survival function, and if we take the sum of these random variables, then probability that Sn greater than x is similar to n into probability that x greater than x. And hence, if Vn equals maximum of xi, then probability that Sn greater than x is similar to n into probability that x greater than x, which is again probability similar to probability that Vn greater than x, which implies that for large x, the event Sn greater than x is due to the event that Bn greater than x. So exceedances of high threshold by this sum Sn are due to the exceedances of threshold by largest value in the sample, which is again another important property of heavy tail distribution satisfied by this new generalized Pareto distribution. Now these are the expressions for hazard rate function and reverse hazard rate function. And from this curve, from the curve of hazard rate function, it is very clear that it shows increasing and decreasing nature. So it is used to model data sets having decreasing failure rate and increasing failure rate character. Now come to the heavy tail properties related to this hazard function. So another important heavy tail property is a distribution, class L property. A distribution F belongs to a class L if limit f bar x minus y divided by f bar x is 1. And here a distribution F belongs to a if and only if, of course, this is another condition of limit, another condition for this class L property. And for details, refer Kluppelberg 1988. And here the new generalized Pareto distribution belongs to the class L property, which means that this shows, so this also satisfies this important property of heavy tails. Now the next property which satisfies this NGP distribution is class D of dominated distribution, where the definition is given here. And here, if alpha is finite, then NGP distribution belongs to the class D of dominated variation distribution, where the definition of dominated variation is given above. Of heavy tails distribution satisfied by NGP distribution is the NGP distribution belongs to the class of sub-exponential distribution. Sub-exponential distribution, the condition is limit of 1 minus f star of x by 1 minus fx is 2, where star denotes the convolution operator. But this is also an important property of heavy tail distribution, and it is satisfied by this new generalized Pareto distribution. Now the last property, the NGP distribution and classical Pareto distribution are tail equivalent. That means limit of f bar x by g bar x is c, where c lies between 0 and infinity. Moments are given by equation 16. From this we can find the mean and variance. So of course this is expressed in terms of hypergeometric function. So that is why I have tabulated certain values for mean and variance for different values of the parameters alpha, beta, gamma, and theta. Now the expressions for the random number generation we can easily simulate using this equation number 20. Then the expressions for median, mode, quantile functions. Then of course entropy is a measure of measure of variation or uncertainty of a random variable. The expressions for Renyi entropy and Shannon entropy are given by equations 24 and 25. Now come to the characterizations. Here actually we focused on mainly on 3 characterizations, where 3 characterizations satisfied by NGP distribution, new generalized Pareto distribution, and which is given by the following theorems and some propositions also. And 3 characterizations which we focused are a symbol relation are based on a symbol relationship between 2 truncated moments, a hazard based on characterization based on hazard function, then characterization based on reverse hazard function. So the first word, the characterization based on 2 truncated moments employs a theorem of Glansell in 1987 given by the this theorem. And this result actually holds when the interval H is not closed, since the condition is on interior of H. So due to time limitation, I am not going to read this. Sorry. Okay. So 3 characterization. So this is also the continuation of this first characterization based on truncated moments. And this proposition is also obtained based on the characterization on truncated moments. So in continuation of that, the characterization based on hazard rate function and based on reverse hazard rate function are given here. Now the expressions, first we start with the PDF of ith order statistic given by equation 30. Hence the PDF of largest order statistics and smallest order statistics are obtained as equation number 31 and 32. Now the estimation of parameters, only one estimation is included here, but we have further worked on other estimation, Bayesian estimation also. Here I have included only the estimation based on moment maximal likelihood estimation. Sorry. So by equating this to 0, of course, so iterative methods are this can be solved only by analytic, cannot be solved analytically, and softwares are used to solve by means of iterative techniques. And shared simulation study is also conducted to measure the performance of maximal likelihood estimation using Monte Carlo simulation, and simulated values are also mentioned here, some simulated values, and it is conducted for sample sizes of 50, 100, 500 and 1000, and it is repeated 5000 times. Analysis part. So the data, this is one of the common data for for generalizations of Pareto distribution. So for comparison purposes, that is why we have focused on this distribution, but in the we have included more data analysis. So here the data corresponds to the 72 exceedances for the years rounded to 1 decimal places statistics, and this is a histogram with the fitted PDF and empirical CDF with the fitted PDF, and we have compared with for goodness of fit criteria, we have compared with many generalizations of Pareto distribution, such as Kumarasamy Pareto distribution, beta Pareto distribution, transmuted Pareto, exponentiated Pareto, and classical Pareto distribution. So while comparing all these distributions, for if compared to all these distribution, the value of -2 log, Kolmogorov-Smirnov statistic, AC, BAC, ACC, all those things are smaller for our new generalized Pareto distribution, which proves that this is a competitive model or superior to other distributions or other generalizations of Pareto distribution. So since that survival function, we have focused mainly on survival function. That is why we have approached the case of minification process. But to derive the minification process, first we need to define the Marshall-Olkin form of this new distribution given by equation number 38. Then we model the time series model as well as autoregressive minification process given 39. So that's all. So the main conclusion is actually here we introduce a new generalized distribution which is superior to other new generalizations of Pareto distribution, and more than that, this satisfies almost all heavy-tailed properties. That is the importance of this distribution, especially as far as regularly varying concept is considered. So these are the references. Thank you.
Thank you, madam. Thank you for your nice theoretical work. Okay, yeah.
Thank you,
so hope, including me, many of the gathering have enjoyed your presentation.
Sir, actually, I have stick on to that time management. That is why I have gone a little bit fast.
Yeah. Thank you for that cooperation. Yeah, thank you.
Especially, I avoid just reading explanation of theorems. I just avoided.
Yes, I was observing it. I was observing that.
Okay.
Yeah. Any one quick question, please?
Yeah, please.
Rajgopal, sir, please.
Yes, sir. Good evening, Dr. Bindu Krishna.
Yes, sir.
Have you attempted for the application of your new distribution, generalized Pareto?
Yes, sir. Yes, sir. I have showed one application regarding the exceedance of river data. I have showed that.
Fine.
Yeah, but not only that, in that published paper, actually, we have included more analysis.
Okay,
so here, actually, due to time limitation, yeah.
That's right.
Yes, sir.
I am particularly specifying about the application means in other fields of statistics like sampling theory, acceptance sampling, like that. Because we have derived a model using Pareto distribution because of its heavy tail.
Yeah.
Further extension to Pareto you have done. So I have just sent a message to you through LinkedIn after viewing you here. I will follow up you if possible. I will communicate you through WhatsApp or mail. Thank you.
Okay, sure. Thank you, sir. Thank you, sir.
Thank you, sir. Thank you, sir. Thank you. Madam, I have one quick question from my side.
Yeah,
if you allow
sir.
me, then I will. Yeah. So did you get the closed forms for the expressions, MLEs, or
yes,
what?
Yes, sir.
Okay.
Yeah.
Fine.
Only moments, except moments. Moments actually we have obtained as a hypergeometric function, but for all other things we have obtained that exact expression, closer form. Actually, I have used that Mathematica also for especially for integration, all those purposes. I have used Mathematica, and for all other data analysis, I have used R software.
Okay.
Because Mathematica it is easy to integrate functions, for getting expressions. So that is why I approached that software also.
Correct. Yeah, thank you.
Okay.
Right. So thank you, madam. We'll move to the next
Thank you, sir.
speaker. So Rajagopal sir, could you please? Yeah, thank you. You did it. Yeah. We'll move to the next speaker. Our next speaker is Dr. MD Izhar Khan. Welcome, sir. Yeah. So welcome to this conference. So before you start your talk, let me introduce
Dr.
you.
Izhar Khan, you mute off your mic.
Okay.
No,
It is
yeah,
a mute
welcome.
mode only, sir.
Yes, okay, it's okay. Thank you. Yes, yes. Okay, okay.
You are right
Yes,
now with Medina, Islamic University of Medina from
yes, yes.
King Saudi
Kingdom
Arabia.
of Saudi Arabia.
Okay,
Yes,
good.
yes.
Thank you.
Okay, okay. Bismillahirrahmanirrahim. Should I start?
Wait.
Wait a minute, sir. Wait a minute. Just before that, I need to
Okay,
introduce
We
you.
will introduce you. Then.
Yes, okay.
Hope the screen is
Unable
visible
to-
now.
Yes, okay.
Yeah, it's visible.
So
Okay. Yes, okay. Just
yeah, brief profile.
yes, profile. This is the better profile. This
Yes,
is
yes, thank you,
Honorable
sir.
General Chair Professor T.R. Padi. And
No, I will do
this-
that, sir. Izhar ji, I will do that.
Okay.
I will do that.
Okay,
So
okay.
Dr. MD Izhar Khan currently working with the Department of Mathematics and is a Faculty of Science in Islamic University of Medina. And he pursued doctoral program from Aligarh Muslim University, and he was awarded in the year 2013. And his research areas are ordered random variates and distribution theory. Currently, he is working as assistant professor in the Department of Mathematics, Islamic University of Medina, Kingdom of Saudi Arabia. And he is a quite good reviewer of reputed journals like the Journal of Applied Probability and Statistics, Statistics and Applications and Probabilities, Pakistan Journal of Statistics and Operation Research, Journal of Statistics, Journal of Mathematica Slovakia, Applied Mathematics eNotes, Journal of MASA, Journal of Statistics Optimization and Information Computing, Journal of Statistic Applications and Probability and Letters. And he's also a member of many professional bodies like ISPS, Kerala Statistical Association, Indian Bayesian Society, then Indian Kerala Statistical, I think it is repeated now. Okay, apart from that, besides this, he has made several academic visits to foreign institutions, to Department of Statistics, University of Dhaka, a Department of Mathematics, Qura University, Makkah, Kingdom of Saudi Arabia, Department of Statistics, University of Colombo, Sri Lanka, Department of Statistics, Middle East Technical University, Ankara, Turkey. So his research track record is like this. So far, he has published 27 research publications and accepted 3, and has presented 13 papers in workshops and conferences, attended 8 conferences and attended 4 workshops. So far, he has completed 2 research projects and 1 is currently on. So with this short note on Dr. Izhar Khan, so I welcome you, sir, for your talk, please.
Thank you. Thank you, all of you.
Izhar Khan, welcome
Yes.
for this one. And right
Yes.
now, where you are in India or in Saudi?
No, doctor. Right now I am in Saudi Arabia and sitting in my office.
Okay, you are in.
So this is my office picture.
Today's
And we
one.
begin. Yes. This is my office picture.
Yeah.
Thank you all of you, Dr. Visnuranda, for introducing good about me. And I start this as Honorable General Chair, Professor T.R. Padi, and respected convener and organizing secretary and distinguished faculty members. A good evening, all of you. I feel immense good joining with all of you. Here I am. Before starting with the talk, I must pay thanks to the Dr. T.R. Padi for inviting me as the invited speaker. I am really thankful to you, sir, for this event. Now I'm going to present this one. It is visible, sir. You can see.
Not yet.
Okay.
Not yet.
Now is it?
No, sir.
Yeah, it's coming.
Yeah, now it has come.
Okay. Just.
So keep it in a slideshow, sir.
Yes. Keep in the slide. So thanks for your help. Here we are going to start. The first I'm going to start my the topic of this today talk, this lengthwise power hazard rate distribution, some properties and applications. As far as I concerned over this topic, here the two things I combine. The one is the lengthwise and another is power hazard rate distribution. Actually, the lengthwise is not the new thing. This is originated from its original distribution. It depends upon where we are going to take whether unequal probabilities or not. There are the many situations where we are facing to accepting the unequal probabilities for the experiment. Then this technique is using there the lengthwise, so-called this is the lengthwise power hazard rate distribution. Before what we present here, in this our talk.
Can you make it a slideshow? That will be, clarity will be there.
Okay, just
slideshow, sir, slideshow.
Just 1 minute, just 1 minute.
Come down in the.
Yes, okay, sir. I found.
Yeah.
Now this is okay. Okay. This is the whatever I did here. This is not okay.
Click on from beginning. Yeah. Click on the icon from beginning.
Okay. This is okay now.
No, you have to click on the icon from beginning on the top right corner, top left corner. Little left.
Okay,
yeah.
Just 1 minute.
We got it.
I speak sorry because one thing. That's here our university is adopting this software is Blackboard. Now this is Google Meet. This is the first time I presenting you.
No issues. We are there.
If anything is fail from my side, please forgive me because this is I'm the very young. This is my topic is the lengthwise power hazard rate distribution, some properties and application. And I said what I did here, a lengthwise version of the power hazard rate distribution is proposed and studies. And this distribution has a number of well-known submodels such as the Weibull, Rayleigh, exponential, and the linear failure rate distribution. Some statistical properties of our proposed distribution also I discuss in this talk. In addition, we also maximum likelihood estimate for the model parameters are obtained. Finally, our proposed distribution are supported by two real data example. In the introduction, we are going to give the literature review. Who the person from the where this is the beginning of this the lengthwise distribution. The statistical interpretation of lengthwise distribution was originally identified by Cox 1962 in context of renewal theory. These distributions arise in practice when observation from a sample are recorded with unequal probability. Due to this important property, we shift from original distribution to the lengthwise. This distribution arises in the practice when observation from a sample are recorded with unequal probability and provide unifying approach for the problems where the observation fall in the non-experimental repetition in the random process. This concept is found in various applications in biomedical areas such as the family history, disease, survival analysis, intermediate events, and latency period of AIDS due to blood transfusion. And this example can be found in the very famous book of Lawless, 2003, The Lifetime of Distribution. Many researchers focus on the length bias. Just I am giving this previous result. The length bias version of distribution and its application. For example, Gupta and Keating studied relation for reliability measure under length bias sampling. Khatri 1989 introduced the characterization of inverse Gaussian and gamma distribution through their length bias distribution. Gupta and Tripathi 1990 discussed the effect of the length bias sampling of the molding error. Holiday 1999 presented inequalities and selection of experiment for the length bias distribution. Dobbs and Wright 2011 studied the application of length bias generalized Rayleigh distribution. In 2012, Ratnaparke and Nibalkar also introduced the length bias log normal distribution and associated with the application. Senoy et al. 2004 developed the length bias exponential inverted Weibull distribution, and Nanwong and Buziswan 2014 introduced the length bias beta Pareto distribution and its structural properties with applications. Recently, Sagir et al. 2016 and 17 have they studied the weight exponential inverted Weibull distribution and Maxwell length bias distribution. And the Parveen et al. 2018 developed some properties of size bias with Weibull distribution and cited the reference. We begin from here. We start from power hazard rate distribution. The PDF of power hazard rate distribution is given in equation 2.4, where conditions are imposing for the alpha and the beta and the x. And the distribution function of power hazard rate distribution is given in 2.2, and the survival and hazard rate function are respectively given is 2.3 and 2.4. Here, if we look here in the equation 2.4, the power hazard, this hazard rate function, we call this is a power hazard rate. From here, we can induce our distribution power hazard rate function. Because in the many cases of the reliability, we can know the feature of the distribution using the hazard rate function. If we see from here hx alpha x beta, we call this is the power hazard rate. It has the three features, whether it depends upon the beta, whether it is a decreasing, whether it is zero, whether it is increasing. For more details and properties of power hazard rate distribution, see Mugdadi 2005 in Ismail, they focus more on this distribution and these genesis. I consider this power hazard rate distribution because it embodies the many flexible model. It changes the various parameters. If I put the several parameters changing the parameters 1, 2, 3, 4 in equation PDF of power hazard rate distribution, we can find the several distribution as listed. For if I put beta equals to alpha minus 1, we can find this is the Weibull distribution. If alpha equals to 1 over theta and beta equals to 1, we can obtain the Rayleigh distribution. If beta 0, we get exponential distribution. And beta 1, we can find linear fellow distribution. Oh, now here in this section 3, we are going to use the lane bias power hazard distribution. Power hazard distribution I explained in the section. Now, using the combine the definition of the power hazard distribution and the lane bias distribution, which is I use the definition 1. If x has a power hazard distribution with PDF fx expected value of x, then PDF of length bias distribution of x can be defined, which is given 3.1. And we can find the PDF of length bias power hazard distribution using the equation 2.1 and put in the 3.1. We can simply find the power length bias power hazard distribution. This PDF is given 3.2, and where we some plots the graph for the several value of parameters, and it is shown in the figure 1. This is the distribution function of length bias. If I write LBPHR, this meaning the length bias power hazard distribution has the form is given 3.3. Survival function also given 3.4, and this is the graph. And the figure 2, this depicts some different values of the parameters. In equation 3.5, we have obtained this a form of hazard rate of the power hazard length bias power hazard distribution. And from this fixture, what this is the important point we notice, the hazard rate function is incremental in the beginning until a certain moment, then decrease until the end of the time. This is the features from the either hazard rate distribution, survival, or the PDF. We can also depicts by this graph by figure by the different values of our parameters. And like the some models as I discussed in the power hazard distribution, this is apply for the length bias power hazard distribution. If I choose the change the several parameters, and we can find the before the works done. For example, for the length bias Weibull distribution, it is already obtained by Shaban and Odessa. My result will be also applied for this one. Setting alpha 1 over theta and beta 1. This is we obtain length bias Rayleigh distribution as obtained by Azami and Jahan Shahi 2017. Setting b equals to 0, we can also obtain length bias exponential distribution as obtained by Mir et al. 2017. My works is to combine all the previous works. If this is the generalized, this is what we call this is using the length bias power hazard distribution, we can combine these and the previous result we can be combined in our new works. Any distribution when we introduce, we have to see all its feature, whether it's a statistical properties is accepted or no, whether this is false or no, whether the mean exists, it is a complete or incomplete, how this is the shape of our distribution. All the things we have to give here. We have to check one by one. Here in this section, subsection is statistical properties for the length bias power distribution, then bias power hazard distribution. We are going to first define this the kth moment, which is given in the equation number 3.6. And this is a very simple formula. We can find the moments. Just write the formula for a expected value of any continuous and random variable. Use this formula, and from the 3.2, this is PDF, we can find after making a small substitution. And what I notice in the 3.8, this is the kth moment. If I put k will be 1, we can find this expected value of our LBPHR. And if K will be 2, this is the second moment. And the variance we can also find, this is the second moment minus first moment whole square, which is given in equation 3.11. Next, after making this measure of central tendency and the variance, now we are going to seek how the shape of the distribution, and these requirements can be met by using the technique of skewness and the kurtosis, because these the two things can do this. From theorem 1, we can compute the skewness and the kurtosis by using this relation, which is given in the skewness and the kurtosis, where mu dash k is defined. After this one, we are going to see how the distribution has a mode, whether this is a one mode or bi-mode, etc. If I see from this PDF or the graph, we found this is the only one, the maximum point. There is only the maximum point. It means our distribution, proposed distribution, has only one mode. We can do by mathematically also, just taking the logarithm of the PDF and equating, differentiating with respect to one times, equating the 0, and the second time differentiate it less than 0, we say this is the maximum. In our case, the mode will be beta plus 1 over alpha to the power 1 over alpha. After this one median, because this is not the closed form, we can take also help of the percentile technique, because the 50th percentile is the same as the median. We can use this as a relation 3.14, and from the PDF we can find the equation 3.15, and percentile can be calculated by using P equals to 0.5. Here in the table 1, we calculate some of the numerical results for fixing the value of alpha, and beta tends to 0.525. And I calculate the mean and the mode and the variance for the several disease parameters. And we have concluded from this table, the distribution is positive when the beta is less than 2.5, is negative skewness when the beta 2.5, and the distribution is decreasing when the beta increasing, and the distribution negative. All the things, all the features about the proposed distribution can be explained from this table. After the statistical properties, then another important things, we propose the distribution, then we have to also, analyze the estimation of model parameters. Yeah, because for any our proposed distribution, this must be supported by the real data example. The real data example, we must be the model parameters. I use this is the method of maximum likelihood estimation to use to estimate the parameters of length biased power hazard distribution. This is given log likelihood. This is a likelihood function is given in 4.1. Log likelihood function is written 4.2. And all people is aware this is differentiate with, we have the two parameter alpha and beta with respect to the 1 times and equate to 0. This is the estimated value of parameters alpha and beta, where xi x is the di-gamma function, which is the logarithm derivative of gamma function. Once we have obtained this is estimated value of our parameters, then we need to the confidence interval for the parameter unknown parameters. For this sake of, we calculate the Fisher information matrix. This is I11 and I12, I21 and I20 second derivative, first derivative. We are going to calculate in equation number 4.5, 4.6 and 4.7 and 4.8. Therefore, after having the Fisher information matrix, then the above approach we are going to find this is confidence interval for our estimated model parameters for alpha and the beta. We can use this as formula. Now, in the section 5, we are taking the application key where I did this new distribution, I generalize the new distribution. Whether our distribution is supported by data or not, whether our works is better than before or not. If our works is better than before did, it means our distribution is quite acceptable for this arena. If our proposed distribution it is not supported by the data, it means our result is not so fruitful and not fruitful for this coming days. Now, in this section, for this to meeting the requirement for this application purpose, I consider the two real data example. First data we take from the LALES 2003, and this data is represented uncensored data and distance between cracks in a pipe data set. This data is given the table 2. This is very famous data also. And in table 3, we can models find an estimate of the parameters of the length bias relative distribution, power length biased Weibull distribution, power hazarded distribution, and length biased power hazard distribution. We estimate its value, we estimate the log likelihood, we estimate AIC and the BIC. And this is represented in the tree. What we noticed from this table 3, our proposed distribution has a small AIC and the BIC compared to the all other the previous works. Hence, our new works, the extended works are supported by this data set. And the table 3 also indicates our model is superior than other distribution in terms of model fitting. And hence, variance and covariance matrix is also given. A 95% confidence interval we also can find this is given. And we can use this from the model parameters alpha and beta, we can find this is also the log likelihood profile of the distribution. And from here also show MLE is a unique. This is a unique, as the mod is a unique, and MLE is also unique for our distribution. Using this estimated value of parameters alpha and beta, we can generate some statistical measure, which is given in table 4. This is mean, and the mode, the variance, skewness, kurtosis is given. And I can conclude from here that our distribution is positive skewness and positive kurtosis when the condition is given. Second example, again I take the second example from the different set. Our study is more supporting, and strong reveals our study is a good. The real data set is taken from Equalator 2017. The data is represented the price of food and price of 30 children in April 1981 at Suffolk Craft Shop. The data is given in table 5. In table 5, the same things we are going to estimate, that the length bias Rayleigh distribution, length bias Weibull distribution. Why? Because these are the particular case of the proposed distribution. Along with log likelihood, AIC and the BIC I given. Once again, I see our length bias power hazard distribution has the smallest AIC, BIC compared to that. Except, and there are the few examples where one distribution is superior to other. In our distribution, the length based, I wrote this is length bias Weibull distribution superior to other distribution in terms of modeling. And if I skip this length bias, our two distribution, and our proposed distribution is superior to other two distribution. Some cases it may be happen. And from this data, we find the variance in the covariance matrix is given. And 95% control for confidence interval for alpha beta for the second data set we find. And also we estimate this is the log likelihood profile also given. Again, it is a this is unique. And using this alpha and the estimate of beta, we can some statistical measure for the second data set, which is given mean, mode, invariance, standard deviation, the skewness, kurtosis. Again, we found our length bias power hazard rate distribution has positive skewness and positive kurtosis. And in this talk, now I come to this conclusion point. We propose a new model which is called length bias power hazard rate distribution. Some mathematical and statistical properties are derived. The maximum likelihood estimate for model parameters also presented. Finally, application of proposed model to two real data sets are given to illustrate that length bias power hazard distribution can be applied quite effectively to provide better fits than other available models. And these are the references which as I use in our talk. Last and all people and the thinking go. Now I take a suggestion from all of you. Just I take a suggestion, not a question. Just I say this is a suggestion. I am the younger. Yes, I take a suggestion from you.
Dr. Rizal, thank you so much for your wonderful presentation on length biased power hazard distribution. So now, any quick question or clarification or suggestion, as Dr. Rizal mentioned?
Yes, I have a suggestion because I'm the younger than yes. You are all people as senior to me. I just need a suggestion. Yes.
Okay. I think there are no such points to your presentation, sir. Okay, you can click on stop presenting now. Srinivas sir, do you wish to ask anything? Yeah. There is one thing. Yeah, please.
Okay.
I have one suggestion. What about the ordered statistics, reliability, and other properties you are going to study, or not at
No,
the
the
return.
problem is that this is not the closed form, or distribution is not the closed form. There is a problem with this one. Incomplete gamma. The CDF is in incomplete gamma. That's why it's in. Not
So order statistics also not possible to.
not possible, yes, for this. If yes.
Okay. What about the reliability function?
Reliability function, show this is graph. You show this is graph, reliability function. So I show this is graph.
Okay. Nice presentation.
One observation I made, I want to record.
Yes, sir. Accepting, sir. Agree.
Good evening, Professor. Most of the expressions seem to be in a already familiar form. Alpha plus
yes,
beta.
Definitely. Yes, familiar terms. Yes, sir. Terms is familiar, but my work is different.
Okay.
This term is familiar. Yes. Thank you for all suggestion and thanks. Everything else, say salam from Medina. This is the holy land of this country, this kingdom of Saudi Arabia.
Right.
Yes.
Thank you.
Should I read? Okay, thank you. Salam.
Yeah. Thank you, sir. Now we'll move to next speaker, Dr. Sridevi EP. Madam is there. Good evening, madam. Please unmute your mic. After long many years, we're able to see. I'm able to see you. Good that with this event, I'm able to, and many of us are able to see you and interact with you. So before you start your talk, let me introduce you. Okay, 1 second. Hope my screen is visible.
Yes.
Yeah. So now Dr. Sridevi EP, currently working as an assistant professor in Department of Statistics, SNGS College, Pattambi, Palakkad. She pursued PhD in statistics from Cochin University of Science and Technology, Cochin. And she has a good number of awards to her track record. That Kerala State Young Scientist Award in Mathematical Sciences in the year 2016. Young Statistician Showcase Session Presentation Award for the best paper from Asia Australia region by International Biometric Society in 2012. Best Paper Presentation Award in National Conference on Recent Developments in Applications of Reliability Theory and Survival Analysis held at Pondicherry University in 2012. She has fellowships from postdoctoral fellowships, particularly NBHM and UGC. Apart from that, she has a PhD fellowship from KSCSTE, I think Kerala State Technical Education, right?
State Council, yes.
The State Council Technical Education.
Of Science and Technology.
Science and Technology Education. Okay, thank you, madam. So she has undertaken some projects as a principal investigator. One is completed, one is ongoing. Number of publications are 15, of which 14 are international, one is from national reputed journals. Number of conferences she has attended is 14, and 12 countries she has visited for paper presentation, like Japan, France, and Hong Kong. She's also...
Sir, it's not there. It's only 3. I don't know how
I think there is 12 has come down. Without presentation is 12. Yeah.
Without presentation 12, yes.
Yeah. Okay, fine. Japan, France, and Hong Kong. Thank you. Yeah, the 12 has come down. It's a continuation.
Yes, without presentation, yes.
Yeah. So she's a member of many professional bodies like Indian Science Congress Association, International Biometric Society, International Statistical Institute, IISA, that is International Indian Statistical Association, and Indian Society for Probability and Statistics. So with this a brief note on you, so we welcome you, madam, for your presentation.
Thank you, sir. Thank you.
You can start.
Okay, sir. Is it visible?
Not yet. Yes.
Okay.
Make it in a full screen. Make it in a full screen.
Yes, it is in full screen, sir.
No. Make it Control L. I think so. Control L. Does it work?
Yes.
Yes.
Okay, sir. Okay, shall I start?
Yes.
Okay, sir. Thank you. First, very good evening to one and all. First of all, I would like to thank the organizing committee for inviting me to present one of my research paper in this prestigious conference. And today I will be talking about some non-parametric inference procedures for panel count data with computer risk. This is a joint work with Dr. P.G. Shankaran from Cochin University of Science and Technology. And here is the outline of my talk. First, we will have some introduction about this panel count data. Then we will discuss about methods and inference procedures developed in this research article. Then we will show the results of the simulation studies, which was conducted to assess the finite sample performance of the proposed procedures. Then the practical feasibility of the methods is demonstrated with the real data. We can discuss it in data analysis section. Then finally, we can come to conclusions. Now, here is the introduction. Actually, we know that in survival or lifetime studies, our interest is focused upon the time to happening of some event of interest. This event can be anything like the failure of a machine or death of a patient due to a particular cause, anything. And in many cases, these events can occur repeatedly. For example, if we are considering the migraine attacks of patients suffering from migraine, it can happen repeatedly. Or the falls of elderly patients, it may also occur repeatedly. Or the failure of a machine due to some a particular reason, it may also happen repeatedly. So if the subjects in this study, we are considering the events which can occur repeatedly. Also, we know that in many cases, we may not be able to obtain the complete information on the event of interest for all subjects. If in a recurrent event study, that is, if we are considering an event which can occur repeatedly, if the subjects are monitored continuously, it provides the information on the time to occurrence of all events. We obtain recurrent event data. In many cases, the study examine only at discrete time points, since the observation is too expensive or important. As a result, we can only have the number of occurrences of the event between subsequent observation times, where the exact failure times or exact event times are not known. This type of data is known as panel count data. So this panel count data is started studying in 1980s as a special case of interval sensor data as well as recurrent event data. This panel count data is also referred to as interval count data or interval censored recurrent event data by many distinguished authors. Now, if each subject is observed only once, a special case of panel count data occurs, which is commonly referred to as current status data. Current status data is also known as interval censored case 1 data. Now, an extensive review of this panel count data is given in this book, Sun and Sao, 2013. The standard methods in the analysis of panel count data is focused on the mean function or the rate function of the underlying recurrent event process. Now, an estimator for this mean function based on isotonic regression theory is developed by Sun and Fisher in 1995. By Weller and Zhang in 2017, they developed a non-parametric maximal likelihood estimator as well as non-parametric maximum pseudo likelihood estimator for the mean function of this panel count data. Actually, these two works proposed estimators for mean function, while the rate functions are studied by Thal and Leching and Lawless and Zhang. These two functions, that is mean function and rate functions, are same. Sometimes these same. These are not same, but they are giving. They are connected each other, but they are giving different informations on the recurrent event process. Now, here is the sum of recent developments in the analysis of panel count data. And we also know that in medical and industrial studies, computing risk data arise when each patient is exposed to the risk of failure due to more than one cause of failure. Panel count data with computer risk originate when each individual is exposed to the risk of multiple events which are observed only at discrete time points. Even though panel count data is a topic of research interest in recent years, nobody has considered the analysis of panel count data with computer risk. And this fact motivates us to study the features of panel count data in a competitive situation. And also we develop an isotonic regression estimator for the cause-specific mean function of the underlying recurrent event process of a panel count competence data. And we also studied its asymptotic properties. Now, we know that in a competitive situation, it is important to test whether the effect of different causes on lifetime are identical or not, because this information will help us to identify the better treatment or better strategy in many cases, in some reliability experiments, etc. Now, in case of right sensor data, many researchers investigated this problem, this testing problem, but in panel count data, nobody has considered this testing problem. So, by motivated by this, we also developed a test statistic to test whether all causes affecting the lifetime identically. Here is the very brief introduction about this panel count data, and now we can move to the methods and inference procedures developed in this research article. Here we will discuss about the data structure of this panel count data. Now we are considering a recurrent event study on n individuals from a homogeneous population, where each subject is exposed to the recurrence due to k possible causes. Suppose that these subjects can be observed only at discrete time points, so that only the number of recurrences of the events due to different causes between observation times are available. We are unavailable with the exact lifetime of exact recurrence time of any individual. Now we suppose that now each subject give rise to a counting process nijt for each j and for each I. And here we suppose that each individual or each subject can be observed at distinct time points. So suppose that ith subject can be observed at mi different time points. That is, if the first subject can be observed at 2 time points, and the second, then the second subject can be observed at 5 time points, while the third subject at 3 time points, etc. So we use the notation mi to denote the number of observations for ith individual. Let these mi time points will be given as 0, ti1, ti2, etc., ti-mi. So these ti1, etc., ti-mi are the time points at which ith individual is observed. After this observation, we will also have the data on number of recurrences of ith individual due to cause j at each time point tip. So the panel count competence data will be of the form MIP. Mi is the number of observations for ith individual. TIP is the time of observations for ith individual, and then Ni1p, Ni2p, etc., Nikp, which gives you the number of recurrences on the ith individual due to cause j. So this is a form of this panel count competence data which we are dealing with. Now let lambda jt be the expectation of nijt, which is the underlying recurrent event process, and our aim is to estimate this lambda j. This should be yes. Our aim is to estimate this lambda jt. Now let S1, S2, etc. Sm denote the order distinct observation times while considering all I individuals together. Let Lpj and Npj bar denote the number and mean values respectively of the observations made at SB due to cause j for all p and all j. Then we can denote lambda pj equal as the cause specific mean function at the time point, at the observation time point sp. Then our aim is to estimate this lambda j sp. So clearly, due to the order restriction, this cumulative mean function will be non-decreasing, and using a max-min formula by Barlow and Robertson, we can propose an isotonic regression estimator for this lambda pj given by this equation 1. This is the very famous max-min formula which gives you an explicit form of the estimator in many other situations like current status data and in some cases of interval sensor data also. Now, under some certain conditions, we can actually in this in this equation 1, this is lambda cap pj, not lambda pg. Now, under some certain conditions, we can show that this estimator lambda pj cap t is strongly consistent to lambda pj t, and also this lambda pj cap t is converging to lambda pj t at the rate of n raised to 1 by 3, but not to the usual normal distribution, but to the maximum point of a two-sided Brownian motion, which is formally known as a Chernoff distribution. These theorems, that is, these consistency and asymptotic properties are proved in our published paper, which is published in Journal of Applied Statistics. It is given in very detail in that research paper. Now, as I said earlier, here we also propose a test statistic to test whether all causes are affecting identically on lifetime. So for this purpose, we can compare the mean functions due to different causes. So the equality of mean functions can be tested using this hypothesis given in 2. And in a case of panel count data, we can rewrite this hypothesis as H naught lambda j sp equal to lambda of sp by k for all j and for all p against lambda j sp not equal to lambda sp by k for at least one j and p, where lambda sp is the overall mean function. Now, in this to develop a test statistic for this hypothesis 3, this lambda j, as the estimator of lambda j sp, we use the equation given in 1, and to estimate this lambda sp, what we have done is we have defined LP and NP bar as the number and mean values of the observations by ignoring causes made at sp. And then we use this max-min formula to estimate lambda cap p. So this is this equation 4 is used to estimate the overall mean function. This is a very common procedure using to estimate this overall mean functions in many papers. Now, to develop a test statistic, we consider this function VJT given as given in 5, where W is an appropriate data dependent weight function, which is used to compensate the effect of censoring and to set it remaining asymptotically distribution free. This use of weight function is proposed by Pep and Mori and Lin in 1997. Now, to test the null hypothesis, in given in equation 3, we introduce the test statistic given as set tau, where tau is the largest monitoring time in the study, and v tau is the k by 1 vector v1 tau etc vk tau dash, and sigma dash tau inverse is the generalized inverse of sigma cap tau, where sigma cap tau is a consistent estimator of the variance covariance matrix sigma tau of v tau. Actually, this estimation of sigma tau is very difficult in practice, and we have to use bootstrap techniques to estimate this variance estimate of this variance covariance matrix. Now, from the asymptotic properties of this isotonic regression estimator, it follows that under H naught, the distribution of v tau is asymptotically approximated by a k-variate normal with mean 0 and variance covariance matrix sigma tau. Now, accordingly, this quadratic form set tau follows a chi-square distribution with p into k minus 1 degrees of freedom, and we can reject H naught if the calculated test statistic is greater than the table value, and otherwise we can accept this. This procedure is used in this paper to determine whether the lifetime is affecting all the causes similarly, identically. Now, we carried out an extensive simulation study to assess the finite sample performance of these proposed procedures, estimation as well as testing. First, we have to generate a panel count competence data. We consider the situation with two competent risks. So we have to generate panel count data of the form MI, where MI is the number of observations for ith individual, TIP, time of observation for ith individual, NI1P and NI2P. Now, the number of observation times, it's MI here, not KI. MI for each individual is generated from a uniform discrete uniform distribution U15. That is, the number of observation for each individual is restricted up to 5. It will be one of the values from 1 to 5. Now, once MI is generated, the observation times are again generated using one other uniform distribution U110. So the time points will be 1 among 1 to 10. Now the number of recurrences, that is Ni1p and Ni2p at each observation times can be generated from a bivariate Poisson process with parameters θ1, θ2 and θ3, for which the distribution is given in equation 7. Now a procedure something like to this is followed by proposed by Balakrishnan and Sao in 2011 in a non-computer risk setup. 3 different weight functions, Wt equal to 1, Wt equal to n, and Wt equal to lambda cap t are used in this study. We have calculated the absolute bias and MSE of the estimates of cospecific mean functions at each observation times. And for this purpose, 1000 random samples of different sizes, n equal to 100, 200, and 500 are generated. Various combinations of θ1, θ2, and θ3 are considered in this study. Actually, the results for all combinations are somewhat similar. And here we show the result for the combination, that is absolute bias and MSE of the estimates of the parameter combination, θ1 equal to 1, θ2 equal to 1.5, and θ3 equal to 1. The results are given in table 1. And here is the absolute bias for n equal to 100, that is θ1 1, θ2 1.5, θ3 1. This first column is for lambda 1 cap and second column is for lambda 2 cap. And this is the result for n equal to 200 and this is the result for n equal to 500. From these tables, we can see that both the absolute bias and MSE decreases with an increase in sample size. Also, the absolute bias and MSE values decrease for large observation times and reach at their peak around the middle observation times. And also, if it's around at the middle observation times. And now we move to the simulation studies for the test statistic. And if we set θ1 equal to θ2 and a non-zero value for θ3, it indicates that the two cause-specific mean functions are same, and hence our null hypothesis H0 will be true. If θ1 and θ2 are different, it means that the two cause-specific mean functions are different, and which results in a situation where the null hypothesis falls. As the θ1 moves away from θ2 moves away from θ1, the difference between two cause-specific mean function increases. Now we choose the parametric combinations θ1 equal to 1, θ2 equal to 1, θ3 equal to 1, and for calculating the type 1 error and different values of θ2, that is θ2 we use 2, 3, 4 and different 4 values 2, 3, 4 and 5 to calculate the power of the test. For θ3 we use 2 different values 1 and 1.5. So we can see that the first row gives you the power of the test statistic, type 1 error of the test statistic, and all other 4 rows gives you the power of the test statistic. So this from these tables, we can see that the type 1 error of the test approaches the chosen significance level when θ1 equal to θ2. That is when the null hypothesis is true. And also the test has a very good power in general, which increases as the difference between θ1 and θ2 increases. We can see that the power approaches 0 once θ2 equal to 5 for all sample sizes actually. For when n equal to 100, 200 and 500, we can see that when θ2 equal to 5, the power will be 100. Now, among these 3 weight functions, we can see that this lambda cap t gives the better power. And also, when the value of θ3, which gives you the dependence between 2 recurrent processes, increases, the power of the test decreases slightly. Actually, these observations are same in all combinations of these parameters θ1, θ2 and θ3. And now we carried out a data analysis to estimate the efficacy of the proposed method. Now, the proposed procedure is using a real data on skin cancer chemo.
Madam?
Yes.
Just a reminder, 5 minutes are there.
Sure, I will conclude. Okay.
Thank you.
We used a skin cancer chemo prevention trial given in Sun and Sao. The data was discussed in detail by many authors, and the primary objective in the study was to evaluate the effectiveness of the drug DFMO in people with two types of skin cancers, basal cell carcinoma and squamous cell carcinoma. The data consists of the 290 patients, consists of information on 290 patients with a history of non-melanoma skin cancers. And these people are coming to examination at different time intervals. And as a result, in the data set, the number of observation on an individual varies from 1 to 17. And the observation times varies from 12 to 1766 days. Now, we consider this basal cell carcinoma and squamous cell carcinoma as two competing risks and carried out this analysis. And the isotonic regression estimators for mean functions are calculated, and the proposed test procedure is employed to compare the two risks of failure. Using these three weight functions, we got this test statistics, very high values for test statistics, which clearly suggest you that the two causes affecting the lifetime entirely different. And we also plot the isotonic regression estimators of the mean functions, which is given in this figure. And from this figure, it's also clear that the rate functions, mean functions for these two causes are entirely different. Actually, this solid line represents the mean function of the number of recurrences due to basal cell carcinoma, and dotted line represents the mean function of number of recurrences due to squamous cell carcinoma. This recurrence rate of basal cell carcinoma is greater than the average recurrence rate of squamous cell carcinoma for all time points. So this makes sure that our conclusion is correct. Now I can give to the conclusion part. Here we develop some non-parametric inference procedure for the panel count data with competing risk, which is very which can be naturally erased in many reliability and survival studies. And we also use numerical methods to assess the finite sample performance as well as the practical feasibility of the method. Also, this panel count data with competing risk is not studied by many authors. And the NPMLE and NPMPMLE, that is non-parametric maximal likelihood and non-parametric maximum pseudo likelihood estimator for this cause-specific mean functions are not developed yet. Also, the cause-specific rate functions are not developed, but we have done this in one of our new paper, which is communicated now. And in further, we can also test whether the time to failure and cause of failure are independent for a panel count competence data. These problems are still unexplored in literature. Thank you. Then here is the appendix part. That is the proofs of theorem we have stated in our paper. And here is some main references. Thank you.
Thank you so much, madam. Thank you for your nice presentation with the combination of this panel count data and the competing risks.
Yes,
nice to see this theoretical structures. So quick one question, please. One question clarification or just a kind of interaction. I can allow one person, if any. Okay, I don't think so. Anyway, thank you, madam.
Thank you. Thank you, sir.
Thank you for your time and thank you for making this wonderful presentation.
Thank you, sir. Thank you so much. And I thank all the PU team for this nice.
Yeah.
Thank you, sir.
Thank you. You can stop presenting.
Okay.
So after this nice deliberation, we move on to the next speaker, Dr. Kaiser Farukdar. He was our alumni. He did PhD in Pondicherry University itself. Kaiser, are you there?
Yes, sir. Yes, sir. Good
Right.
evening, sir.
Good evening. Turn on your camera. so that we can see you all after a long time.
Good evening, sir.
Yeah.
Good evening, Kaiser. How are you?
I'm fine, sir.
On your camera.
I already on my camera. Actually, in J&K there is some network issue, so I apologize that.
Now
it is fine, sir.
We are able to see now.
Yeah, good. Nice.
How are
So-
you now? Either in Kashmir or Korea?
No, sir. I am in Kashmir only.
Okay, good.
Okay, good. So, Kaiser, before you start your presentation, it's happy to introduce you. One second. Hope my screen is visible now. Is it visible?
Yes, sir. It is visible, sir.
Yeah. So Dr. Kaiser Farukdar is a postdoctoral researcher in Division of International Trade, Institute of Digital Economy, Incheon National University, Incheon, South Korea. So he has pursued PhD in statistics from our own Department of Statistics, Ramanujan School of Mathematical Sciences, Pondicherry Central University. And then earlier to that, he did Masters in Statistics from University of Kashmir and Master of Science in Mathematics with Computer Applications, with applications in Computer Science from Indira Gandhi National Open University, New Delhi. So he has been associated with many organizations and reputed journals like European Journal of Operation Research, Pakistan Journal of Statistics and Operation Research, Pakistan Journal of Statistics, International Journal of Statistics, Optimization and Information Computing, and International Journal of Data and Development Analysis. And apart from that, he is a member of several professional bodies like International Data Environment Analysis Society, ORSI, Society of Statistics, Computer and Applications, Kashmir Mathematical Society, Indian Society for Probability and Statistics, Jangjeon Mathematical Society, and I think he is also a program committee member for this 46th International Conference on Operation Research for Data Analysis and Decision Sciences. So he's a postdoctoral researcher, Division of Internal Trade. Now presently he is in this Incheon National University. He was also a statistical scientist at first grade, Sher-e Kashmir Institute of Medical Sciences, Jammu Kashmir. He was also a teaching assistant in Department of Statistics, Ramanujan School of Mathematical Sciences, Pondicherry. Kaiser, we are so happy to have you here with us.
Yes, sir.
You can
Yes, sir.
You can make your presentation.
Good evening, one and all.
No, first you share your presentation.
Yeah, I shared already, sir. I already told you here is some network issue.
Okay.
So because of
You
that,
just share present now first. It is just at the bottom. You just share the entire screen and just minimize this browser where you are in now.
No, I have a presentation with you, Gurbadin.
Yes, sir. Yes, sir.
I'm having, sir. Then I can share it from here, sir.
No. I now it is, I think, visible.
Not yet.
Okay.
Wait a minute.
Try once, Kaiser. Try one more time. If not, we'll see the possibility. So, hope you are aware that how to present a content, right? Present now button like that.
Wait a minute, sir.
Have you sent your presentation?
Yeah, I have sent this Gulbadian. I have already sent him.
Gurbadin, you open your computer and share it from your computer. He will speak. Gulbuddin.
Sir, I will share it from here, sir.
Yeah. You share
Sir,
from
sir.
yourself.
Yes, sir. Yes, sir. 1 minute, sir. Is it coming, sir?
Not yet.
No, not yet. Yes, it's coming.
Yeah, now it has come.
Yeah, sorry for this disturbance.
Gulbuddin, you can
So
mute
today
your
I am
mic.
going to,
Gulbuddin,
Yes,
you can
yes,
mute
sir.
your
Yes, sir.
mic.
Yes, sir. Yes.
today I am going to present this study on Indian bank efficiency by using data envelopment analysis. So before that, we have to try to understand what is actually productivity and what is actually efficiency. Productivity is actually, it is based on this single input, or we can say actually productivity is total
Kaiser,
output.
1 second. Kaiser, 1 second. So if you are presenting the content in the next slide, you can tell Gulbuddin to change to the next slide, please.
You
Okay,
you just instruct Gulbuddin for changing the slide, and then only you speak. What is visible, you have to speak. You are speaking one thing and visibly another thing, it will give confusion. Okay?
Okay. Gulbuddin, you just change the slide, next slide. Yeah. So productivity is our total this output produced divided by input used. And efficiency, there are two types of efficiency. One is related to this input and another is related to the output. Input, when we try to minimize inputs in order to produce the same level of output, that type of technical efficiency, we can say it is an input technically efficiency. And another, when we try to produce more at a given level and use the given level of input, and this type of efficiency is called as output technical efficiency. And the actual difference between the productivity and efficiency is related to productivity. Efficiency is actual productivity divided by potential productivity. It is just a ratio, how much you are producing and how much should be you have to produce. Next slide. And same thing, we have to try to understand by an example. When we take two processes, maybe it any DMUs or firm, using one input and one output. Input is labor cost and output is the this throughput. And then at that time in process first, this this A is more productive than B. At that time, we are using labor cost. When we change the input from labor cost to capital, at that time you can see this B process is more productivity. So on the basis of productivity, we cannot compare the firms or DMUs. Because in some input, the one form or one DMU is productivity, and for another it may be changes to another process. So because of that, we need efficiency. Efficiency is actually combination of inputs to produce the output. And next slide. Gulbuddin, you just change the slide. And No, previous slide.
Gulbadin, what
Yes, sir.
happened?
I'm sharing it now.
Previous slide.
Not sharing. Previous
No.
slide you go.
Yes, sir. Yes, sir.
All right.
Yeah, this slide.
You make a scroll bar in a proper way.
Yeah.
Roll the
In this slide,
bar in the proper way. Right.
In this slide, when we have lot of firms producing the different inputs and outputs to different inputs to produce the output. Here there are near about A, B, C, D. These are the firms, and this is the input. Labor cost is input, and jobs or output. This is the output. And when we estimating the productivity, at that time this is the just productivity 3.5, 3.33. This is the productivity, and you can see the firm A is actually producing 3.5, but this firm should produce the 5 units of the output. So when we estimate this efficiency, that is 3.5 divided by 5, that is the 0.7. So this firm is inefficient. So at the same time, the firm C, it is actually producing the 5 units, and its potential is also 5 units. So it is then efficient. So this is the main difference between efficiency and productivity. Next slide. Now there are the different ways through which we can identify the production technology, and one of the important is the production function. Production function is the first through which we can identify our production technology. It is physical output production process to the physical inputs. It shows the maximum output to obtain from the given set of inputs. And another is the ISO count, and latest one is the production possibility frontier. Next slide. In the production possibility frontier, it shows the various combination of 2 or more goods that can produce with a given technology and resources. And actually production process is just changing our raw materials in the finishable output. And the process through which the input changes the output is called as the production. In the production process, we can make our production process efficient by 2 ways. One is that we can use minimal output obtained from a given set of inputs, and another we can use minimum input required to produce a given level of output. Next slide. You just change quickly this. And these are the methodology, efficiency evaluation methods. There are different methods. Different methods has their own advantages and disadvantages. The very first method is the ratio. Ratio is just productivity. We can just divide the inputs divided by the output, and this is called as the ratio. Then there is the regression analysis. It is another way we can try to calculate the productivity or efficiency. And there are then latest one in regression. We should have a linear combination of different inputs with an output. In regression, we can use only one output. And this is just I will share the PPT because time is going on, and they will try to study about ratio analysis, regression analysis. I will just finish this data envelopment analysis part. Just to change the slide. in frontier analysis, there are one way is parametric frontier analysis and another is non-parametric frontier analysis. In parametric frontier analysis, there is one method, deterministic frontier analysis, and another is the stochastic frontier analysis. And in non-parametric frontier analysis, there is the non-parametric stochastic frontier analysis and non-parametric deterministic frontier analysis. And then non-parametric deterministic frontier analysis is based on data envelopment analysis, and another is measure is the free disposable hull. These all measures are dependent upon the production function. What is the behavior of our this production function? Whether our inputs are independent or dependent upon the output. And error is error due to is error following any distribution, or it is deterministic. When we have a fixed inputs and outputs, in such situations we are using the data envelopment analysis. It is the case of the non-parametric deterministic frontier analysis. Just to change the slide. Gulbadin. Yeah, and this non-parametric deterministic frontier analysis does not need any particular production function. It has the two properties. One is it is a non-parametric approach, and second, it is based on the deterministic frontier. And from the graph, this is the data envelopment analysis. And here C is an efficient because C is on the frontier, and below the frontier these all DMUs are inefficient. And free disposable hull, there is one difference between data envelopment analysis and free disposable hull. In the free disposable hull, we can say that we can say here the two efficient, all the pointers between the two efficient pointers are efficient in data envelopment analysis, but this condition is restricted in free disposable hull. Data envelopment analysis is originated in 1978 by Charles Cooper Rhodes, but concept was before that given in 1954. But the same, and after that same this approach was developed by Charles Cooper Rhodes. And then different developments and different improvements came in data envelopment analysis methodology. Data envelopment, next slide. Data envelopment models are there are two types of models. One is the radial models and another is the non-radial models. Gulbadin, you just change slide. Please change the slide.
I'm changing it from here. Is it not visible?
But my side it is not visible.
Sir, is it visible from?
Yeah, it is visible. Graphical presentation of DEA.
Yeah, graphical presentation of DA. Here, there are two fundamental approaches. One is the CCR approach. There is the BCC approach. CCR approach is based on the constant returns to scale, and the BCC approach is based on the variable returns to scale approach. Here, the curve which is bisects x-axis and y-axis at the angle of 45 degrees is just CCR, constant returns to scale model given by Charles Cooper Rhodes, and the convex curve towards the x-axis. It is just the concept of BCC approach, and here D is an inefficient, and B is efficient on both the models, CCR models and BCC models. In here in variable returns to scale, it also in constant returns to scale it just gives us the efficiency, but in variable returns to scale it shows whether our DMU is efficient or not, and meanwhile it gives whether or this DMU is variable, is increasing returns or constant returns or decreasing returns. And this is the beauty of this BCC model. And CCR model is just gives our technical efficiency, but BCC model gives technical efficiency as well as the scale efficiency. Scale efficiency is it is the concept whether our DMU is too small or too large. That means they have capability to use such resources or not, or these resources are maybe small for a DMU. That is the concept of the scale efficiency. And technical efficiency is just how much the DMU has the potential to produce more and more. And there are now concept of input oriented and output oriented. Input I have already discussed, when the efficiency is dependent upon the inputs. Inputs means when we are trying to minimize inputs to produce a given level of output. That is called as the input orientation technique. And when we are producing more to restrict our inputs, given level of inputs, that is called as the output orientation. And then we have developed one measure where we have to change both inputs and outputs. That is called as the mixed orientation. And this paper was already published. Sir was the author also that paper. Sir and me has published this paper, mixed orientation concept. Next slide. Next slide. Yeah. Here is the concept of this weak efficient and strong efficient. Weak efficient G and G star. You can see G and G star. These are using same. These are producing same Y3, but using the two different inputs, X4 and X5. That means G is weak efficient because it has potential to reduce its inputs to G star in order to produce the same level of outputs. That concept is called as the weak efficiency. And later this concept was the new framework was given, that is called as the slack based measure. Slack based measures is on the base of this. Next slide. And the scale efficiency is just a ratio of constant returns to scale and variable returns to scale, and that gives the scale efficiency. Scale efficiency is just, you see there is H and E. H is efficient in constant returns to scale, and E is efficient in variable returns to scale. And the difference between H and E, that is the scale inefficiency. That is the scale inefficiency present in the DMU. Change the slide.
I have changed it. It has taken some.
And actually, data envelopment extension of linear frictional programming problem. This is the general form of the linear frictional programming problem. C transpose X plus alpha, D transpose X plus beta. And in this for this problem, we have given a methodology for estimating the optimal solutions. But DA is something different. It is extension of linear frictional programming. It is just a C transpose X plus alpha, D transpose Y plus beta, because Y is that time it is output. And for that, we cannot solve this by using the same methodology. We have to change it is scenario. We have to use transformations in order to change this linear fractional programming into the linear. Then only we can solve this type of the problem. Next slide. And that transformation are given by Charles Cooper Rhodes. Charles Cooper has given that transformation through which we can change our linear fractional programming into the linear programming, and that transformations are given here in equation T1, and the model will be the 2.2, and it is after using these transformations, and this is our linear form of this linear fractional programming problem. Just change slide. It is taking a little bit time. Sorry for that.
Okay, Vishnu.
But next slide, you just go to analysis part. I need some suggestions in analysis part, because
Yes,
that is why.
Can you make that? Yeah.
Yeah. You just Gulbedin, you just go the analysis part. Actually, once this slide will come, I will just because I want to discuss to sir. Actually, in 8th November 2016, when demonetization was happened in India, I have just collected data one decade before that demonetization, and now I am trying to calculate this data after demonetization. And I have Indian bank sector. Usually we have categorized it in 4 parts. One is first broad classification is public sector, and another then it is the private sector. In public sector, we have divided into 2. One is SB and it is associated. That is all the bank related to
wait. Yeah, now it got.
Go to the data and explain that findings and conclude immediately.
Yeah. Actually, sir, I need some suggestions, because it is what now we are working on these. I am trying to apply all these DM methodology in the banking sector, so that we can give a document shape like a scientific report, so that we will submit it RBI. So I need some suggestions. My concept in this paper, we have to calculate the data before demonetization and after demonetization, and we are trying to estimate the effect of demonetization on the banking sector in India. So in this case, we have categorized our this banking sector into 1 is the public sector and another is the private sector. In public sector, we have another classification. One is SBI and it is associated. That is all those banks which are related to SBI banks, and another is the nationalized banks. Nationalized banks are given here, and then after that, in the part of the private sector, we have some old private banking sector, old private banks and new private banks, so that we are trying to change the effect of demonetization actually in which sector of the bank. In which sector of bank will be more effective by this demonetization in this study. I am sorry for this inconvenience, because in J&K we are using only 2GNet. That is the reason this problem happened.
It's okay, fine. We can understand that. Yeah, Gulbuddin, you can stop sharing it. Kausal, did you complete it?
So here we have just shown the average efficiency. This is the efficiency estimated the decade before the demonetization, and now we are calculating more this data, and we are trying to use mole mixed index, and and we are using this slag based measures of efficiency, and we are trying to use this window analysis. Window analysis is just for this panel data. When we have the panel data, we can use the windows concept of the windows. Otherwise, we can use the mole mixed index. In mole mixed index, we are just estimating that how this efficiency changes, or is it because of technical change, or is it because of this management change. For that, we are using this mole mixed index.
Yes.
And we have used some software also here. We have mentioned it in the last stage, last slide. I am sorry for this disturbance. I have not here this given conclusion of this study, because this study is still going on. I have already told you we are trying to estimate the which sector affects more by demonetization.
Okay, fine. Thank you so much, Kaiser, for a nice presentation and giving a broad coverage of this DEA and its peripherals. Yeah. So keeping time in view, sir, can we proceed for next speaker, sir? Tirupati sir, can we
Should
proceed?
I stop sharing now?
Yes, Gulbuddin, you stop sharing.
Yes.
Yes.
Yeah. So we shall move upon to the next speaker. Is Dr. Monica Saini. Madam, hope you are there. Yes, I'm able to see you. Good evening.
Good evening, sir.
Welcome to this virtual conference. So before you start your presentation, I have a small thing to give a brief profile of yours to the gathering. Wait a minute. Hope the screen is visible now.
Yes, sir.
Yeah. Yes. So Dr. Monica Saini, currently working as assistant professor in Department of Mathematics and Statistics, Manipal University, Jaipur campus. She has completed her MSc. She has completed her MSc from KUK in Kurukshetra University, right, madam?
Yes, sir.
University, and MPhil in Statistics from MD University, Rohtak. She completed her PhD degree in sampling theory from MD University in the year 2012 under the University Research Fellowship. She has published more than 50 research papers in various national and international journals and practiced and participated in more than 40 conferences in India and abroad. She is currently guiding 4 PhD students and 1 student awarded PhD degree under her guidance. Her area of interest are reliability modeling and analysis, sampling theory, biostatistics, reliability estimation, and data analysis. She is a life member of many professional bodies. So this is a very short note about Dr. Monica. And so with this, I hand over the platform to Dr. Monica to make her talk.
Thank you, Dr. Vishnu Vardhan, for nice introduction.
Yeah.
So my screen is visible?
Now it is visible.
Okay, thank you, sir.
You can make it in a slideshow and presentation mode.
Okay, sir. Done, sir?
That's fine. Yeah, you can start.
Okay, thank you, sir. Before starting my talk, I am thankful to Professor Tirupati Rao, sir, for providing me a great opportunity to present my research work on this great platform. I am also thankful to my teacher, Professor S.C. Malik, for motivating me to work in various areas of statistics. The title of good evening to one and all. Title of my presentation is Performance Analysis of Evaporation System Industry using RAMD analysis. These are the outline of my presentation: introduction, some fundamental concepts, system description, notations, assumptions, RAMD analysis, sensitivity analysis, discussion and conclusion, decision making inference, and references. In the present era of science and technology, the market value of any product or item is measured by its reliability. Reliability is the most important characteristic of the product or a systems. The role of reliability is visualized in our daily life from switching on the bulb to the use of car or a mobile. In all these jobs, the customer expects that this equipment perform their intended function properly with full efficiency. But sometimes we found that system product does not able to provide the service according to expectations. Due to the advancement of technology, all industrial manufacturing, home appliances, and medical equipment configuration becomes more complex. So reliability evaluation of such complex system needs lot of computational work. Generally, maintenance staff of system not able to perform such computational work. So requirement of such techniques felt which can be easily implemented by laymen. Many researchers developed several techniques to measure the reliability, maintenance policy, and performance of the system. In this work, we propose technique, namely RAMD approach, which require elementary concept of reliability and probability theory to assess the performance of the system. RAMD investigation of complex system is very helpful in identification of possible designs. These improvements are required to enhance the reliability, mean time between failure, and availability of the system. The performance of the industrial system depends on the component performance. Hence, it becomes necessary to identify the most critical component and implementation of some maintenance strategies on these components. To execute a maintenance plan successfully, it becomes necessary to analyze each and every component or subsystem of the system. Among the various tools of performance modeling, RAMD analyzes the system at different stages. With the help of RAMD examination of the system, significantly performance measures can be obtained. Actually, these results are helpful for maintenance manager to plan maintenance roster for the system. Next is the system effectiveness flow chart. Performance or effectiveness of any system or product can be measured by using these indicators. Broadly, system effectiveness can be divided into three parts: operational readiness, mission availability, design adequacy. Mission availability further divided into two parts: reliability measures and maintainability measures. Reliability measures can be in reliability measures we can calculate availability, reliability, cost analysis, and maintainability measures we can estimate mean time to repair, preventive maintenance, and corrective maintenance. This is a pictorial representation of some process industries. These are the example of some process industries in which RAMD analysis can be used, like process industries like marine power plant, thermal power plant, sewage treatment plants, paper and pulp industry, piston manufacturing plants, paint manufacturing plants, computer system, agriculture system, medical equipment and reliability, and sugar industries. These are the few examples of process industries. Next is the literature review. There are many research studies in the literature that deals with the reliability of industrial systems using various techniques. I include few of them are here. Next is the some fundamental concept. First is the exponential distribution. These are the fundamental concepts which have been used in my presentation. First is the exponential distribution. Exponential distribution is a continuous probability distribution, and this is the PDF of the exponential distribution, and it is one of the most discussed failure distribution of the engineering systems. And next is the reliability. Reliability is defined to be the probability that a component will perform a required function for a given period of time when used under stated operating condition. This is the formula for reliability, and if our failure rate follow the exponential distribution, the reliability is equal to e raised to power minus theta t. Next is the mean time between failure. Mean time between failure is basically average time between the failures, and the system reliability increases with the increase of mean time between failure. For an exponential distribution, the mean time between failure is equal to 1 by theta. Next is the mean time to repair. Mean time to repair is basically reciprocal of the system repair rate. Mathematically, mean time to repair equal to 1 by mu, where mu is a constant repair rate. Availability is defined as the probability that a component is performing its required function at a given point in time when used under stated operating condition. Availability can be calculated with the help of mean time between failure and mean time to repair. Next is the maintainability. Maintainability is basically the probability that a failed component will be repaired to a specified condition within a period of time when maintenance is performed in accordance with prescribed procedure. Mathematically, the maintainability for the industrial system is expressed as 1 minus e raised to power mu t, where mu is a constant failure rate. Next is the dependability. Dependability as a design parameter. It measures the performance using average failure rate and repair rate with the help of reliability and availability. For exponential distribution, the dependability ratio is calculated by using mean time between failure and mean time to repair. High value of dependability ratio represents the necessity of the maintenance, and dependability minimum value can be calculated by using this formula. Next is the Markov process. It is a special type of stochastic process that has memoryless property. What is memoryless property? Probability of transition from one state to another state depends only on the present state, not on the past state. Next is the fundamental concept about the configuration. A system can be configured in many ways. Like one is first is the like series configuration. In series configuration, n components, we have n units or n components. All units arranged in a series manner. And if the failure of one component means the failure of the complete system, and reliability of the series system is equal to the product of the reliability of their components, and the reliability of complete series system is less than the reliability of the weakest component. Next is the parallel configuration. Parallel configuration is basically all the units are connected in a parallel mode. The failure of the system occurs only when all the units of the system fails. Next is the series parallel configuration. First, we arrange our units into series order after we arrange in a parallel mode. And next is the parallel series configuration. First, we arrange series in a parallel mode. After that, we arrange in a series configuration way. K out of n configuration. K out of n configuration is like system operates if at least k out of n units function. And if for series, if k for series structure k equal to n, and for parallel structure k equal to 1. Next is the redundancy. Our main objective is to increase the reliability of the system, and it is not possible to create highly reliable component, or the cost of the manufacturing such component is very high. So one way is to use the concept of redundancy. Redundancy is basically the provision of parallel path, and in a system of complex nature, redundancy can be applied at various levels. This is the one form of redundancy configuration is called the cold standby redundant configuration. It is to increase the reliability of the system. So in cold standby configuration is like this is a picture, this is a figure of the standby redundant configuration. In standby redundant configuration with n units, only one unit is online at a time. When it fails, it is replaced manually or automatically by a standby unit. Okay, this is the sugar production. This is the whole layout of the sugar production plant, and in my presentation, my totally focus on evaporation system. What is this evaporation system? The evaporation system is used to clear water from the juice gotten from clarifier system. All the cells are arranged in a series configuration. Evaporation system consists of 3 subsystems. Rate of all the subsystems are exponentially distributed. This is the my system description. I have already discussed that evaporation system has 3 subsystems. System one have 2 units arranged in a parallel in a parallel mode, and system two have 2 units. One is operative and one is cold standby unit. And system 3 is configured as 2 out of 4G, means the system works when 2 units are in a good state. These are the notations which I have used in my results or a presentation. And X, Y, Z represent the full working state of the subsystem, and beta 1 represent the constant failure rate of subsystem 1, beta 2 represent the constant failure rate of subsystem 2, beta 3 represent the constant failure rate of subsystem 3, and mu 1 represent the constant repair rate of system 1, mu 2 represent the constant repair rate of subsystem 2, and mu 3 represent the constant repair rate of subsystem 3. These are the assumptions. My model is based on these particular assumptions. First assumption is proper and sufficient repair facility available with system immediately. Second is distribution for the failure and repair rates considered as exponential. Third is system performs as new system with full capacity after the repair. And next is the two types of failure cannot occur simultaneously. So my model is developed under these assumptions. And first is the subsystem 1. Subsystem 1 is the evaporator. And evaporator system has 2 parallel units. The failure rate of both the units are same, and the failure of both units causes the complete failure of the system. Figure 1 shows the transition diagram of evaporator. Initially, both the units are in a good state.
Madam?
Hanji sir?
Sorry for interference. There's 5 more minutes to conclude this. 5 more minutes.
Okay, sir. This is the transition diagram of evaporator. And next we construct a transition diagram for syrup sulfator. And syrup sulfator has 1 operative unit and 1 other unit is a cold standby, and the failure and the repair rate both are constant. And next is the subsystem 3. Subsystem 3 is a sulfated syrup, and the configuration of sulfated syrup is 2 out of 4G. It has 4 similar units and same failure and repair rate. Failure of any one, then 2 units causes the complete failure of the system. And here we assume that our failure and repair rate follow the exponential distribution. Failure and repair rate is a constant. So for system 1, 2, 3, we assume failure rate and the repair rate. And next is the RAMD analysis. Mathematical model of subsystem of evaporation system is formulated, and Markov-Bardet process have been opted to develop the Chapman-Kolmogorov differential equation. Various failure and repair rate associated with subsystem are shown in table number 1. And next we calculate the RAMD indices for subsystem 1, and these are the differential equation of subsystem 1 are derived by using the transition diagram 1, and using initial condition and taking t approaches to infinity, equation 10 to 12 get reduced at the linear equation, and by using the normalized condition we calculate the value of probability of P1, P2, P3, and I skip the calculation part. So directly I use the formula. I use the expression for the write the expression of availability. Availability for the subsystem 1 is this is equal to 0.98, and this is availability depends on availability is calculated by using P1 and P2 state, because P3 is our failure state. And next we calculate the reliability of the subsystem 1, and maintainability of the subsystem 1, and calculate other performance measures like mean time between failure, mean time to repair, dependability, and minimum value of dependability. Okay, next is the RMD analysis for subsystem 2. Same type of steps we perform for system 2. First, we derive the differential equation of the subsystems, and using initial condition and taking t approaches to infinity, equation 20 to 22 get reduced to a linear equation, and we calculate the value of P1, P2, P3, and we calculate the availability for system 2. We calculate the maintainability and other measures of reliable performance measures of system 2, mean time between failure, mean time to repair, dependability. Similarly, we calculate we perform the RMD indices for system 3, and system 3 is 2 out of 4 configuration. These are the differential equation. These are the differential equation are derived using the transition diagram, and by using the initial condition and taking t approaches to infinity, we calculate these differential equation reduces to linear equation, and by using the normal condition, we calculate the value of P1, P2, P3, and availability. We calculate the availability by using P1, P2, P3. P4 is our failed state. And next, we calculate the reliability for the subsystem 3, maintainability for subsystem 3, and other performance measures for subsystem 3. In the previous slide, we calculate the reliability for subsystem 1, 2, 3. Next, we calculate the system reliability. System reliability means whole evaporation system reliability, and all subsystems are connected in a series mode. So reliability of the system is equal to the product of their component reliability. And next, we table 2 show the variation of the reliability of subsystem with time, and we observe that if the time increases, the reliability of the system decreases. And similarly, we perform the system availability, and similarly we perform the system maintainability. System maintainability means maintainability of whole evaporation system, and we check the variation with respect to the time, and we observe that increases, maintainability value increases. And next is the system dependability. We calculate the system dependability of whole evaporation system, and this is the summary of all the RMD indices for systems as well as subsystems. Okay, next we check the effect of failure rate of failure rate on subsystem as well as system. So we observe that if the value of the failure rate is increased, the reliability of the system decrease as well as subsystem. Similarly, we check the effect of the failure rate on our second subsystem and as well as system. And similarly, we observe that if the failure rate increases, reliability of the system decreases. And we perform the effect of failure rate on our third subsystem. And here we also observe that if we substitute different value of the failure rate, and if we increase our failure rate, the reliability of the system decreases. Next, we perform the sensitivity analysis. Sensitivity analysis is a technique that is used to determine how independent variable value will impact a particular dependent variable under a given set of model assumptions. So for sensitivity analysis, we partially differentiate our system reliability equation with respect to beta 1, beta 2, and beta 3, and beta 2, beta 3. Beta 1, beta 2, and beta 3, we substitute the value of beta 1, beta 2, beta 3 particular values, and we draw a sensitivity analysis graph with respect to the time. Yellow line show the sensitivity of the third component, and we observe that the sensitivity of the third component is very high. Next, last is the discussion and the conclusion, and the reliability value of the subsystem 3 at all the given time point is very low. Therefore, it needs special attention and maintenance policy with critical observation. And the reliability of the subsystem is high at various time points, but due to the series configuration, the system reliability is very low, and the system reliability is highly sensitive to failure rate, due to which it becomes necessary to handle subsystem sulfated syrup with high attention. Hence, it is concluded that the proper maintenance policy should be opted, and some redundant techniques may be applied in the designing of the system to enhance the reliability of the system. So we draw some type of conclusion that in this presentation we develop a model for each subsystem of evaporation system under certain condition and apply RMD approach that reduce the computational work. Implementation of RMD is simple in comparison of the other existing techniques. This model is helpful for managers, engineers to analyze the performance of the system effectively. And the one important thing is that the system manager also can determine the most sensitive component of the system. These are the references which I was used in my talk. Thank you.
Yeah, thank you. Nice one, elaborated and detailed way. Okay, good to see this work on RMD analysis.
Thank you, sir.
Yeah, thank you, madam. Thank you for a nice presentation.
Before going to that, welcome, sir, Professor Raghavan, sir. Welcome, sir, Professor Raghavan, sir.
Please unmute, sir, Raghavan, sir. Yeah.
Turn on microphone.
Yes, sir.
Welcome for today's session. Sir, on your camera. Yeah, right.
Yeah. You are audible, sir. You are audible.
Welcome, sir. Welcome. Now let us complete this session, sir, and we will come to you. Thank you, sir. Right. Carry on.
Yes, sir. Thank you. So, quick one question or suggestion or clarification, please, on presentation of Dr. Monica Sen.
Okay, thank you, Dr. Monica Sen.
Okay.
Your presentation is very nice and thought-provoking talk. That system reliability. Where you did your doctor program?
From MD University, Rohtak, Maharishi Dayanand University, Rohtak.
Oh, who is your teacher? I think teacher is watching your program. Your teacher is watching your program. Good.
Yes, sir.
Good. Very nice. The very thought-provoking, and you are making play with reliability theory with the parallel systems, series systems.
Yes, sir.
Oh, nice work.
Thank you, sir. Thank you.
Thank you.
Thank you, Dr. Vishnuvardhan.
Yeah, thank you so much. Yeah. If you remember, I was the chair for your talk in Utkal University, Bhubaneswar also.
Yes, sir. Yes.
Yeah. That's nice. So, welcome, Raghavan, sir. Hope you are doing well. This is Vishnuvardhan. Happy to see you after a long time, really long time. And I think 2 years over, you have visited our department.
Sir is now 80 plus, sir.
Yes, 80 plus.
They are still active because of the inspiration of his teacher, C.R. Rao.
Are you able to see me?
Yes, sir.
Yes, sir. You are visible. Okay. You are visible and audible also.
Okay.
Right.
Okay. Can I now start?
Wait a minute, sir. Before you start, I need to introduce you.
Okay.
There is an introduction about you.
Very good.
It's my privilege and honor, a kind of a privilege to me to introduce you, sir.
Master, నేను ఇప్పుడు టాక్ అవుతుంది రాఘవన్ రెడ్డి నేను తర్వాత మాట్లాడతాను.
I'm just sharing. Yeah, now hope the screen is visible now. So he's Dr. Young T.S. Raghavan from the picture, but still you are still young, sir, with your voice and academic assignments. I'm so happy to see you again. Today sir is going to talk about assignment games. Now is Emeritus Professor of Statistics in University of Illinois, Chicago, USA. So he got his PhD in 1968 from the reputed Indian Statistical Institute, Kolkata, under the guidance of Professor Kalyampudi Radhakrishna Rao, that is what we generally call C.R. Rao. And initially worked as a lecturer in mathematics at the University of Essex, England. In 1969, he moved to Chicago, and from 1969 onwards, he has been at the University of Illinois at Chicago, where he single-handedly introduced several graduate courses in game theory based on his researches in cooperative and stochastic games, and also initially based on his book, Some Topics in Two-Person Games with the T. Parthasarathy. The book became very popular all over Eastern Europe after an immediate translation into Russian language by the Moscow University in 1973. He has toured and lectured as invited and plenary speaker in several international game theory conferences and research centers in England, Germany, Netherlands, Switzerland, Belgium, Russia, Brazil, Australia, Japan, Taiwan, Israel, and many to go. Okay, his main research work is in game theory and is in one of the algorithmic aspects of game theoretic solution concepts, and this research was fully supported by the National Science Foundation under the project Existing Theorems and Algorithms for Cooperative and Stochastic Games. He has guided 12 students, and many of them have become internationally famous as researchers. Just to mention a few names: Marvin Trott, University Scholar, Kent State University, USA; J. Filler, Distinguished Professor, Flinders University, Australia; Ravindra Bapat, President, Indian Mathematical Society in 2007, Professor of Indian Statistical Institute; Thomas Solmercy, Associate Editor of International Journal of Game Theory, a Professor of Budapest University, Hungary. His book with R.P. Bapat on non-negative matrices and applications, which was published by Cambridge University Press in 1996, as a new paperback edition in 2009. He organized several international conferences right at his department, and many of the plenary speakers like Lloyd Shapley, Roth and Mason of 1992, and Bob Foreman 1994 are now Nobel laureates, and he jokingly says that his conferences are springboards for Nobel Prize. He has edited several conference volumes, notably one in honor of Shapley, the topic of stochastic games and related topics in the year 1980, and many in Annals of Dynamic Games and conferences at Indian Statistical Institute, New Delhi. He retired from the department in 2011 and is currently a professor of emeritus. He continued to guide students for research, and he had two students, Brian Powers and John Hadwick, completed their PhD thesis in the areas of final offer arbitration in 2016, and measuring relative power of couples in marriages and the problems of matching and divorce via the nucleolus of the induced cooperative games by John Hadwick in 2017. His mathematical genealogy tree has currently 115 descendants. So this is very short profile of yours. Okay, we try to make it very crisp so that we can reach you to your talk on a live session. So very most welcome to this virtual conference once again, sir.
Sir, it's my privilege to invite Professor Raghavan Saab. He's right now from Chicago, University of Illinois at Chicago, and sir is now on the day side. We are on night side of the globe, and sir has a very energetic and enthusiastic, and number of times he visited our Pondicherry University, and he is our one of the most vibrant admirers, and really we are very much grateful to you, sir, to be on the desk of this virtual conference, and we are really privileged to your presence, sir. Thank you very much for your time and valuable sharing of your ideas, sir. Please welcome, sir. Please welcome. This is Tirupati Rao, sir.
Okay, thank you. Now, first and foremost, I would like to thank the organizers of this unique virtual conference at Pondicherry University, initiated and organized by Dr. Tirupati Rao and his excellent faculty colleagues in honor of my thesis advisor, Professor C.R. Rao. the greatest living statistician in the world. He is now past 100. I am recalling my graduate school days. In 1962, when I joined ISI as a research scholar, he encouraged each one of us to find one's own research area. In April '66, I submitted my PhD thesis in the area of game theory and positive operators. And within a few days, he had a call from Professor George Barnard, the famous frequentist, looking for a young faculty at the University of Essex. C.R. Rao just made a phone, on his phone call, he immediately called me and he said, Raghavan, you are going to Colchester and joining Professor George Barnard. That set my pace for my life. And whatever I am, it is only because of him. Guru Brahma, Guru Vishnu, Guru Devo Maheshwaraha, Guru Sakshat Parabrahma, Tasmai Sri Guruve Namaha. So all my prayers for his long life.
Salutes to the teacher.
Yeah, with this, I start my talk. Okay. I want to put my, just a minute. I want to put my
presentation, sir.
Yeah, yes, I'm putting 1 minute. Are you seeing that?
Not yet, sir.
Not
yet.
Not yet. 1 minute. Slide.
Welcome, sir, Professor Suresh Diamond. Welcome.
Yeah. Okay.
Professor Suresh
1 minute.
from UK, London is also joined, sir. Thank you, sir.
Okay. Very nice. Oh, just a minute.
Okay.
Slide. Monitor from beginning.
Present now.
Yeah, are you able to see now?
No, sir.
Huh?
No, not yet, sir.
Sir, you have to select.
Sir, there is in the bottom right,
Yeah.
there is a button called Present Now. In the bottom right of the Google Meet.
Bottom right?
Yes, sir. Present Now button is there.
Huh?
Present Now button. Present Now button will be there with up arrow.
With up arrow. No, I'm not seeing that.
Extremely right side lower, sir. Extremely right side lower, sir.
Vishnu sir,
Just a minute. Let me.
Yeah, Ganapati.
Yeah.
Shall I coordinate?
Bottom.
No.
Okay, fine. No issue, sir.
He has to bring the cursor down. Cursor down.
Yes.
Then it will pop up the bottom screen. You just the arrow down.
Just.
Sir,
I'm not seeing even the cursor.
sir, just shake your mouse, sir.
Huh?
Just shake your mouse.
Yeah.
You just person now is there. Right side corner, down side.
Yeah.
You just click that one. Present now.
Privacy update. No.
Present now.
Sir, excuse me, sir. Sir,
Yes.
should I present, sir? You can just tell me when to.
Ishan,
Okay,
you have his presentation.
I'll do that, sir.
You have his presentation?
Yes, sir.
Yeah, then do it. Yeah. So one of our students will present present your content. You can just tell him to go to the next slide upon the completion, so that he can move according to your directions.
Okay, but are you able to see me?
Yes, sir. We are able to see you. Yeah.
Okay, then that's fine. Then that's okay.
So this is the slide, right?
Talk now.
Are you able to see?
So start with the first.
Sir,
with the
you are
first
able to
slide.
see the.
Yeah. Start with the first slide.
Ishan,
Now
next
the
slide.
topic.
Okay, yeah.
Topics. Yeah.
Yes. The topic is assignment games and 29th November 2020 Pondicherry University. go to the second slide.
Yeah, it is in second slide.
Yeah. This is the how to measure the individual
second slide.
Shapley value and the nucleolus.
Poisson. Go down, right? Keep it here.
Yeah. Okay. How to measure the individual contribution of participants in a coalitional venture? And that is the question. And game theory offers two unique single point solution concepts. They are the Shapley value and the nucleolus. You can think of Shapley value as similar to, see, when in statistics, for the measures of central tendency, we use two measures. One is the mean, the other is the median. So roughly like mean is Shapley value, roughly like median is the nucleolus. It's not quite that. Now to motivate this two basic notions, even though our concentration is going to be more on nucleolus than on Shapley value, I still want to talk about Shapley value. So go to slide 3. Lawn mowing game. Do you see that?
Yeah, yeah.
Okay. So there are 3 persons. Think of the first guy as myself, the second little girl as my daughter, the third one with the bikini, my wife has nothing to do with that, is my wife. You can imagine the 3 people. So we are the 3 who are mowing the lawn in the house. Every weekend we need to mow the lawn, and my next door neighbor actually offers us at the end of mowing the lawn a cake to be shared by the 3 of us. The real problem is I am the only one who can mow the lawn, in the sense I can start the engine and more or less complete half of the lawn myself with nobody's help. But I cannot do more than that. I can ask my wife or my daughter to come. If my daughter comes, she can help me. Jointly we can finish 3/4 the lawn. And then later if I call my wife, if she comes, then she can finish the whole lawn. So in some sense, the data induced TU game. Go to the next slide. Induced TU game. I am summarizing the same thing. Raghavan can mow half of the lawn. Raghavan with Usha can mow entire lawn. Raghavan with Deepa can mow 3/4. Raghavan alone can start the lawn mower. So the 3 of them can also mow the entire lawn. So I am trying to write down a function which represents this. The worth of Raghavan is half, namely he can finish half the lawn. The worth of Raghavan with Usha is 1. They can complete the whole lawn mowing. Raghavan with Deepa is 3/4. Deepa alone or Usha alone is 0. Or Deepa and Usha together also is 0. The 3 of us is 1. Now what Shapley says is, how do you reward the people for their skills? So move to the next slide, random arrival. So what Shapley says is a very simple procedure. You choose a random way by which you arrive the lawn and take away whatever you have contributed as marginal contribution. So suppose, look at the very first row. I am arriving first, next my daughter arrives, next my wife arrives. So before me, nothing was done. After me, half of the lawn was mowed. So I take half. I have already completed half of the lawn. Myself with my daughter, we have finished 3/4 the lawn, which means her marginal contribution is 1/4. The same way, my wife's marginal contribution is 1/4, provided this is how we arrive. So look at the very last one. The last of these 6 cases is, first my wife arrives. She is looking at the lawn, but nothing can be done. My daughter comes. She is also looking at the lawn. They cannot start the lawn mower. Then I come. So the 3 of us join together. We completely mow the lawn. So the marginal contribution of my wife is 0. The marginal contribution of my daughter is 0. My contribution is 1. So if you average over all such marginal contributions, That is what is called the Shapley value. And put the slide 6. It says
slide 6.
Slide number 6. Shapley value for lawn mowing game.
All right.
Using the Shapley value.
6. What you are saying? You are not saying the number?
Huh?
No, just okay. Carry on.
Shapley value for lawn mowing game. Look at that one. Because of the 25 minutes restriction, I have cut down some of the slides. That's the reason. The most recent one which I sent to you is the one which contains this. Raghavan deserves 19 pieces. Usha deserves 4 pieces. Deepa deserves 1 piece if the cake is cut into 24 pieces. So that is the Shapley value, namely 19 out of 24, 4 out of 24, and 1 out of 24. Do you get it?
Yes, sir. Go to next slide.
Yeah, I move to the next slide, which is Ricardian economy. Do you find it? Slide number 7. Do you find it?
Sir, are you visualizing your slide on the screen?
Now, are you able to see?
Sir, are you able to see the display?
Yeah, I am able to see the display. Not yours.
No. That our display, are you able to see?
No.
Why?
I'm not able to see your display. I'm only seeing my display.
No, sir. You stop your display, sir. Stop your display.
Okay. Yes.
Now you guide us, sir. Which slide you want?
I cannot see the until you show me the slide.
Yes, slide is
Can
going
you go to
on.
the next slide.
Slide is going on, sir.
But I am not seeing it.
So he has to come out from the slide, so no? Vishnu?
Sir,
How do I
Raghavan
see your
sir?
slide?
Raghavan sir?
Yes.
Sir, now are you able to see the PowerPoint which is in the display mode?
In our system.
In our system, not...
Mohammed Isham, turn off captions, raise hand. Turn on.
Sir, it should be on your like. Okay, sir. I'll do one thing, sir. So just wait. I'll just stop sharing. I'll put it back.
Isham.
I'll just stop sharing and then put it back again. So it will come on.
Yes. Do that again. Yeah. First you stop presenting and again redo.
Just a moment, sir.
Yeah.
Just a moment.
Yeah.
Oh, had you stopped at your end?
Sir has done it, sir.
Raghavan, sir.
Yes.
Had you stopped your display there at?
Yeah, I have stopped my display.
Close
all tabs.
Now, please wait, sir. Please wait, sir.
Sir, he closed his, sir closed his tab, I guess. Okay. He should be joining. 1 minute.
I will call him.
Wait, Isham. Sir will join. So keep this like this one.
Yeah.
Isham, you can mute your mic.
Yes.
Lena?
Isham, for time being, you can stop presenting. Let's all join, then you can do that.
Sir, Sir is there on the line. T.S. Raghavan. Hello. Sir Raghavan, sir. Yes, he's coming. Sir,
Yeah.
Raghavan, sir. Raghavan, sir. Right. You don't do anything, sir. You keep it like that. You keep it like that, sir. Now we will display your thing. You please be like that. You please be like that. Right. Now, Hisham, start the slow. Start the steering. Hisham.
Yeah. Okay, but I need to see my slide.
Yeah, sir, it will be shown to you, sir. It will be shown. It's in the presentation now.
Sir, now are you able to see, sir?
I am only able to say Muhammad Hisham is present, something.
Yeah, so now it will come, sir. Next it will come. Next you will be able to see that.
Yeah, I am able to see now.
Yes,
Now go to the next
fine.
one. Now move on to the slide. Finish. Next slide. Next slide. Next slide. Next slide.
Do it slowly because there is a fraction of delay there. Okay, do it slowly.
Now, the Shapley value has a formula by which we got it. So move to the next slide. Now this is the Shapley formula. We don't need it. Go to the next slide. Okay. Now I want to start with. So there is something which is missed in this one. That is the so-called I wanted to define the nucleolus. I sent the file. Somehow that is being missing. But let me explain to you. Start with this simple example. Are you able to see the example?
Yes, sir. Yes, sir.
Okay. So you have a horse market with 6 sellers and 5 buyers. Has their own price expectation, and each buyer has their own price ceiling. Now the question is, how many horses can be sold if all horses look identical? All of them look identical. So there is no sense in having different prices for the different horses. So given this constraint, what is the price at which the horses will sell? A third person says what price P equals 39. Then you find 1, 2, 3, 4, 5 people, 5 sellers are willing to sell at 39. There are only 3 buyers who are willing to pay a price of 39. So the number of sellers is more than number of buyers, which means the supply is more than demand, which means the price has to come down. 38 they try, again it's hopeless. 37 it clicks. The price 37 is what is called price at which the market demand equals supply, and that is what's called the competitive equilibrium price. Equilibrium price is in the core. So the notion of a core I have to explain. Move to the next slide. Move to the next slide. Okay. Suppose you have n players. The n players, if you take any subset of them, it's called a coalition. And the coalition's worth is what they can achieve on their own is V of S. X of S is what they are being paid. X of S is the sum of Xi's over I belonging to S. If it is more than what they can gain on their own, they are satisfied. For example, if you take the lawn mowing problem, if I am given 3/4 and my wife is given 1/4, my daughter is given 0, that satisfies my constraint. Namely, I can get nothing on my own, but I am offered 3/4. Similarly, for my wife, she can get nothing on her own, she gets 1/4. The two of us can mow the entire lawn, so we decide the whole thing and we get it. Myself with my daughter, jointly we get 3/4, even though she gets nothing. So given this constraint, so it is a core element. So if everything is even given to me, that is also a core element. move to the, so nucleolus is a unique point to be selected inside the core. And what it is, I had that, is there a way I can put that file? I don't know. Okay, let us take a simple example. Maybe I will do the following. I have another way of doing it. Please hold on. Just a minute. No, it doesn't work because that file is outside. I cannot push that file here, but whatever it is, suppose you have a landlord and 2 workers. And 2 workers. The landlord will not work. He can hire the 2 workers. With 1 worker, they can produce 10 bags of rice. With 2 workers, they can produce 12 bags of rice. Agreed? Now, how do they distribute these 12 bags of rice between the 3? If you ask a layman, he will say, okay, they should split evenly. If you ask another person, he will say, oh, the last worker added only 2 bags. So the first worker and last worker, so each one should get 2, and the landlord should get 8. And a third person will say, no. The landlord can talk to the very last worker. You have added 2 bags. Previously, we were producing 10 bags. You joined and added another 2 more bags. But that is possible only because of my land. It's not because of the other land. So we share it equally. And he says that you get 1, and he tells the first worker also, you also get 1. So 10, 1, 1. You have 3 possible, what they call imputations. So which is the right imputation to be selected? Unique imputation to be selected is 10, 1, 1 for the following reason. What you try to do is offered. People immediately think what they should have got and what they got. In the case of 822, or in the case of 444, for example, the first landlord and the first worker got 8 bags. But they deserve 10 bags, so they are unhappy. Their unhappiness is measured by the number -2. So what you try to do is you arrange the unhappiness of people in an increasing order, from the smallest to the largest. The most unhappy to the least unhappy. And you lexicographically order those vectors and choose the right vector. There is only one vector which gives the lexicographic maximum, that is called the nucleolus. And nucleolus is incredibly difficult to calculate, and so is Shapley value. The substantial number of researchers in Stanford University are concentrating their effort in algorithmic game theory, and especially on computing Shapley value nucleolus for various classes of games. Can you move on to the next slide? Move on to the next slide. Move on to the next slide. Skip it. Skip this. Go to the next. Go to the next. Skip. Skip this. 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 Now come to this one. No. Previous slide. Go to the previous slide. Yeah. There are 7 boys and 7 girls. The table, the matrix here shows, the rows show the names of the boys are row 1, row 2, row 7. Names of the girls are column 1, column 2, column 7. If there is a 1, that means the boy 1 likes girl 1. So boy 1 likes girl 1, boy 1 likes also girl 2. boy 2 likes girl 2, boy 2 likes girl 3. So for example, boy girl 7 and boy 7 likes girl 7 as well as girl 6. So the 1 represents that. Now given this information, they are paired together. Say boy 1 can marry girl 1, boy 2, girl 2, boy 7, girl 7. This portion is very clear. Do you agree? Now the real question is, who is the stronger of the two after the marriage? Who is the dominating person? I want to measure the dominating power of the couple. Is it the boy or the girl? That will depend upon. So just take the same matrix and look only at the first 3 boys and 3 girls. Forget about the rest of the people. Now the first boy likes the first girl as well as the second girl. The second girl also likes the first boy. Look at the second row. The second boy likes the second girl as well as the third girl. They also do. Look at the third one. The third boy likes only the third girl. Okay? The same way, the first girl likes only the first boy. So you notice the first girl likes only the first boy. She doesn't want to. This boy knows that she is stuck with me. Agree? So he wants to kind of, you intuitively feel that he is the more dominating in that marriage. The same way, the third boy is going to be henpecked for the third girl, because the third girl could have chosen also the mate of the second girl. Great. When you look at the third column. So in some sense, I want to measure the relative dominating power. And how do I do this one? I want to use it in the nucleolus, which is computable in this case very easily for the 7x7 case, for example. How I do, that's all I am now going to show. Please put the next slide. Yes. Now what this table shows is, I have put an arrow from 4 to 1, 1 to 2, 2 to 3, etc. So just look at 2a, the first one alone. And again, remember 4 to 1, 1 to 2 I have written. Go back to the previous one. Yes. So when I look at the fourth person, he likes also the first girl. The first girl also likes the fourth person. Agreed? So first I write down, now you go to the next slide. Yes. So I put an arrow saying that the fourth boy, even though he can marry the fourth girl, he has also an eye on the mate of first boy. The mate of the first boy has an eye on the mate of second boy. The second boy has an eye on the mate of third boy. So this arrow indicates how they can twist like that. Now you introduce a source and a sink. Source is 0, sink is 8. So they are connected. Source is connected to anything which is missed. If some arrow is there, don't connect it, otherwise connect it. Now the procedure is a simple procedure. You start from the source, go to the sink, find the longest path. So the longest path is from 0 to 4, 4 to 1, 1 to 2, 2 to 3, 3 to 8. That is the longest path. Once you find this longest path, all you try to do is the source person is 1. The fourth person cannot, so it is split evenly between all these things. So the fourth person's power is 4 over 5. The first person's power is 3 over 5. Second person's power is 2 over 5. The third person's power is 1 over 5 in the marriage. So if you look at the third person, his power is 1 over 5. His wife's power is 4 over 5. So go back to the previous one. So if you look at the fourth person, I am saying the fourth person's power, this person's power is 1 over 5, and his mate, this is his mate. and her mate, his mate's power is 4/5. Even though the numbers look kind of 2, 2, 3, 2, 2 like that, you need to evaluate the nucleolus. What is the longest connection you can have is the more important thing. Now you go to the next slide. Next slide. So this is the relative power of the various people. The first person's power is 3/5. The fourth person's power is 4/5. The fourth person's mate's power is 1/5. When you add these two, it will be always 1. That kind. So this is the relative power measure of couples. And I was trying to, this is part of my student PhD thesis. He studied a whole general class of such games, very complex. There are a lot more complex things inside, but we cannot get into the details of them. And you go back now. Can you go back, further 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 back. Okay, now go to the next slide. Next slide. Next slide. Next. Next. Yeah, stop here. No, before that. Okay, you have two houses. House 1 expects, there are two houses in the market. House owner 1 wants at least $200,000. The second one, he says, I won't sell for less than $230,000. There are two buyers. Buyer 1 says, I am willing to pay at most $290 for the first house, $260 for the second house. Buyer 2 values at most $300 for the first house, $280 for the second house. So now the question is, how would they split if the houses are sold? For example, house 1 is sold to B1, house 2 is sold to B2. How should they split? So if there is a price P which is below 290, then only B1 will buy. If it is more than 200 only, house owner 1 will sell. So if P is a number between these two, so if P is more than 200, house owner 1 makes P minus 200 as his net gain. The buyer 1's net gain is 290 minus P, because he was willing to pay up to 290. So he paid only P. So 290 minus P is his gain. So the total gain of this coalition is 90. So I can write down the total gain for each coalition. Put the next slide. 90, 100, 20, 50. So these are the gains which they can get. Now, the seller can say that I want to take all the 90. Seller 1 says, I want to take all the 90, you get nothing. Seller 2 says, I want to get all the 50, you get nothing. If they do that one, you get the next one. Put the next slide. So 90, 50, 0, 0, that's what they are splitting. Now the seller 1 with buyer 2, they are looking at each other. They could have gotten 100 units to split. Now what has happened is they had gotten only 90 units. So there is a loss. So there is an conflict. So they want to grab something from the other person. There is a fight which goes on. And go to the next slide. The fight says how they move. Say they move in the direction of 0, 1, 0, minus 1. And then the next, can you push it up? Slide a little bit up. Okay. Okay. Now go to the next slide. It is, again, they come to 80, 20, 10, 30. Still they are unhappy because there are two coalitions. They are still unhappy. And now the last one, try the next one. So 70, 10, 20, 40. That's how it has to be split. That is the nucleolus value of the game. And this was an algorithm which we gave long back with one of my PhD students. And so in a sense, the computation of nucleolus is a very fundamental part of game theory. and you can do it only for some select classes of games. Assignment games is one of them. So can you put the list of references at the end, very end? Last slide. Last slide. All these things are, yeah. So the horse market is by Bombauer in the 1890s. Gale and Shapley introduced the so-called college admission, for which Shapley won the Nobel Prize. Shapley and Chubik assignment game, that's what the topic is. Myself with my student Solimosi, this is the algorithm which we published on the house market, which is a polynomial type algorithm. And my PhD student, Hardwick, he was the one who worked on the binary value, namely the marriage problem. That's all I want to say now. Thank you for this opportunity. If you have any question, you can ask me.
Very nice combination of game theory, sir, and it is an assignment game. Mostly we are having very basic level for designing the saddle point concepts, etc. And we used to follow the principles that maximum, minimum, saddle point. And we are around roaming at there only. But assignment game theory is something very interesting. And your passion makes more adding and what we call it as more aroma and flavor of the. And really, it's a very interesting concept that making game strategies, and really we enjoyed, sir. We enjoyed. Thank you very much, sir.
Thank you. Thank you. I'm sorry I had to take more time than what I am allowed.
No, sir.
No, that's fine, sir. That's fine. So every time I listen to you, I enjoy your talk on stochastic games, game theory.
Yeah.
From 2009, when I met first time at Sierra Institute.
Yes. Yes. Yes.
So thank you so much, sir.
When you visited Pondicherry University also.
Yes, sir. Sir gave.
Yeah, you have made as a matching problem of game theory.
Matching problem. Yes.
Matching problem. That is also a very nice topic.
Sir, we always look at zero-sum game.
Yes, but this is all.
No, there is no zero-sum game at all. One's loss is not the other's gain.
Yes.
This game is a different game, not the usual game that we
It's a
play.
cooperative game. It's a cooperative game.
Yeah.
And the thing is, in game theory, is split into two parts: cooperative and non-cooperative. In the non-cooperative, it is split into two parts: zero-sum, non-zero-sum. The entire modern, many of these people who won Nobel Prizes are only for non-zero-sum games, especially on Nash equilibrium, which is become very fundamental for especially modern business, especially in auction theory. The most recent Nobel Prizes are mainly for auction. So the first time, the first 1994 was given for John Nash, Harsanyi, and Reinhard Zelton. They won the first Nobel Prize for their work in game theory as an application to economics. Then Bauman won. Then Roger Meyerson won. Then Alvin Roth with Lloyd Shapley. But to be honest, I feel the fundamental work of Professor C.R. Rao, especially in statistical theory, especially in regression, is discriminant analysis. Almost everything is used left and right by the economists. I wish they understood such a deep person, and I wish the economics society recognizes, and someone like Professor Varadan or K.R. Parthasarathy or somebody, or many of these economists, they should. And at some stage, Professor Demon made all his effort, I know. Karmanyevadikaraste mapaleshu kadachana. That's the attitude which he did it. So I feel he deserves the best. I'm so touched. I went and saw him once when his wife was also there. I carried some mangoes, and that is the most memorable thing in Buffalo, New York. And recently I tried to reach him. but it is very difficult because he's too old. But my prostrations to him. And thank you for organizing this conference in his honor.
Yes, sir. Professor Damon was to something, share to something.
Yes. Please.
TES, I heard him many times. He's so interesting. He adds his sense of humor in every presentation. I met him in Spain in Baulo conference in 2000. It was the World Game Theory Conference. And subsequently in the international conference in which he played a very important role in honor of Professor Rao. And we were engaged in somewhat a campaign to get a Nobel Prize or Bharat Ratna for Professor Rao.
Yes.
Unfortunately, we didn't succeed, but we succeeded in getting a Nobel Prize for Shapley. Actually, the second conference was in his honor. And
no, in the case of Shapley, Shapley should have won earlier.
Yes. Actually, you'll be surprised, Professor Raghavan. Professor Oman wrote to me when I sent him the flyer on the second conference. He wrote a very good email. He said his contribution, Professor Shapley's contribution, is more than all combined game theorists' contribution.
True.
And actually, Professor Raghavan, I don't want to take the time of others, but actually this induced me, game theory in Pittsburgh, Jamir and Roth was there. And the Shapley's work was about the matching game for which he got the prize, Nobel Prize, that the person who proposes first gets the best guy, the matching.
Yes.
If there is a complete information. And I was working on, actually I practice in my young life in the pubs and discourse, that if you have asymmetry of information, then you can create a divergence between the information of your information and the other party's information. And by creating asymmetry, you can catch the best looking girl.
Sir,
and I was able to succeed in that in my young age.
No, that is known as the famous Gale-Sotomayor theorem.
Yeah.
Okay. In fact, that paper, I was the referee for that paper. This was a paper in American Mathematical Monthly. And it came to me. And the main thing was, the paper starts like this. Why can't women be honest? This is a famous poem by Bernard Shaw, famous line. So in a sense, if everybody is honest, there is an advantage for you to become dishonest to make yourself a little better.
Yeah.
That's the. So being honest is not a Nash equilibrium.
No, I tell you, it doesn't work. You have to create a divergence between these two.
Very good. Anyway, let's
nice seeing you and listening to you.
Okay.
So, sir's presence is creating vibrations, sir. We are enjoying from I think from last 8 years, I am enjoying this type of moments with Professor Raghavan. And whenever he is there, the total area will be galvanized. It's just a magnetic field we are having.
Sir, if this concept is extended to marketer and consumer, government and the taxpayer, I think we will have a different dimension in the happiness of the people. Whether these concepts can be given to income tax also, where the gainer and the loser are both maximizing the satisfaction or minimizing the dissatisfaction.
Okay. Yeah.
So, any other wish to interact? That is up to you. Then, otherwise, what Vishnu?
Yes, sir. Yes, sir. If anyone wishes to interact with the content given by Raghavan sir, so you can. If not, we'll move to the next speaker of our event.
That is Vishwanathan.
Sure. Yeah.
Vishwanathan sir.
See, as Professor was mentioning, in this context, just I want to add one thing. Because of that Nash equilibrium, there was a very beautiful movie called A Beautiful Mind.
Yes.
I think probably you might have come across that movie.
Yeah, we have seen that. I went with my wife.
Yeah. That movie was
first
called
time after marriage.
Oh, okay.
First time after my marriage, we both went and saw one movie. This was the last movie we saw together.
That's why you are maintaining the equilibrium. So it was a very beautiful movie which was picturized. See, because normally movies, they have to play two roles actually. One for the famous lot and another for the geniusness of Nash. And it went on like, even to some extent, it started describing Nash as a psycho in the beginning. But gradually, his preoccupation with numbers and other things, okay? And finally, he's coming out of the shell and how he got that Nobel Prize, what was that moment, and how he relished that. So everything was a wonderful thing, something like a common man like me enjoyed. I just want to share this. Thank you.
Thank you, sir. Thank you. Right. Yes, fine. So thank you, Raghavan sir, for your presence.
I just want to share my happiness or feeling to Professor. Your way of presenting things is just like teaching a complicated thing in a simple way so that the student is much interested. So the young researchers can follow you very well. Thank you, Professor. Nice opportunity to hear you. Thank you.
Thank you, sir.
Okay, now you can conclude, Vishnu.
Yes, sir. So thank you, Raghavan sir, for making your presence in this virtual conference and giving us your insights on assignment games. So now we'll move on to next speaker, Professor Suresh Dhiman. Welcome, sir.
Thank you.
Yes, sir.
So really, we are very great time to meet Raghavan and Daman on the same platform.
Now. Professor Raghavan and Professor Partha Sarthi were the first two students, PhD students of Professor Rao. And when he returned from Cambridge, I think Professor Rao told me one time when I was interviewing him that Professor Lewis was organizing a seminar on this book, Morgenstern book, Games and Economic Behavior. And John Robinson used to come and sit. She was a young lecturer, Mrs. John Robinson. And she raised the question, this is a zero-sum game, so why you want to play when nobody gets anything? So Professor Rao was telling me those story. But imagine, although he was not working in the area of game theory, and he come back to ISI and supervised those two PhD theses, first in game theory area, Professor Raghavan and amazing contribution of these two people, Professor Sarthi, Professor Partha Sarthi and Professor Raghavan, amazing. Everybody knows these people,
Yes, sir.
In the world of game theory. So mine will be just conversing for Professor Rao. My paper is a non-academic paper.
Nice.
And actually,
that will be more attractive and inventive.
And my appeal in the paper would be that this is very well done. I congratulate you that virtual conference you have done such an extensive, international conference and so many people you involved. But I think these people should start writing for the Bharat Ratna and for the the Nobel committees, to.
Sir, actually, I would like to share one development regarding this, sir. Actually, this Bharat Ratna award has to come during the Manmohan Singh, sir. But that what we came to know that there are some technical issues regarding our CRO, sirs, his citizenship. Now he is an American citizen, and that Indian citizenship, that type of technicalities are there, sir. Otherwise, during the Manmohan Singh period, it was greatly mobilized. Almost we confirmed that Bharat Ratna was conferred on our C.R. Rao. But I think there are some technical issues. Hope that issues will be resolved in near future. And Modi government is more particular about honoring this type of genius and really contributing, as you said, sir, applying the concepts of the mathematics or in a statistical thinking in economics. They got the Nobel Prizes.
Yes, I know.
Nobel Prizes. But what about this wonderful around 36 theories he has what to call it as a foundational theories, not any application theories. That are the foundational theories he has introduced. You go for orthogonal arrays, you go for directional data analysis, whatever you call that. If you apply somebody, some economics or some botanist, some genetical person, they are making using of a Devian chemistry people they are using, and they are getting the Nobel Prizes. Okay.
Yes, yes.
So of course we have some unfortunate thing that even Bharat Ratna he deserved long back, not now, long back. But that are some technical issues. But let us hope this Modi government will make it possible. We are all realizing.
Okay, thank you for doing that.
Right.
So should I put the present now?
Wait a second, sir. Wait a minute, sir. Before you start, I need to introduce you to the gathering.
Okay.
So kindly give me a couple of minutes of time. Then you can start your
All right.
talk.
No problem.
Yeah.
Our Vishnu is one of the most lovest person in our department, and he has to say something. He has to say something.
I was in Pondicherry actually for Econometric Society meeting, Indian Econometric Society meeting.
When, sir?
Okay.
This was a few years ago. I can't remember the right now.
Yeah. You spoke about Ramachandran.
The screen is visible. No, the screen is visible, sir.
Yeah, visible.
Oh yes.
So today we have with us Professor Suresh Dhiman. He is going to talk about C.R. Rao, a resurrection of a great Indian tradition. Sir is honorary director and AMP, UNAP, UNCTAD, and visiting professor, consultant, and Center for Economics and Finance. Oh, that's ampersand. Okay. He is a specialist on mergers and acquisitions and regulations, corporate governance, econometrics, game theory, and financial modeling, and other areas of real estate and finance and economics. He has received BSc, MA, MPhil, and PhD in the area of game theoretic models, methods, and applications to take over with Professor C.R. Rao as the mentor. He has a wide range of teaching experience and research experience covering a variety of courses in economics, finance, and game theory to diverse group of students, at least in India,